Hey, what's going on everyone? It is Caleb and welcome to the world's greatest Python series in the world. And we're going to go from absolute beginner all the way up to working effectively as a Python developer. So if you're brand new, this is the place to start. And why is this the world's greatest series, you might ask? Well, here's 3 reasons. 1, all of the code we go through is up online for you to reference, so you can go in here and there's just hundreds and hundreds of lines of examples that you can copy and use in your projects or just to learn or whatever it might be. So everything is up there for reference. So that's the first reason. Second reason is that this course is completely free, so all of it's up here on YouTube. And third reason, best of all, is that if you watch at least an hour of this course and you're not crazy satisfied, then we offer a money back guarantee. Just leave a comment in the comment section, and there is a refund fee. However, besides that, everything in this course is just fantastic. So where do we even begin? So when we are working with Python, the first thing you should understand is that writing it is actually very simple compared to other programming languages. But the programming language is not limited. This programming language is powerful in that you can build scripting applications, you can build user interfaces, you can build websites, and it's actually really popular in the data science and machine learning space. So the options and the opportunities are pretty much endless. And when you get started, you should know that there is an interactive mode where if you look at some of these examples, you type in an expression and you get a response back. And this allows learning Python to be a very intuitive process because you can test things and get responses immediately. However, that's just one way of writing Python. The other is to write it out in a file, and then you can run that file and get the results inside of the console. And that is what we're primarily going to be doing, is building some more file-based projects. However, when you're learning Python and you just want to try things out, you can just use the interactive mode, whatever is more comfortable for you. So I'm going to be showing you how to set up both, and then you can decide which one you want to work with inside of this series. So when you're starting, you want to go to python.org and go to downloads, and then click the latest version. Now, there is a Python 2. I wouldn't recommend going that route. However, you should know about it. It's I would say like the older version of Python. However, some people still use it today, and maybe that's what you'd be using at your work. However, I would recommend you learn Python 3, and whatever version after the 3, don't really worry about it. Just get the latest version. Mine right here is 3.8.2. So I'm going to hit that and start that download. Now, installation is super easy. You just click buttons and make sure you read all this really good content here and agree, and then install. Now, when this is installed, you're going to default with working with the interactive mode. And that is, again, where you type in something and you get a response. Then what we're going to do is we're going to later install a text editor to allow us to work with files. So for now, we'll just start with the interactive mode and just type our first program. So once that's done, we got this new folder inside of our applications, and we can go in here and there's this, oh my golly, break my eardrum, why don't you? Sorry about that, guys. Go into the idle, click that, and that's going to open up Python. So it's really tiny, so how in the world do you zoom in? Go to preferences, and I'm just going to increase this size to like 20. Nope, even more. How about 29? I'm just going to go all the way up to like 34. All right, hopefully you guys can see that nice and clear. And just to show our first example, you can do something like 5 plus 5, hit enter, and it gives us the result back. So that is your first Python example, and now you can go apply for a senior software engineer position and just let them know you learned everything from this video. They'll hire you, trust me. I'm just playing. There's a lot more to go, and hopefully this is exciting because, hey, you just made some code. So now I just want to talk a little bit about how to get the most out of this course. Again, the first thing is that all of the code is online, and if you want to find that, go to github.com/Caleb Curry. Go to my repositories and open up Python. And in here, we are currently inside of beginner Python, and we're going to start from the absolute beginning here, 01-numbers. So these are some of the examples we're going to be going through in the upcoming videos, and that'll get you started with kind of documenting your knowledge so you don't just forget it all. But I do highly recommend you go through all the examples yourself, typing them out. That's probably the number one way to take these concepts and these syntaxes that you need to know and putting them in your brain permanently versus just watching the videos. The other thing is if you're struggling or need any extra information on any of these points, the Python website has some great documentation, so just go to documentation and go to python3.x docs. And inside of here, there's a tutorial which will go through all these principles in tutorial form if you need something else. If my videos aren't good enough for you, or what you can do is you can use the documentation more as a reference if you need to know any particular way of doing something. In the next video, we are going to get started working with the interactive mode, and pretty soon we will download a text editor to start working with Python files. So stay tuned for the next episode, and the least you can do is just hit that subscribe button and completely destroy that like button and leave a comment in the comment section below letting me know what you're most excited for. So stay tuned and see you in the next one. Hey, welcome back everybody to video number 2. Good job sticking with it. You probably made it past what most people quit on video number 1, so good job with that. And not to be a motivational speaker or anything, but you can do anything you set your mind to as long as you believe you can do it. So what are we going to be talking about in this video? We're just going to be first talking a little bit more about this interactive Python, and second is just getting some vocabulary out there that'll help you in your development career. So again, if you want to get this page open, all you got to do is download Python and open the idle here, and there you go. Now, that was the first step, and what we did in the end of the last video is we did something like this, 5 plus 5, and when we run this, we get some value in return. And the vocabulary I want to share with you today is an expression. An expression is anything that gets evaluated to some value. So 5 plus 5 is an example of an expression. So if you ever have any questions on vocabulary, there's actually a useful resource in the documentation. So let me show you that, guys. Go to the documentation at docs.python.org/3 for Python 3. And then in here, there is this glossary. And you can scroll through here to find any keyword you're looking for, or you can find within the page. So we can look for expression. And there's a bunch of different ones on here, but the one I'm really looking for is the actual definition right here. And it pretty much says what I just said. They must have stole it from me. It's some syntax that can be evaluated to some value. In other words, an expression is an accumulation of expression elements like literals, names, and a bunch of other keywords that we're going to be going through inside of this series. And the thing you should try to understand here is that it returns a value. So anytime we need some value in our code, we can use an expression in place of that value. So for example, if you're writing code that is expecting a number, instead of using 10, you could instead use 5 plus 5, because that expression is evaluated and returns a value of 10, which will then be used inside of the code. And why is this important? Why am I making this more complicated? Well, the reason this is important is because it allows us to be very dynamic with our code. Instead of always typing out a value, sometimes we're going to work with a variety of values and mix them together to get a final value that will be returned and we can then use. So, maybe you're doing some calculations. You ask someone their age, and then you say age plus something else, and that is evaluated. That is what makes programming so dynamic. We can make programs that will work with a variety of different things, and it all works because we can create expressions. Now, the other thing I wanted to show you is that if you are working inside of Python and you're struggling with some concept, you can say help and pass that into here. So for example, what if I pass in the value 10? Pressing enter, we get this weird thing that says squeezed text. And basically it's just saying, hey, it outputted a bunch of information. So you can expand that and you can read all about it or get any kind of signatures that are required later on when you're doing some more advanced Python stuff. So there you go. You got 3 different resources. One is the online code for this series on GitHub, Caleb Curry. And then 2 is the documentation, the different vocabulary you can look up. And 3 is the help inside of the interpreter here. You can use that for anything you're struggling with to get specifics. So now that I've given you all of that boring information, in the next video, what are we going to be talking about? Well, now I want to start working with expressions, and I want to start doing different math things. So we did 5 plus 5, which, that's really simple, but I want to show you some more complex ones just to become more familiar working with Python, and we will use those principles for the rest of this series and the rest of our Python development career. So stay tuned, be sure to subscribe, and I will see you in the next one. Hey, welcome everyone. This video, we're going to get a little bit more experience working with numbers inside of Python. So nothing too crazy here, probably just some review of some math stuff you probably weren't paying attention to in school, sort of like me, but don't worry, we're not going to get into anything advanced, just the basics. So again, I've shown you guys this example like 3 times, but you can type a simple expression and get a value returned to us. But the plus is not the only thing we can do. And just for another vocabulary here, this plus is known as an operator. So anytime you think of an operator, just think it does some stuff on some values and gives us something in return. So 5 divided by 5, this division, that is another operator we can use. These are known as arithmetic or arithmetic operators. So 5 divided by 5, we get 1.0. Cool. What other ones are there? Well, there's 5 minus 3. There's a minus operator, which will give us 2. And then 5 times 4 will give us 20. So those are the 4 basic operations of math that you should know about. But the cool thing is we can put these in a sequence and do more than that. So for example, we could say 5 plus 3 minus 2, and that gives us the value 6. Now, we are going to talk about precedence, which is an important thing. If you remember in math, like the division and the multiplication happens before addition and subtraction. The same thing applies inside of Python and pretty much every programming language. So it's important to understand that. So if we do something like 5 plus 3 times 2, well, this is going to happen first, the 3 times 2, so we're actually going to have 5 plus 6, which will evaluate to 11. So we're going to talk about all the different precedence rules in the next video, but for now, just understand that you can mix all kinds of different operators, and it's just important to understand what order they happen in so you get the right value. The reason this is important is because, well, obviously we want to get the right value. However, when we're working with code, we don't want to have deployed applications that are working, like they run, but the actual outcome of the application is incorrect. That would be known as a logical error. A logical error is when the code works and you can give it to people to use, but the results are not giving what would be expected. So it's also known as a bug. We don't want bugs in our software. So always be careful, and anytime you can be really clear, even if it takes a couple extra steps of coding, I would recommend that just to make sure that you don't make mistakes looking at the code, or if other developers are using your code, that they don't get confused. And ultimately, it just allows for more scalable code. So the main thing you need to take away from this video are the 4 basic math operators: plus, division, minus, and multiplication. So make sure you understand the characters for each of those. The ones that you might need to just pay a little extra attention to are the division and the multiplication, as these show up a little bit different than they might on paper. So that is known as a /, and this is known as an asterisk. When it comes to the slash, you can tell if it's forward or back by the top of the slash. So this is a / where this is a backslash. The top of the slash is pointing back or to the left, and this is a / where the top is pointing forward or to the right. So minor detail, maybe I'm being nitpicky, but it's just a thing that people often get incorrect. They will call it a backslash when it's actually a / and vice versa. So those are the 4 basic operators. Upcoming next, we're going to talk about precedence rules and just how to do different things with the precedence so you can force certain precedents. So if you have no idea what I'm talking about, stay tuned for the next one, and Stay in school. Okay, that was a terrible ending. Hey, what's going on? This video is unprecedented because it's going to be so dang good, and because we're talking about precedence, which pretty much just determines in what order different operations happen inside of our programs. And this is pretty much exactly the same to how it is in math class. So if you remember this from math class, then you are good. So for example, when we say 5 plus 3 times 2, the 3 times 2 actually happens first before the plus. So it's not always left to right. And the rules is that multiplication and division happen first from left to right, and then addition and subtraction. So let's create a complex expression and try to figure out what value is going to be given. So maybe we do 3 times 2 plus 5 divided by 2 minus, or let's go with even numbers just to make it easier. Divided by 2 and then minus 1. So are you able to guess what the output is here? So what is it? 3 times 2 is going to happen first because we're looking for multiplication or division. So that's going to be 6. And then this is going to happen next, 6 divided by 2. So that's going to be 3. So really we have 6 plus 3 minus 1. So what's that going to be? That's going to be 8. Hitting enter, we get 8.0. Now, there is an interesting thing here that maybe you noticed, and I just wanted to call it out. Sometimes we'll get a whole number like 11, and then other times we'll get a number, but it'll have a .0 in it. And that's going to happen anytime we're working with operators that might return a fractional part. You know, if we do something like 5 divided by 2, well, in this situation, we get a fractional part. But if we're doing addition, there's no way for us to get a fractional part, so it's just going to give us an integer, a number without any decimal value. Now what next? The next thing I want to show you guys is that you can use parentheses to force any particular evaluation to happen first. So if we go through the same example, but let's say we want the addition and the subtraction to happen first, here's what it would look like. We would type everything out the same, but when we have any addition, we would use parentheses, and then whenever we have any subtraction, we would also use parentheses. So it looks something like so. So now the division and the multiplication is going to happen after the parentheses. So anything inside of parentheses always happens first. Press enter, and we get 24, which completely changes the answer. And another thing with parentheses is sometimes if you have something that's complex, you can throw those parentheses in there just for clarity's sake. So that way people can visually see what's happening. So like when I look at this, you know, I can figure out what happens first, you know, just because I understand which operators evaluate first. However, if you are doing something really complex, it might not be as clear. So you might just want to throw in some extra parentheses, even if it doesn't change the value. So we can parentheses around the multiplication, and then we can say plus 6 and divide that by 2, and then put the division inside of parentheses and then subtract by 1. So although the result's going to be exactly the same, visually it's much more appealing. You know, I like to look at it. It's sexy. All right, maybe that's a little bit too far. However, when you read this, you can easily see what's going to happen first. So hitting enter, and we get 8.0, same exact result. But clearly this happens, and then this happens, and then we subtract 1 from the answer. So much more visually appealing. So those are the two primary benefits of parentheses. 1, they force certain operations to happen first, and 2, they can add clarity to our application even if they don't change anything. You can use parentheses anytime, and you can even go a little extreme. I'm not saying you should do this, but you can put parentheses inside of parentheses, and it's totally okay. So I can put 5 plus 5 inside of 3 sets of parentheses, and we still get 10. So use parentheses to your advantage whenever you need to make something clearer to you or to another developer who you're going to be working with. And just coming from someone with like 30 years of development experience, you're probably not going to know what your code does in about 3 weeks. So anytime you can make it extra clear, you're going to thank yourself in the future when you have to look at that code again. So do the extra work to make sure your code is clear, but you don't have to be too extreme about it. Like, this is not going to help anybody. It just makes it look confusing. So keep it reasonable and just do whatever you can to make your code as clear as possible. So that is all I have for you in this video. We have one more video where we're going to be using the shell, and then we're going to be teaching you how to create Python files. So that is very useful if you want to do any kind of complex coding or any kind of scripting. That's how you're going to do it. So let's follow up this video with one more video talking about operators and math, and then we'll get into creating files. So stay tuned, and you better not forget to hit that subscribe button. You know it's my self-worth indicator here as a YouTuber, so don't let me down. Hit that subscribe button, and I will see you next time. Hey, what's going on, everyone? This video, we're going to learn some extremely important concepts in programming, so you better be paying attention. You know, this isn't no college class where you go to sleep. Pay attention here. What are we going to be showing you? We're going to be showing you how to round a number, which seems pretty simple. However, there's a lot of different concepts if you're new to programming that you need to learn. So when you do some operation such as 5 divided by 2, we get some value back. And this value has a fractional part, 0.5. And sometimes you don't want to be using these fractional parts, so you want to round the number either up or down depending on that value. So that's what we're going to be showing you in this video. Alright, so I'm going to be introducing a lot of different vocabulary, and the very first vocabulary word that we're going to be showing you in this video is syntax. Syntax is basically the typing rules for the language. So when I am introducing a new concept, that concept might have a specific syntax that you need to use. So specifically, we're going to say round and then put parentheses. So that is the syntax that you need to follow. It's important to follow it up with parentheses. The next keyword that you need to know is a function. And a function is just some code out there that we can give it some input and it will return a value. So it takes an input and gives us back an output. So round takes an input inside of the parentheses, as all functions are going to do, and you just put the value like so, hit enter, and we get a return of 2. So that is how functions work. And round is a function that already exists, it's part of Python, and we can use it. Now I don't want to get too much into the concepts here, however, functions are very similar to operators. So if you think of this division operator, it takes 2 inputs, 5 and 2, and then it gives us back a value, 2.5. So you can use functions in a similar way, where you pass in some data and you get a return. It's just the syntax is a bit different. Now, I just want to get some other vocabulary out on the table. Whenever we put data inside of these parentheses, that is known as passing data. We are passing 2.5 to the round function. And another word for the data is an argument. So to put it all in a sentence, we are passing an argument to the round function. Make sure you understand every word in that sentence because it's not going to change. We're going to be using that for the rest of this series and the rest of our lives. When the function gives us data back, that is known as a return. So this function returns the value 2. Alright, so that's a lot of vocabulary. Hopefully you got all it figured out and you understand how this function works. However, there's one more thing you can do with this function that's pretty cool. So if you say round and hit the first parentheses, you can see it has number and then n digits. And this is basically describing what data it expects. So the first thing it expects is a number to round, and then we have an optional one, which is the number of digits, and it defaults to the value none. So what that means is we could say 2.5555, comma, and then the number of digits that we want to keep after the decimal, we could say 1, like so. Hit enter, and we get 2.6. So that's useful if we want to keep some data, but maybe we don't want to keep a ton of numbers after the decimal. Maybe we just want to keep 2. So another example would be round, and let's say we had 3.33333, and we just kept 2. That's how we would do that. Now, if you remember back to probably the second video, I talked about expressions, such as 5 divided by 2, and how it gives us a value back. And because it gives us a value back, you can use an expression anywhere a value is expected. So that means you can do something in here such as 10 divided by 3, comma 2. So what is going to happen here? Well, very first thing is that this is going to be evaluated to 3.3333, and then we're going to invoke the round function. So hitting enter, we still get 3.33. So now you're starting to see the different things we can do with these expressions and why they are valuable. It allows us to be very dynamic in our code. We can put expressions wherever values are expected. So the next thing I want to show you guys, and we might not understand all the details of this until later on in the series, but I want to show you how to round up and round down. And in order to do this, you need to say import math, and that is going to import a module for us to use. And now we can take a number such as 3.3, and we could say math.ceil for ceiling, and pass in 3.3, and press enter, and we get the result 4. So that's how you round up. And if you want to round down, you can say math.floor and pass in a value such as 3.6, and that will round down to 3. So we'll get into all of this, these modules, and why there's this math before the function call. We'll get into all of that soon. However, just if you're working with these numbers and you want to know how to round up or down, here's how you would do it. Now the next thing we're going to be talking about is how to create Python files and execute them. That should be pretty cool because then you can start building out complex programs. So stay tuned for that, and please be sure to subscribe. Hey everyone, welcome back. Hopefully this series has been helping you tremendously in getting up to speed with Python and developing. And don't you forget that we have the money back guarantee, so if you want a refund on these free videos, there is a $10 refund fee, but other than that, it's a great way to get your money back. And with that, we're just going to jump into creating our own Python files because, you're probably getting bored of just using this interactive mode and doing 5+5. You want to do something a little bit more complex, get your money's worth. That's what I'm going to be showing you in this video. Alright, so from the interactive mode, what you can do is you can go to File and say New File. And wow, that was it. We just created a Python file. Except the title here is Untitled, which probably we don't want to deliver an application called Untitled. So what we can do is we can actually save this by hitting File Save or Command S or Control S, depending on if you're Mac or Windows. And now you save as some file. So again, just file and then save and then give it some name. So we can say hello dot, and I don't think we have to say .py. I think it will default doing that for us. However, in the future, if we're working with a text editor, which we're going to do in the next video, you might have to put that .py. So we'll just go with hello and see, make sure it does it for us. Hit save, and now we got hello.py. So you can see it added that .py for us, and that .py is to indicate to the computer that this is a Python file. So that way it knows how to treat this file. It works very similar to a .txt or a .text file. However, when you have a text file, your computer doesn't try to run it, it just opens it. When we have a .py file, it knows that it's a Python file and that is used for programming. So that was like a really terrible explanation, but pretty much we need to put that .py in order to write in Python. Now what we do in here is not going to work the same way. When we press enter, we don't get a result. So how do we, execute this? How do we make it do stuff? Well, I'll show you how to do that. All you have to do is go up to here, hit run, and say run module. And it's asking us if you want to save the file and hit OK. You have to save the file anytime you make changes. And this is what happens when we run our program. Absolutely nothing happens because the program is completely empty. So we need to change the code to actually do something. So if you notice, we actually went back to the Python shell. Now we're back to these little arrow keys. So how do we go back to our file and how do we, develop in an easy way? So the best way to do this is probably to hold this, put this on the left, and then put the program that we're typing on the right. So now when we run, we can actually see it on the left over here. So that is how I would develop if I was to develop using this file we just created. And maybe decrease the font size a little bit so we don't get so much of this overlap, or just drag things around. Oh, nope, didn't like that. Don't do that. Don't drag, guys. Don't do it. Let's try this again. And it's frozen in full screen, guys. This is quality control right here. I think the windowing can be a little touchy inside of Mac sometimes, so I'm not blaming Python for anything here. So let's get things back to normal, and then we'll learn how to write our first program. So we're back in the shell, and if you need to reopen your Python file anytime, you can just go File, Open, and find that file, hello.py, and hit Open. All right, so now we are back to where we were, and maybe this time I'm not going to actually put everything in full screen, but just kind of position things nicely. So that way, nothing explodes. All right, there we go. And inside of our Python file, just copy this code here. We're going to say print, put some parentheses, and then double quotes, and then hello world. So a hello world is kind of just like a really basic program that prints hello world to the screen just to make sure everything is set up right. Now we can run this thing by hitting run module or the shortcut F5, and that'll show on here, hello world. So that is how you create Python programs and then execute them within the shell. So use the Python program if you need to do any complex line-by-line stuff, and then you can use the shell if you need to evaluate things on the spot, like again, evaluating different expressions. So that is one way to create Python files, but there's actually another popular way, and that is to use a more developed text editor. And there's all kinds of different text editors out there that you can use. In the next video, I'm going to be teaching you how to install one of my favorite text editors and run Python code within it. So stay tuned for that, and don't forget to hit subscribe, and I'll see you in the next one. Hey, what's going on, everyone? This video, I'm going to be teaching you how to install a text editor, specifically one of my favorites, Visual Studio Code, and then teach you how to run Python in it. Now, if you got a different text editor that you prefer, that you want to use for this series, by all means, you use it, girl. Don't let me control your life like that, all right? So what you need to do is you need to download this, and whether you're on Mac or Windows, it should be pretty much the same, so don't worry about it too much. I'm just showing you guys this if this is your first time developing and you've never really done this before. I'm going to give you step-by-step instructions on how to get it done. So open this, and it should go in some folder on your downloads folder. Hit open. And wow, look at that. So simple. Now I already got some junk in here. Don't worry about that. You don't have to have this stuff. This is just what I've been working on developing this course. So yours might be a little bit more empty. So what you can do is you can go to File and then hit Open. And this is going to allow you to open a folder. So for example, I can go in here and create a new folder and just say example, like so, and then open this folder. And voila, now we are within that folder and we can create new files over here. So hit that little plus, and then we'll just say hello.py. So that's creating our first Python file inside of this text editor, like so. All right, so if you're in this Python file and you have this little play button available to you, not like a YouTube play button like I have. I mean, come on, get on my level, guys. Hit this play button, and that will do nothing because we didn't write any code, but it should pop open the terminal where our output would go. Now, if you don't have a play button here, you may need to just download an extension. It might pop up saying, hey, you're working with Python. Do you want to install this Python extension? Or what you can do is you can download it manually. So go over here on the left, hit this little button, extensions, and look at that. The very first one on here is Python. So you will want to download this Python extension, and that one is under enabled here, but if you need to find it, you can see it in recommended, or you can search it. So we'll search Python, and it should be the very first one on here. So although there might be a little bit more setup using Visual Studio Code compared to using the interactive mode, there's a lot of powerful things you can do with this, and it might allow you to build some larger applications a little easier. So for example, when we say some method, such as print, when we do this, we get all kinds of information pop up, and this will make our life a little bit easier, especially with the nice syntax highlighting and everything like that. So very, very nice editor. Now, if you need to zoom in, just hold Command on Mac and hit plus, or Control on Windows, and notice that it zooms in everything, so it's a little funky. So if you need some space, you can hit that and move that aside. So now we can see if this works by saying print hello world and running this, and it says hello world in our terminal right here, So it is good to go. Now down here on the left, it says Python 3.8.2. If for some reason you had numerous Pythons, you could click this and you could select which one you wanted to use for this. So maybe for work, you're developing in Python 2, and then for personal, you're developing in Python 3. Well, that is how you would swap. So we're going to stick with Python 3, obviously, come on. And this is where we're going to start in the next video, where we're going to start going through all the different concepts in Python a little bit more systematically. So stay tuned, and don't you dare forget to hit that subscribe button, guys. Please. I need to get that gold play button so I can flex that on people as well, you know? Not just silver. I mean, no one cares about the silver one. I'm making myself sound so ungrateful. No, but really, guys, I am so thankful for every single subscriber, and it really helps out a lot. So please hit subscribe, and I will see you in the next video. Hey guys, welcome back. In this video, we're going to be talking about the print function and how to get the most out of it. So we are in Visual Studio Code. We set this up in the previous video if you need to know how to get to this point here. And when you're here, you can hit this play button here, and we will get the output in the console. And a nice thing here is that if you want to clear this, you can just type clear, and there you go. And maybe if you're on Windows, it might be CLS. Honestly, I don't have a Windows machine available to me right now, so I apologize if it's a little bit different, but it's not that important. I mean, it's just to clear the screen, it'll be all right. So output's going to be down here in the terminal, and our code is going to be here in our file. Now here's a cool tip for you guys, and people ask me this all of the time on my channel. If you go up to the top and under help, there's this search here, and you can search anything such as theme. And check this out, there is this color theme here. So you can go to Code, Preferences, Color Theme. So let's try that. Code, Preferences, Color Theme. And look, here are all of our different options for the different themes. So for example, we can go to this solarized light, and wow, look at that. Man, it's a little blinding. If it's dark out, maybe hurts your eyes a little bit. So let's try a different one. Let's go to color theme and maybe try this quiet light. So you can go in here and figure out what color theme you like. There's also the shortcut keys here. So in my situation, it's Command K, Command T. So I'll try that out. Command K, Command T. And then, you know, I can go with Monokai dimmed, for example. So we can set a theme like that. So I'm just going to look around and find a theme that I like. I like this solarized dark one. I think it's pretty. Maybe this Tomorrow Night Blue. Nah. So many options. So I think I finally settled on solarized light. And I apologize if you don't like light themes. However, I think that's going to give the best user experience for this series. So be sure to fight about it in the comments, which is superior, light or dark. And I will look forward to enjoying your guys' arguments, so make them nice and juicy. All right, that's enough theming around. Let's look at this print function. So again, anytime we pass in data, this is known as an argument, and we're passing in what's known as a string, anything surrounded by double quotes. Now we can pass any kind of data in here. So for example, we can pass in a number and run this, and we get the value 5. We can also pass in an expression. So we can pass in 5 plus 5. And when we do this, it's going to evaluate that expression and give us the result in the terminal. So you can see we get the value 10. Now the cool thing about print is that you can actually pass in a sequence of arguments. So we could pass in a string here and separate this data by commas and pass in another number in here and so forth. And each time we do this, it's going to output every single one to the console. So we get 10, hey, 10.3, and high. So that's pretty cool. So anytime we need to output data to the terminal, that is how you do it. You use the print function, separate all of the data by commas, and then it'll be nice and pretty out here on the terminal. Now you can actually pass in another argument that could be important for you, but this one's different because you have to say end equals and then some value. So for example, right now it's defaulting to ending with a new line, which is why this is down here on the next line. Instead, we could just end with a space. And in this situation, the result's going to be a little bit different because you see now we get 10, hey, 10.3 high, and then just a space here, and then we get the default terminal output here. So it's basically overriding the default end, which would be a new line, which if you wanted to type that out would be a \n, and replacing it with something else. And this is going to be very important in this course because we're not always going to want to put a new line after our prints. So you should understand how this works right now. And you might be wondering why we have to put this end here. Well, if we didn't put that end here, let's just say we put this, well then print is just going to assume that is just another argument that we want to print to the console. So when we run, we just get a space here, which not exactly what we want. So in order to specify, hey, no, we're not doing another argument, we actually want to change the ending. That's why we have to say end and put an equals to assign it a value. So that is how that works. So that's your introduction to the print function and all of its basic capabilities. In the next video, we're going to be learning about interactive mode inside of Visual Studio. I totally forgot, so I had to go look. So that's what we're going to be talking about next. So please be sure to subscribe, and I'll see you in the next one. Hey, what's going on everyone? Welcome. In this video, we're going to be talking about how to use interactive Python. So similar to how we were using Python when we first started this series, but now inside of Visual Studio Code. So you can keep everything in one spot. Now, if you've been following along, you may have noticed I switched my theme. Maybe I'm just a bit indecisive. I don't know. I'll probably just switch themes throughout this whole course just to try new things, keep things wild. So what we're going to do is we're going to go to Code and Preferences and then Color Theme. I wanted to mention to you guys that you can scroll down here and click Install Additional Color Themes. And look, there is a color theme for every style and every taste. No matter what you're into, there should probably be a theme to match that. So check it out. And yeah, now let's talk about how to start the interactive mode inside of Python. So if you go down to this little gear here and click that, there's this button Command Palette. Or what you can do is Command-Shift-P, or I'm assuming on Windows Control-Shift-P. So when you do that, you open up this command palette, which allows you to do different things, one of which is this Python start REPL. And REPL stands for read, eval, print, loop, which is essentially what the Python interactive mode is. It reads what you're typing, it evaluates it, and it prints it back out to you, and it just does that in a loop forever. So don't be frightened by the weird acronym. It's just an interactive mode, and it'll pop up down here, and we can say things like 5 + 5 and get a result of 10. So there we go. We got all of the things we need for Python, but all inside of Visual Studio Code. But here is my problem. This is a red flag warning for you guys, so pay attention. This has caused me some headache because sometimes when I'm typing, I'm just, enjoying myself, typing my codes. Well, I'll press a certain shortcut key accidentally, and it will open up this interactive mode. And I think that shortcut key is Shift-Enter. So if I hit Shift-Enter, you can see it starts doing stuff inside the interactive mode. It basically copies our code here and then gives us the output. And although that's fine and dandy, when this interactive mode is open and I hit run, look, it says invalid syntax. And I don't know why it does this. I can't figure out how to fix it. So I don't know if it's a bug with Visual Studio Code or if I'm just stupid or maybe just a little bit of both. However, when the interactive mode is on, the read eval print loop is active, I cannot run my code using this green play button here. So here's the solution. There's two solutions I got for you. The first is to right click and kill terminal. And there you go. It'll bring back the old terminal, or if it closes out of everything, you can just hit the play and it'll pop up and again, and you should be good to go. The other way to do it is if you go back into the interactive mode, so I think, Shift Enter, and this interactive mode pops open, and you want to close out of it, you can type in exit, like so. Parentheses, enter. And that'll close out of it and go back to the normal terminal where we can run our program and be happy again like we used to be. So then it's going to put our output here. So if someone has a fix for that, leave it in the comment section below. That way we don't have to worry about switching back and forth and we can just keep one window open. But until then, we just might need to remember how to close out of that interactive window. And if all else fails, just close out of the terminal, run the code, and it will go back to how it was. Now, there is one other form of interactive mode that I wanted to bring up to you guys, and you will find that if you go to this command palette, you might see something like show Python interactive window. And when you hit this, it's going to say starting Jupyter server. And it crashes because I don't have the Jupyter stuff installed. However, it may suggest that you install it, and you can do that. And what this does is it's basically a system of putting some input and getting some output. So it's like the read eval print loop, except maybe a little bit more substantial. So if you want to see an example of a Jupyter notebook, it'll look something like this, where you can put a comment, you put some input code, and then you get some outputs here. And then you can have numerous inputs. For some reason, I have like 20 empty ones. I don't know why it's like that. Also, don't judge my code. I wrote this like 2 years ago. And also, I was coming from like a Java background, so some of my while loops and stuff are written incorrectly. I mean, it still works, but it's not really written properly Python-wise. So don't judge my code here. I just wanted to show you guys that. And this is a possibility if you are interested in having some blend of interactive mode and also having some more structured code, then the Jupyter Notebook stuff might be for you. It's very popular for data visualization and data science, and that might be your route. But until then, until we get to that future point, we are going to be working here inside of the terminal. So that's all I wanted to explain in this video, is just how to get the interactive window open, the REPL, and how to X out of it and get back to the terminal. So in the next video, we're going to get back into coding, so stay tuned and subscribe. Yeah, that's what you should do. Subscribe. Hey, what's going on, everyone? In this video, we are going to discuss variables. And I know we're on like video 10, so maybe we're going a bit slow, but I'd like to think that we're going in a lot more depth than you might get in some of the other series out there. So although we're going slow, we are going in really good depth. So what in the world is a variable? Well, it's something that can store a value for us. And the way we create a variable is first we have to come up with some cool name for the variable, and then we assign it a value. So here is a really simple example. Age is the value 5. And I'm going to get rid of this print for a moment. We don't need that. So what's going on here? Well, there's 3 essential things. We have the variable name, also known as the identifier. So vocabulary. Next, we got the assignment operator. So similar to how, the plus does something, well, this equals does something as well. And what it does is it assigns a value to a variable. Then we got the actual value that we want to assign to the variable. So those are the 3 things going on here. And you can see that this is an int, so that's cool. I mean, Visual Studio is giving us some tips. So age contains the value 5. And you can do something like this in the interactive window. So if we open up the REPL, you can say age is 5, and then you could get the value of age by just typing in age. So if when we type in the value age, we get the value 5, well, then we could probably just assume that anywhere 5 would work, age would work as well. So we can obviously go in here and say print and pass in 5. So we could probably also say print age, right? Yeah, that actually works. So here's where we need to exit the interactive mode and run this. And you can see we get the value 5. All right, so let me get real with you. So we're at a very basic level where some of the stuff we're learning kind of seems silly. Like, why do we need to store the value 5 in this variable and then print the variable? Why don't we just print 5 instead? I mean, that's a really logical question. However, because this is such a simple example, we don't really see the value of variables. But if we're going to be building a complex application, we might need to use age 10 or 20 times, and we don't have to want to type out that value 10 or 20 times. So let's imagine we have this print in here, like, 20 times here, and we don't want to have to put 5 in there 20 times, because if we wanted to change it, we'd have to change it everywhere. But now we only have to change it in one place, and every single place will use that new value. So when we use 5, it puts the value 5, and when we use 6, everything uses the value 6. So that's the first benefit of variables, is it prevents us from having to change code in quadrillions of places, and then also reduces bugs and mistakes, so it just makes our lives better. And the second big reason we need variables is because we don't always know the value of everything ahead of time. In this situation, it seems obvious because we're just typing in 6. However, this value could come from somewhere else. It could come from user input, so we could ask the user their age. It could come from a database. In that case, it would just read the database, and whatever the value is, it would be stored inside of age. Or it could come from a text file or some other form of input. So we can't just always assume we can type out the value inside of the print. We often need to use the variables. So maybe I just went into way more depth of why variables are valuable than you would ever possibly need, but just so you guys are all clear, variables are essential and we're going to be using them for everything. It allows us to make our code more general to where we don't know the age. We don't always know the age ahead of time, and that's the purpose of programming. We create applications to work with every single case. You know, whether your age is 6 or 25, and we can change the application based on your age. These principles are simple now, but we can use these to our advantage when we create more complex applications later. So let's say we're building a website. We could do a check to say, hey, does this person have a membership? If membership is true, then we can allow them to sign in. If membership is false, then we need to kick them off and say, hey, you need to subscribe. Speaking of subscribing, you should probably subscribe to this channel. You know what I'm saying? Now, another thing we can do with variables is we can use them inside of expressions, just like you would a normal number. So let's get rid of all these different age prints, and what we can do is we could say print age plus 10, and my dang phone is ringing. Claire, I swear if that's you. It's been like 15 years, girl. Get over it. Okay, let's run this and see what we get. And we get 16. So 6 plus 10 is 16. Math, guys, it's how it works. Variables can also be used just to make our code more readable. So for example, if we have some complex expression here, and you know, we could print this directly, right? So I could take this and I could print it here. And that's fine. However, that might not be as pretty. So if you just want your print statement to be nice and simple, well, then what we could do is we could take that value and we could assign it to a variable. So we'll just say something like this, and then we could just print val. So yeah, we added a line, but maybe it's more clear on what's going on. We're calculating some value, and then we're printing that value. All right, so that concludes our introduction to variables. So there's 3 things you need to take away from this. 1, variables prevent repeating values throughout our entire program. So you should always avoid hard coding numbers. Hard coding is when we type out a number like this, and doing that throughout the program is bad. We want to do that as little as possible. You know, hard coding some stuff isn't the end of the world, but if you're repeating some certain number 10 times throughout a program, you're asking for trouble. The second thing is we don't always know the value of something ahead of time, so we can use variables to store that and work with it a little bit more generally. And third is it might make our code more readable by assigning some value to a variable and using that variable throughout our code. So those were the 3 things. The first thing is to reduce repetitive code, and then the second thing is to work with our code a little bit more generally. Instead of specific numbers, we can make general algorithms. And 3 is to make our code more readable. So hopefully I covered everything you need to know about variables, and we'll be using them throughout the rest of this entire series. So yeah, should be pretty fun. Stay tuned for the next one. Yo, what's up everyone? This video, we're going to be talking about comments. And no, I'm not talking about those things you put on my YouTube videos saying how awesome these videos are. No, not those kinds of comments. We're talking about comments in Python. So a Python comment is when you prefix anything, any line with a pound symbol or a hashtag for you youngsters here. And this will basically make the code completely irrelevant. You can type whatever you want in here and it's not going to ruin your program or break it. So normally when you have some kind of junk in your code here and you try to run it, it's going to say invalid syntax. But if you replace that with a comment, or you can even do it in the middle. So for example, I could comment out this really important message. When we do that, hey, check this out. We can run our code And look, we still get a value of 11. So when do you do comments? Well, first, anytime you got to explain something, if you got some complex algorithm doing junk, you're going to want to comment to say what's going on. Or some people will use comments if they need to come back and do something and they just want to leave some notes. They might use comments for that. Comments are also very useful for passing on code to other developers, so you can basically explain how a certain section of code works or what input or output it is expecting. That way developers know how to use your code without reading it line by line, which can actually be pretty dang difficult. If you've ever came to a project and you don't know what it does, picking it up can be pretty hard. Even for yourself, in a few years, you're probably not going to understand any of your old code, so those comments can help you in the future. Now, there's one important thing you should know with comments, and that is once you put the pound sign, everything after it is a comment. Meaning, it's not possible to put a comment between two things of code. Like, we couldn't put a comment right here, because if we put comment, everything after it's going to be affected. We can't end the comment or something like that. That is not possible. Now, this is a single line comment. Some languages have the concept of a multi-line comment. Python doesn't really have that. However, there is an alternative, and I'm not saying this is proper. However, you may see this in the future. And that is if you use 3 double quotes and then end something later on with 3 double quotes. This works in a similar way to a multi-line comment. So just to show you guys this, let's print some number at the end here. And running this, all you see in the output is 5. This here is not printed. So what is going on here? Well, we're actually making a multi-line string. So we're going to get into strings later. However, the thing you need to know here is that we're just creating this string and then it's not being used for anything. The actual code inside of it is not being executed. So although officially this is not a comment, you may see this being used when people want to comment out a large section of code. So for example, we could put numerous print statements in here and none of them are going to execute. Then if you want to uncomment it, boom, all you got to do is get rid of those right there. And there you go, you get a bunch of different outputs. If you weren't going to do the 3 double quote version, you would just have to put a pound sign before every single one of these, like so. And that works just the same, and that's the actual proper way of doing it. And then we just get one output. So that's all I got for you guys on comments. Stay tuned for the next video because we're going to get into how to properly name variables. I know it sounds boring, but it's important, so check it out and don't give up. You got this, guys. Keep going. Motivation. Woo! Hey everyone, welcome. In this video, I wanted to talk about legal variable names. So you can see I have a bunch of variables I am creating and they all have some variation of the word age. And now the very first thing you need to understand is that when we create a variable, we're pretty much free to name it whatever we want as long as we stick to some rules. However, it should make sense, right? So we don't want to call this yellow because yellow doesn't really... How does yellow equal 5 make any sense? At least in this context, it doesn't really make a whole lot of sense. So the very first rule, and this is just a very strong guideline, is to give your variables names that mean something. So when you see the variable name, you know what it is referring to. So when I say age, you know it's referring to the age of someone or something. So it's at least pretty good. So this here is a valid assignment. Age is a good variable name. But let's look at all these other examples and see if they work, and if so, why they work or why they do not work if they don't. So the very first one, age 1, well, this actually is okay. And just to show you guys this, here's what I'm going to do. I'm going to comment all these out just so it doesn't interrupt our program. And then at the end of our program, I'm just going to print the variable that we're working with. So right now we have age 1 and we're printing age 1. Running this, you can see we get the value 1, so it seems to be working. So that one is legal. All right, let's try this next one. Age 2. So we'll uncomment that and change this to age_2. And run this. And you can see we do in fact get the value 2 in the terminal, so it is valid. So you can use underscores, and in fact, it is recommended for multiple words. So if you need a variable name but it needs to be a little bit more descriptive, you might have multiple words, which is exactly what we're doing in this example here. So let's try that one. Age of user, like so. running that, and we get 7. So both of these are good. This is good, and this is good. This style of using underscores to separate words, this is known as a convention. Conventions are just something that numerous developers have agreed upon, that this is the way it's going to be, and using underscores is just so common that everyone in Python just does it. You may see other conventions. For example, you might see age of user. However, that's not the convention we're going to follow, and for Python, it's recommended to use underscores. And yes, my phone is ringing, if you can hear it. Sorry, I just have this crazy stalker. I don't know what to do about it, guys. I'm a little scared, to be honest. All right, so we know these ones are good. Let's try this next one, age-3. So we run this, and we actually get a syntax error. Cannot assign to operator. So maybe it thinks we're trying to assign to the minus operator or something. I'm not really sure what's going on here, but I do know that this is not good. So you cannot use hyphens in your variable names. This is bad. We don't want to do that. So we're going to comment that out so it doesn't ruin our code and move on to the next one. And that is starting with a number. Can you start a variable with a number? Let's try it. We'll just pass for age into here, run, and oh, syntax error. You cannot start a variable with a number. So the rules are you can use numbers in your variables, even in the middle or at the end, but you cannot start with them. So this is bad. Also known as not good. All right. And then we have this one here, which is actually age with a capital A. So let's run that. Running this, we get the value 6, so it seems to be working. However, this is also not good because this is a style thing. You don't want to use a capital here for your variable. By convention, we keep variables lowercase. So although it does allow it, it is not recommended. And lastly, we have return is 5, and watch what happens when we do this. So we print return, running this, and we get a syntax error, invalid syntax. And the reason that is because return is actually a keyword. And you can see that by the syntax highlighting, it's not the same color as these other variables. So this is not good. All right, and I'll comment that out. So that is your introduction on proper variable names. To conclude, all you need to really do is stick to lowercase and underscores to separate words, and you can use numbers, but only within it or at the end, not at the beginning. So hopefully that was helpful for you guys, and we'll try to stick to best practices with naming conventions and everything in the series. I'm actually really particular about that. So I want to make sure you guys are on the best track to becoming the top tier Python developer or just developer in general. And in order to do that, it's important to follow conventions. So we'll be doing that for the rest of this video series, and stay tuned for the next video and subscribe. Hey everyone, welcome to this video and the next video where we're going to be finishing up our basic discussion on operators. Just get a little bit more experience before we switch gears and talk about something new. So stay with it because we're going to be finishing up this section soon. So this video, we're going to be talking about a new operator that we can use in our code. So first, let's talk about when we take a number such as 10 divided by 3, and we'll just assign this to some variable. We'll just call it result. And we'll print that result. Sorry, apparently I am unable to type today. Okay, run this and we get 3.3 repeating. All right, awesome. This works, and I even taught you how we could lower this or basically bring it to the floor. So instead of 3.3, it would be just 3. So how do we do that again? Let's see if you remember. Okay, I'll show you. Import math, and then you would just say math.floor. And you can do this pretty much one of two ways. You could do it directly inside, right before the result inside of the print, or you could create a new variable. When you're first learning, maybe the variables are a bit more clear, and then once you're more familiar, you can just do it directly. And I'll show you both ways so you can see that there's just options here. So what we could do is we could say new result, and then assign it the value math.floor and pass in result. So what's going on? It's going to take this variable result, floor it, and then assign it to this new variable, which we could then print. So that's one way we could do it. And you can see we get the value 3. Another way we could do it is we could just do it all within the print statement. So we'll just take this here, cut that using Command X or Control X, and pasting it right there. And then we can just get rid of that variable. So now we're not storing it in a variable, but we're not going to be reusing that value, so printing it directly is fine. So the way this is going to be invoked is first, the math.floor is going to do its calculation on this variable, and then that value is going to be passed into the print function. So that's how that nesting works here. It's always innermost parentheses to outermost parentheses. So this is inner, and then this one here. All right, but that's not really the purpose of this video. That was just just to show you some options. The thing I wanted to show you is that instead of using math.floor, we can actually use a new operator, and I'll show you it. First, we'll just print result. So right now, we're getting 3.3 repeating, and you can do the lower division by putting a second division symbol and running it like so, and now we just get 3. Now, I don't believe there is a way to do the ceiling version with the division, so if you need to do that, just use the math module using math.ceil. So in that case situation, it would be like so, math.ceil, and passing that value in to get 4. So that's just another operator. It's very useful if you know you're going to need the floor version of the division. So let's go back to that. So we'll get rid of this math.ceil here and just print result. And another way to think about this is that it's just going to return an integer. And an integer is a whole number, positive or negative or 0, and no decimal value. And the reason this operator exists is because in other programming languages, not to get too off topic here, but if you did 10 divided by 3, it doesn't automatically convert it to 3.3. It would just do an integer division and give us 3. So because Python automatically will create the decimal version, it gave us another operator to go back to just integer division, which is using 2 division symbols like so. So to conclude, let me just make some comments. 1 division, this is going to be known as float division. If we use 2 division, this is known as integer division, and you can also just think of it as getting math.floor. So that's just a little bit more practice working with operators. Be sure to check out the next video and be sure to subscribe. Hey, what's going on everybody? In this video, we're going to be discussing a super important operator known as the modulus operator. Now, this is used for so many different things inside of computer science, and it's actually so simple, but grasping it to start with can be a little bit confusing. So pay attention and we'll get through this just fine. The modulus operator will give you the remainder of some division, specifically integer division. So let's say we had 10 divided by 3. Well, right now, if we ran this and we printed out the value, we're just going to get 3.3 repeating. So running it, you can see we get 3.3 repeating. However, if instead of doing what would be float division where you can split it and get fractional parts, if we did integer division, well then there would be some remainder. So 3 goes into 10 3 times with 1 left over. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 left over. So yeah, maybe that's rudimental and I'm going into the details a little bit too much. Although I think it is helpful to think of it with this beautiful example. Let's say we have slices of pizza and we have 10 of them, and we have 3 people. And you want to hand out the slices of pizza for everybody to enjoy, and we're not going to split any pieces yet. You're going to hand out 3 to each of the 3 people, and there's going to be 1 whole piece left over, which then people will either have to fight to the death over, or it's just going to go to waste. So this is how we can understand the modulus operator. So to use the modulus operator, it's the %, 10 modulus 3, and you could also use variables here. So pizza modulus people, and we get 1. So what we could do is we could say something like leftover, and then pizza modulus people, and we get leftover 1. So I don't want to get too into the details of this. However, this operator is common in certain data structures because it can be used to transform a large number into a smaller number in a very natural way. So let me just go through one simple example of that. Let's say we have this really large number and we want to transform it into a number under 10. Well, what we would do is let's just change these variables. Just call it limit and say 10. And then what we would do is we would say number modulus limit, running this, and we get the value 5. And it's actually impossible to get a number 10 or larger. We're always going to get 0 through 9. So if you imagine here for a second, we had some box, and this box had 10 different positions to put data in. We could use the modulus operator to decide where to put that data. And this concept is the basis for a really popular data structure known as a hash map. So let that be some food for thought, something you can research or something to look forward to later on in our development experience. But for now, just wanted to introduce you guys to this operator, and upcoming in the next video, we're going to be talking about raising a number to a power. So I think that will probably sum up our operators section, and then we'll get into something new. So get through that video and I'll see you then. Hey guys, in this video I wanted to show you how to raise a number to a power. So for example, if we wanted to raise 3 to the third power, we would get 27. So let me show you how to do that. The easiest way to do it, honestly, this is really simple. We just say 3 times 3 times 3, which is pretty much just breaking out the power into the multiplication equivalent. And it's not the best solution for large powers. However, for small ones, it will work. And you can see we get the value 27. Now, the operator to do this, rather than repeating ourselves, is actually to use 2 of the multiplication symbols, 2 of the asterisks, and then what to raise the number to. So 3 to the third power, and we get 27. So you can see 2 different ways to do that there. The first one is fine for small situations, where we're raising something to the third power. But if you're going to, 4th, 5th, 6th, 7th power, that's going to really quickly be pretty gross. So I don't really recommend that. And honestly, anytime you're raising something to a power, you should probably just go with this operator here. But the multiplication is a good way to think about it. So if we wanted to raise 3 to the 5th power, here's how we would do that, 243. So this is a common way to do it. I'm going to show you another way you might see it, and that is using the math module. So we will say import math, and then we're going to say math.pow. And this takes 2 arguments, and you can see it says returns x to the power of y. So x is the first, y is the second. So we'll say 3, 5, and let's just assign that to a variable like result, and then print that variable like so. So running this, you can see we get 243.0. Notice these are technically different. That's because this one has the 0.0 and this one does not. We get the same result. It's just the type of data, this being an integer and this being a double. Right now, we really don't have to worry about that. It's not going to cause any problems. So you can work with either one as is. Obviously, you can use the floor method we've talked about if you want to get the integer version. So math.floor, pass in result. That's going to be the new version, which we could print here. Printing that, you can see we get 243 without the decimal. However, not a huge need. Oh, Claire, I'm a slap a noob, I tell you what. Well, enough about that freak bag. Let's get back to what we were doing. That's the end of the power video. Up next, we are going to review everything we've talked about and just go through our reference guide that I created and just make sure everything is solid in your brain before we move on to the next section. So check out that video and just measure how you feel. If it's all really simple and you got this down, then you can move on. Otherwise, it'll be a good video for you to just review and get up to speed. So check it out. I'll see you then. Hey, what's going on, everybody? This video, we're going to review everything we discussed up to this point. Anything code related, it's going to be in this video. So you can get the code at github.com /Caleb Curry /Python, jump into this beginner Python folder, and the first section, 01/numbers. And we've talked about all this stuff. So here's what I'm gonna do. I'm gonna take it all, I'm just gonna copy it and bring it over to my text editor and just go through it real quick. Pretty sure you can download these files somehow if you want to figure out how to do that. I'm gonna worry about that later. So let's just go over to our text editor, paste all this code, and just go through all these examples. Clear off the terminal here, and we will start at the beginning. So we're gonna run this and just start with the very first output here, and that is 25. So we created a variable called age, and we printed that variable. So here's how you assign to a variable. Again, we have the value, and here's another vocabulary for you that I haven't mentioned yet, and that is literal. Anytime you type out a value, like the actual value, 25, this is known as a literal. This is in contrast to a variable which stores some value. The literal is just the value itself. So we are assigning a literal to this variable using the assignment operator. Then we use the print function. We pass in age as an argument. Then we create a comment. Then we talk about all of the different types of names we can use for variables. I commented out any of them that are not valid. So the very first one is age 1. We can use numbers inside of the variable names. That's fine. We can use underscores. That's totally fine. We can use uppercase. However, this is not recommended. It is recommended, however, to use underscores to separate words, and that's based off of this guide here, which you can check out if you guys want. Next up, we cannot assign to keywords. So return is a keyword, so that's not going to work, and we just commented that out. And you can see all the keywords here on this guide. So opening that up, we can see all of the keywords right here. So don't try to assign to any variables named like so, it'll cause an error. So the next thing on here is we start doing some operators. We do some division, and that's where we get this output here, 6.6 repeating, because we printed that result. Main thing just to show you guys is that we're using integers for the division, and the result has a decimal spot. So this is known as a float, and it'll automatically convert it to a float division. If you want to use the floor version, which is basically integer division, you would do 2 division symbols like so. 20 divided by 3 is going to give us 6. Next up, we did raising a number to a power using 2 asterisks. So this is 5 to the power of 2, which I apparently left out the 2 there, but I think you guys get it. And that's going to give us the result 25. You could also use round, so we rounded the number, and that's going to round it up or down appropriately. So that's different than this. This is always going to lower it. So even if you got 6.99999, it'll give you 6. Round, on the other hand, will round up if it's 0.5 or higher, and round down if it's lower than that. This here shows that you can use variables instead of literals. So we're using result divided by age. That gives us the value 1 here. And now I just wanted to talk a little bit about the way precedence works. So I want you to guess the output here. And if you understand precedence, you would know that this happens first, which gives us 6.6 repeating. We add 1 to it to get 7.6 repeating, which is the output right here. All right, next up, you can think of it like so. So this doesn't actually change the output. We get the same exact output. However, it might be a little bit clearer if you're not super comfortable with the order of operations. And in this situation, it's really simple, but it can get more complex once we get into more operators. So don't think of it as simplistic and that you would never do that. It actually can come really in handy. And you can force certain operations like so. In this situation, we get 3 plus 1, which is 4. And then 20 divided by 4 is 5. Next up, here's how to raise 5 to the 5th power. I think we showed that earlier. And we can do integer division remainders here using the modulus operator. So the remainder of 78 divided by 11 is 1. That's because 11 goes into 77 perfectly. And then with 78, we have 1 left over. So that is the review of everything we've talked about with numbers and just how to do everything properly. Hopefully that was helpful. And next up, we are going to begin our discussion on strings and various other things. And this is actually where things start to get interesting, because you can see the next review is going to be a whole lot longer. So buckle up, put your big boy or big girl pants on, and let's start to learn how to code, like actual stuff. Maybe, I mean, we'll get there eventually, but stay tuned. I'll see you in the next one. And don't forget to subscribe, guys. Come on, just do it. Do I gotta bribe you? Like, come on, I'll pay you. No, I'm just kidding. Hey guys, welcome to your introduction to the next section of this series, which is all going to be about strings and working with them. Now, what in the world is a string? Well, a string is just a series of characters, where a character is pretty much anything you would type out on your keyboard. So it could be, a C or a 5 or a space or an enter, whatever it might be. And you can put all of these in a sequence and you surround them with quotes. So a really common example you're going to see is hello world, and you start it with a quote and you end it with a quote. So this is a string literal. Again, there's that word literal. A literal is when we type the value out directly. And we can assign this to a variable like so, and use it within a print statement like so. So very simple, and we get hello world to the console. This is how to do a hello world inside of Python. Doing the same thing inside of other programming languages is not as simple. For example, inside of Java, you have to do system.out.println and then pass in this message. And it's all surrounded within this giant thing, public static void main. However, we're not doing Java in this series, so apologies, but just consider yourself lucky that this is so easy. And I'm honestly out of things to say for this video. Wow, it's that easy, guys. Some of the things we're going to be talking about in the upcoming videos, we're going to first be talking about escape characters. We're going to be talking about single quotes versus double quotes. We're going to be talking about slicing strings and indexes. We're going to be talking about how strings are immutable. There's so many different things we're going to cover with strings, and it seems so simple, like we just have a string. However, there's so many different things we need to know in order to work with these strings properly. Hey, what's going on, everybody? I just want to let you know, just so you guys know how important this is to me, I got up at 4 a.m. to get this video going. I don't know why it took me an hour and a half to get in the office, but anyways, my point is I'm going to be up making these Python videos until we've covered everything, or until I get tired. Whichever comes first, I guess we'll see. Probably the tired one. So what are we going to be talking about today? We're going to be talking about string escape sequences. Now you might hear these by a few different variations of names. You might hear string escape characters. You might just hear escape strings. But basically, there's certain characters that are a little bit special when we're working with strings. So if we have some message and it just says something like hello, this is fine. And it works, it's all great, but there's certain characters you can't really type out when you're trying to make a string literal. So I'll show you my first example of that. First, let's print this message. Running this, we get hello. And what if we want to do a tab? Well, we could put a tab in here, run this and say, hey, and that works. But what about a new line? What if we press enter here? Running it now, we're actually getting an error. So how would you put a new line in this string? Well, you actually just put a \n. So that is an example of an escape character. It's treated different than the rest. And you can see it as orange. And you can think of this escape character as being rendered. So it is replaced with whatever that escape character would represent. In this case, it's a new line. And now it works. Hello, hey. And there's other ones as well. So for example, we could do a tab, which obviously we saw that a tab character can be typed out and it works fine. But in this situation, we could put a tab there, which can be used for formatting and so forth. Now, another thing we can do with these escape characters is we can actually use hexadecimal to print characters, which you might run into, but if you haven't worked with hexadecimal yet, don't really worry about it too much right now. But just so you guys know, there's this thing called the ASCII table, and it contains all of the characters in this character set that we can use. And for example, there's a hexadecimal value. So let's say we wanted to print in capital A, it would be hexadecimal 41, which is the equivalent to decimal 65. And we can print that using hexadecimal using a \x. I already forget the number, what was it? It was 41. So we can say 41, run this, and look at that, we get an A. So that is how we can take hexadecimal and render it as a character. And there's other escape characters that you can use. So here are some examples. You can also do octal here and some other special characters from the ASCII table. And there is some stuff on single quotes and double quotes. So just real quick, I'll show you an example of that. If we wanted to actually print a double quote, you would have to put a \, double quote. Now running this, you can see we get a double quote in the terminal window. So that is your introduction to escape characters. Nothing too crazy, but they are going to come important for various things. You know, maybe if you're trying to quote somebody or do some hexadecimal conversions or whatever it might be. If you need to format your messages using tabs or new lines, this is how you would do it. It's also important if you have a string that has characters that could be considered escape characters and you don't want to render those, then you have to be a little bit different. So for example, let's say we have a string and there is a \t and we want to actually print \t, then you would just need to prefix with another \. Running this now and we get \t. So that is how you basically escape the escape character. Well, that is our first video for the day. Hopefully it wasn't complete garbage. Still waking up a little bit. So I will see you guys on the next video where we're gonna continue talking about Python, thankfully. All right, I will see you then. Gosh, Caleb, you're terrible. Hey, what's going on? This video, we're gonna be talking about single quotes and double quotes inside of Python. This is actually pretty interesting because this is different than various other programming languages. And the thing is that double quotes and single quotes work exactly the same way in Python. And what that means is that we can have this message with double quotes, run it, and we get hello. And instead we could replace these double quotes with single quotes, like so, and running it, we get the same exact thing. It works exactly the same way. So just so you guys have a little bit of context for some other programming languages, if Python is your first language, inside of languages such as C# or Java or various other C-like programming languages, characters, just one individual character, will be used with single quotes. So for example, an H. And then if you wanted to use a string, you would have to use double quotes, like so. It's not the case in Python. And even in other programming languages where you don't have characters and strings, they're just the same thing, well, the single quotes could be used differently than the double quotes. So an example of a language like that would be PHP. Now in Python, they're exactly the same thing, so you don't have to worry about it. Now, which one do you use? Well, it's totally up to you. Personally, I don't really care. I have so much experience in my life using double quotes, just years and years of development experience, so I'm going to be using double quotes for my strings. However, if you want to use single quotes, by all means, you do you, girl. Or boy. Alright, so here is one thing you need to know. That is just a slight difference. So, maybe I wasn't 100% true. There is a minor difference, and that is what quotes you can use inside of the quotes. So here's an example. Let's say our string is going to be, "You're pretty." We're writing like a secret message to our crush, aka my wife. Love you, girl. And I want to send this message to her. Well, this is going to work just fine. See, we get that message in the terminal and everyone's happy. Well, she's happy. But look what happens when I use single quotes. When I replace these double quotes with single quotes, it's not working. The syntax highlighting isn't even right, and we're getting an invalid syntax thing. That's because it thinks that these are the quotes and it stops the string there, and then this is all just like extra crap that shouldn't be there. So that's the problem with single quotes inside of single quotes. And the backwards is true as well. If you wanted to quote somebody in a string, so let's just say she responded in a message and we quote her and we run this now. Hey, look, it works. That's because we have double quotes inside of the single quotes. If you put double quotes on the outside, we're going to have that same exact issue where it thinks we're closing the string and then we have a bunch of extra crap at the end. So if you're trying to put single quotes in your string, use double quotes. If instead you're trying to put double quotes in your string, you should use single quotes. So you can escape quotes. So for example, if I'm just so desperate to use double quotes for some reason, I want to use double quotes, all right? Let me do what I want to do. And I need to make this work, then I can put a backslash before the internal double quotes, and that's where those escape characters come in. Python sees this and is like, dang, we don't want to consider this to be part of the syntax of the language. Rather, this is part of the string. We need to print this double quote, and check it out. It works. She said, ooh, which is not very nice, by the way. Come on. The same thing goes for single quotes inside of a single quoted string. So let's switch this to a single quoted string, and let's just run it now and see what happens. The same exact thing happens. So the escape characters work fine inside of the single quotes. However, the backslashes are not actually necessary to get the same result. So we're still going to get the same exact message here. But if instead we had something else like this, you would need to put a backslash before any single quotes in order for that to work. So there we go. So moral of the story, use single or double quotes however you like. However, if you're going to have quotes within the string, it might make sense to use one or the other. So that's what I got on that. Now stay tuned for the next video because we're going to be talking about, let me look at my notes because I totally forgot, concatenation. It's fun stuff. It has nothing to do with cats. Hey, what's going on everyone? This video we're going to be talking about concatenation, which is a process of combining strings into one master giant string. So let's say I'm sending some top secret love notes to my lovely lady, and we got one message here that says you're cute. And again, following the previous video, you could use double quotes here just as a refresher. If you guys are just jumping in, you can use double quotes so then you don't have to escape any single quotes. So now that string works fine. And let's say I have another message, and if we're writing messages to people, we want a response, so we leave with a strong call to action, tell them to hit you up. And now we need to combine these into one giant message. So how would we do this? Well, if we're printing, there's something magical you can do where you put commas. So this will throw in a second argument and it'll print both. So message 1, I guess, first message, and then message 2. Running this, and it says, you're cute, hit me up. However, when we're working with strings, we can't always just pass in unlimited arguments and have it work like that. It's real simple. You just say plus. So it's like math, but with strings. And there we go. We get you're cute, HMU, no space. So when we're not having a space in there automatically, we might want to customize it by throwing in some custom string here, like so, and running it. And now it says you're cute, ... hit me up. So the way this works is that we're building an expression, and this expression gets evaluated, and the entire thing gets passed to the print function as one entity. So the order in which this happens is not that print starts, and then it starts parsing this string here and makes a giant message. Rather, the message is put together through this process of concatenation using the pluses, and then the final message, you're cute, hit me up, is passed to the print function. Although this is a minor thing right now, this is actually really important to understand, because if we say print and we throw in the message and the second message here, well, this is actually going to pass 2 arguments to the print function, and then that print function has to work with those 2 arguments, and it's probably going to work with them as separate entities on the inside and put it out to the terminal for us. So moral of the story here is that if you are expecting one argument of string, you will want to use concatenation. And this is going to be 99% of the time. Print is just special because it's obviously designed to print a lot of things, so we can pass in our data as separate arguments. However, other functions we're working with, it's probably not going to just do that magically, and it'll expect you to put the string together on your own, and it's not going to do any hand holding for you. So you need to concatenate beforehand. Now, alternatively to doing this concatenation inside of the function call, we can do it as a separate thing. So we could say full message, and then we can do the expression here. So we'd say message plus ... plus message 2. And then all we have to do is print that full message. This is the logical way to think of how this is working. So the message is being created first, and then that message is being passed to the print function. Stay tuned for the next one, because we're going to be talking about concatenation with literals, which is a little bit special, and it should be pretty fun, so stay tuned for that. Hey, welcome back everybody. This video, we're going to be talking about concatenation with string literals, and this should be our last video with creepy messages here. So this is an example of a string literal where we're typing the value out hard-coded in our code. Message, this is a variable and it's not a literal. Literals are only the actual value itself. So this here is a literal, this ellipsis here, and so is this HMU. So when we are concatenating variables such as message and then this literal and then this other message, we use this plus operator to concatenate this data. However, if we are working with literals, you don't actually have to put the plus operator. So to show you an example of this, instead of printing this message we just created, let's just print a literal. And let's just say, hey, and then we put a space and then another set of quotes there. And running this, we get, hey there, no spaces, because the concatenation doesn't automatically put spaces because it can't assume you want spaces. So if you want a space, you throw that in there like so. But with this literal concatenation, you can put a space in like so. You can do it however you want. You could put an exclamation mark running this and we get hey there. And obviously our code looks terrible. Like why would you do that when you could just put hey there in one string? However, this can be useful for certain situations, I'm assuming. So let's go through maybe another example where this might be useful. And that is if you want to break a string into multiple lines, you know, like you're writing some book, right? And this is a long string and it just keeps going, right? And you're tired of writing, so you're tired of writing on the same line, so you want to break it down to the next line. Well, when you do this, it's not going to work. So we say this is a long string continued. We run this, didn't do anything. We got to print it. The print message. Running this now, it says this is a long string, but the continued doesn't appear. So to make this work, you actually have to put it inside of parentheses and hit run now. This is a long string continued. So if you were working with numerous strings and you want to break them out on new lines, that is one way you could do it. And when the actual message is constructed, it's all going to be one giant string. So in our code, it's split up by line. In the actual data, it's combined into one string. So you can use it as one string and there's no new lines built into the string. So this is different than if we did this, where we put a new line in here, because that's going to be visible in our code and stored in the data, so it goes down to a new line. There is no new line characters when you do the literal concatenation with an extra set of quotes inside of parentheses. So the only other thing I want to share about this is that if you have some message or some variable, and let's just say it says hello, and you try to do this with a variable, so you say message, and then you say there, this is not going to work. It's invalid syntax. Whenever you have a variable or an expression, you have to use a plus operator, and that's how you would concatenate. So it only works with string literals. So maybe you'll use that sometime in your development career. Probably not though, so stay tuned for the next video. I'll try to give you something a little bit more useful. Yo, what's going on everyone? This video, I'm going to be teaching you how to do multi-line strings. So you might want to check out the previous two videos where I just kind of introduced strings if you're just jumping in here, but if you're following along, congrats guys, because you get to experience my first time showing poetry here on YouTube. So if you guys didn't know it, I am a poet. All right, here's my poem. This is all combined as one happy string. What was that sound? It was a doorbell ring. When I see you, my heart sing. Here, please take this diamond ring. Aww. So you can send this to your love and, you know, get married. So when we print this, check this out. It says all of this on one happy string, and it's all together. So this is because when we do this concatenation with the parentheses that we showed in the previous video, it does not automatically put new lines or spaces or anything. So what that means is this string here to Python is pretty much typed right here. It just continues where it left off. So that's why everything is put together. internally it's just stored as one string, no new line characters. However, with poetry, that's just killing my vibe. We want this out line by line. So I could go in here and I could type out new line characters, but that's just gross. I don't want to have to do that. So here's the solution. First thing, we don't need the parentheses. We can get rid of those. And instead, we can use 3 double quotes, like so. So 3 at the beginning and 3 at the end. And this is going to change things because we no longer need to use double quotes throughout. So converting between these is a little sloppy, but if you're going to start from scratch, you can start with the 3 lines and you don't have to go in here and delete a quadrillion quotes. So yeah, clean up all the formatting and it should be ready to go. Make sure I don't got any extra spaces in here. All right, it is looking good. Now when we run this, look at this. Everything goes out on a new line. So in this situation, the new line character is automatically inserted in the poem after each enter in our source code. So anytime we hit enter or return, that is a new line character that's going to be stored in the string. As a result, my string is written out line by line, which might be a little bit easier to read if you're going to be writing a long poem. We want the terminal output to be nice and pretty. So now, what if we want like a mixture of both, right? So the first situation, the new line character was not automatically put in there. In this situation, it's put in there every single time. Well, what if we had one long string that we wanted to split up over numerous lines in our code, but we did not want that new line character to show up? So like, let's say we wanted it to look like this in the output. So now all of this is in one line, but we didn't want to type it out all in one line in our source code. Imagine if this string was very long, we might want to break it up. So to do this, what we can do is we can take this and we can just move it down to the next line like so and replace it up here with a backslash. And I don't know why this does this, but kill that, running this, and there we go. This is all combined as one happy string. What was that sound on the next line there? Which is right here. So the as one happy string is printed on the first line. So to get rid of the new line character, again, is to just put a backslash at the end of whatever line you want to get rid of it on. So for example, we could do it here, and we could do it here. And there we go. That would change the formatting completely. All right, that's enough on strings and concatenation and writing terrible poetry. Stay tuned because we're going to go into a new topic coming up. Hey, welcome everybody. So in this video, we're going to be talking about indexes, and I got this poem variable. I realized I really wasn't that great at poetry, so I just decided to trash what I had and replace it with this much more inspirational poem that has, layers of meaning. Where am I? I mean, this could mean, where am I physically, spiritually, what is my purpose? Anything. The true meaning of this poem is up to the reader's interpretation. And anyways, what I want to talk about is how you can grab any particular character of a string, and that is with indexes. Or what some professionals might say, indices. Sounds stupid. I'm just playing, guys. Say it however you want, but essentially, each one of these characters is given a number, and we can grab that character using that number. So to start off, W is given the number 0. So that is important, and that's probably one of the biggest hurdles for new developers because any kind of algorithms we work with, we have to start with 0. So how do we actually grab that W? Well, using square brackets, we can put a 0 like so. Hitting run, and we get W. Also, I apologize, I keep scrolling, my mouse is like really touchy. Anywho, that's how we grab W, and we can go on and grab H by using a 1. Running that, we get H. And what about this space here? Well, spaces are characters. Even though they're not something visible, they're actually a space. They are a thing. I feel like this is some weird, is something that doesn't take up space a thing? I don't know. So yeah, strings are considered characters. So this is going to be 0, 1, 2, 3, 4, 5. So if we want to get that space, we just put a 5, running this, and look at that. It's a space. Great. So what happens if we put an index that is too large? So for example, 50. Well, that's going to go through this string, but it's going to go way past the string. And when we run this, we actually get an error, string index out of range. So this is something you really have to be careful with because it's very easy to go outside of the edge of the string. And in that situation, you're going to break your code and the code's not going to work the way you would expect. This is really important if you create an algorithm to go through each one of these characters to make it such that it doesn't go too far. And we'll be talking about how to do that in this video series. So yep, that's all I got for you guys in this video. I thought I had more, but I mean, it kind of ran short. So stay tuned for the next one because we're going to be talking about slicing, which is how you can grab a section of a string. Oh, and another thing I could talk about on indexes is it's not just for strings. Once we get to lists, we're going to be talking about indexes again. So make sure you understand them and understand that the first character always has the index 0. Alright, stay tuned for the next one. Hey, what's going on everybody? In this video, we are going to be talking about string slicing. And if you're new to strings and slicing, then this can be a little confusing. So stay with it, guys. We can get through this together. So it's similar to indexes. So you can see here we have this 5 here, which grabs the character with the index 5. The first character starts at 0, so that's actually going to grab the space here. So to count that off, 0, 1, 2, 3, 4, 5. So that 5th jump was the space. Slicing is a little bit different because it's more versatile. You can use slicing to grab one particular character, but you can also use it to grab a range of characters from a string. And this concept is known as a substring. So other programming languages might have a substring function, but in Python, we are going to be using slicing. So how do we actually do that? Well, it actually follows the same syntax. So instead of putting a 5 just in here, we could put a 5 and then a colon. And running this, you can see it says am I, and it's prefixed with a space because it starts at the index that we throw in here, which is the space character. So doing this actually grabs everything all the way to the end, starting with that space. Now, if you want to go from the beginning to a particular character, like let's say we want to go up to that space, then we would take the 5 and we put it on the right of the colon. Now, watch here. When we do this, we get where. And it's not easy to see here because of my choice of character. So let's back it up one. Let's go to 4. And when we do this, it cuts off the E. So the index on this side of the colon, well, this is exclusive. So it does not include that character. So what is that index for? Let's find out. W is index 0. H is index 1. E is index 2. R is index 3. And then that last E is index 4. And you can tell that because that's exactly where we stopped in this string down here. So that's interesting because when we put the number on the left side, if we throw in a 2 here and run this, the 2 is inclusive. So 0, 1, 2, it starts right here. So when the number is on the left of the colon, it is inclusive. When the number is on the right, it is exclusive. So the next video and the video after that is going to just be some variations of slicing because it can get a little bit more complicated, but one step at a time, right? So stay tuned and I'll see you in the next one. In this video, we're going to be talking about negative indexes or indices. So to start off, let's just go with a positive number without the colon. So we're not doing slicing yet. We're going to get to that in a second, but for now, let's just focus on one number here. We run this and we get, what do we get? We get H. So it's going to grab the second character there. So W is index 0 and then H has index 1. Well, what if we do a negative 1? How does this affect things? So running this, we actually get a question mark. So it doesn't even know the answer. No, I'm just playing. It's actually grabbing this character right here. So the first character on the right has the index negative 1. So you may have thought, oh, it would be negative 0 because the one on the left is 0. Except the whole concept of 0 and negative 0 doesn't really make sense. There's only one 0. And in fact, I'm going to show you just to prove my logic here. And we're going to get into logic later on here. But I'm going to print, and we're just going to do a little comparison here. So I'm going to say 0 is equal to negative 0. Running this, and we get true. But if we did something like 1 and negative 1, false, not a thing. So that is why the character on the right starts with -1. So that's your introduction describing one character, but now let's try slicing. So we'll start with a positive number and then convert it to a negative number to see how things change. So let's go with, I don't know, let's pick a number. Let's go with 5. And then a colon. So running this, we get am I and a space at the beginning. So our original poem, Where Am I, is now much more deeper because it's not even asking where, it's just asking am I? So we are reaching depths that I was never even expecting, but now what I want to see is what happens when we switch this to a -5. So running this now, we get am I without the space. So when we do a +5, we start at index 5. So we say index 0, 1, 2, 3, 4, 5. And because that number is on the left of the colon, we include that index. So this space was included because it's index 5. When we say -5, we're starting from the right. So -1, -2, -3, -4, -5. Also, it is inclusive, so we start with the A. So when we say -5 colon, we are saying, hey, we want to get the entire string starting from the 5th index from the right. So starting at the end, go back 5 characters and give me all of those things. Now let's try a number after the colon. So if we put a 5 here, all right, let's go with something else. Let's go with a 7. Running it with a 7, we get where A. So when we put a number after the colon, we're saying, where do we want to go up to? So starting at the beginning, we go index 0, 1, 2, 3, 4, 5, 6, 7. And the 7 is not included. So when we put a number on the right of the colon, it is exclusive. So we stop here. The 7 is like the stopping point. Consider there to be a wall before that index. So we grab everything up to index 7, but not included. So that is why we get where A. Now let's try a negative number. Running this here, we run it and we get were. And basically now we're going to go up until the character that is -7, so 7 from the right. So starting from the right at -1, -2, -3, -4, -5, -6, -7. So this E is the character at -7 index, and it is exclusive, so we're not going to include that character, which is why we get were. So I'm not going to lie, this can be confusing, especially when we're getting in negative numbers. I literally have to go through this and think like which ones are going to be included, and oftentimes, you know, I'll be like, hey, I'm going to try to grab this word, and I'll get one character off, and then I have to like adjust by one number, and that's not the end of the world. You get more used to it over time and make less mistakes, but don't feel like it's the end of the world if you don't get it perfect, because you can go back and test it and try to get the right substring. Drinking coffee ASMR. Oh, that's hot. Oh, ow. In the next video, we're going to take this, what's kind of already a little bit confusing, and make it a little bit even more confusing by not only putting a starting point or a stopping point, but putting both. So you can put a range from where to start all the way up to where to go to. So stay tuned for the next video. That'll be really fun. I don't know. Yes, it'll definitely be fun because everything we do on this channel is fun. So stay tuned and be sure to subscribe. Hey, welcome to your last video on slicing. And in this video, we're going to talk about a starting number and an ending number, and we're going to try to use some positives and some negatives so we can just get the full spectrum of everything we're going to expect when we're dealing with slicing and trying to get a substring. So this is kind of part 3 of slicing, so if you're brand new, then maybe you want to check those out if you're struggling with it. However, if you're pretty familiar, this should give you what you need. So let's say we want to grab a piece of a string, and we know ahead of time we want to grab this word am. Well, let's think about where we would start and where we would stop to get this number. So to start, we're going to use just positive numbers, and then I'll introduce a negative number in after that. So let's first figure out where to start. So if we start at the beginning, W is index 0, and I'm just going to count 1, 2, 3, 4, 5, 6. So A is index 6. And the starting position is always inclusive, so if we want to include A, we need to put a 6. So 6. And then, if we do this now, we can just confirm that we get A. However, we want to get am. So the next step would be to put the colon, which will actually go all the way to the end of the string and ask the deep question, am I? Now what we do is we put what character we want to go up to, not including. So we want to grab 2 characters, so we want to go to index 8. So we'll get 6 and we'll get 7. Running it, and we get am. So we correctly grabbed that word. Now, if you wanted to introduce a negative number in here, you could actually go from the right to say where to stop. So this is -1, this is -2, -3, and then we don't want to include -3, so that's going to be our stopping point. So instead of 8, we could say -3, running this, and we get the same exact thing. So if you had a really, really long string and you just wanted to go up to like a few characters from the end, that is where a negative number is going to come in handy. If you're working closer to the beginning, then maybe positive numbers is where you want to go. Or if you want to grab a particular number of characters, you can do that as well. So as an example, let's say we have a variable start and we set it to 6. And then what we could do is we could say, instead of 6 here, we could put start. Then what we can do is we can go all the way up to start plus 2. So that's going to grab 2 characters. So numerically, you can think of it as 6 being on the left, and then 6 plus 2, or 8, being on the right, which is what we originally had. However, this works just the same. So as you build more complex programs, you're going to shift from concrete numbers to more general numbers and variables. So something like this might be more realistic in seeing in actual code. So as an example, a lot of times for software, there will be a generated username or code built off of someone's name. So for example, if instead of having this terrible poem, we had a name. So I'll change the name of the variable to name here. And you might search through the string to find a space or some other way of figuring out where the first name and the last name are separated. So we could have a start of last, and that would be index 6 actually. So we're already good to go. And then we wanted to grab the first 3 characters. You would just do start of last right here, all the way up to start of last plus 3. Running this, yeah, we want to update poem, obviously. Running this now, and we get cur. So a lot of email addresses I've had have been like calcur. I also have a URL shortener, calcur / whatever the link is. And it's just a common convention for names. So that is how you could, as an example, grab the first 3 characters of someone's last name. Now, generally, I try to only use negative numbers on the right side of the colon just because that's how I can easiest think about easiest? Come on, man, get your English together. That's how I can best think about it. However, you can experiment and try all kinds of different combinations to work with your slicing and just become a slicing pro. If anybody wants to spend their time building a game, what you could do is you could make sort of like a Fruit Ninja kind of thing where it's for programmers though, so it's probably going to be not as fun. And you're going to have a string up on the phone, and then a slice index range pops up, and you have like a certain number of seconds to like slice between the characters that you're going to keep. Right, so you can slice off the beginning, slice off the end, and you're left with what you have. I literally just thought of that on the spot, but that would be definitely pretty interesting, a good way to practice slicing. Now, there is something else in the documentation I want to show you guys, just if it helps you visualize it or if you're still struggling with the concept of slicing. And that is, when you're looking at indexes, it might help to consider them as the in-between of characters. So when you say you're grabbing from index 2 to index 4, you can visually see, oh, we start at 2, so that is why 2 is inclusive, and we stop at 4, which is why 4 is exclusive, because we haven't jumped that wall. So that is what I was kind of visualizing when I mentioned a wall in a previous video. However, maybe this will help you see it a little cleaner. This concept hasn't helped me a whole lot. However, if you're new or you're a visual person, maybe this will just hit the spot and you'll never have struggles with it again. Let me know in the comments below if this illustration is helpful to you guys, and if you prefer more visual things like that, or if you just like coding examples. So that's the end of slicing. Stay tuned for the next one. Hey, what's going on, everybody? In this video, we're going to be talking about something that I've honestly been putting off talking about just because it's a little bit more technical than what we've talked about so far. However, it is vitally important, and I'm going to do my best to make sure you understand it. Now, I left a subliminal message up here on the screen, and there's this really cool function that we're going to be using, and it's called ID, and you can pass an object in here, such as task, and let's print the return here. So whatever this function gives us. And this is a number that refers to where this object is located in memory. So the string is somewhere in our computer's memory. And what we can do is we can print this multiple times to confirm that the string stays in the same spot. So you can see that the number is the same each time. So each time we print this, the task variable is referring to the same string or the same object more generally. So trying not to get too technical here. However, the thing is that anytime we create a variable, that information has to be stored somewhere in our computer's memory, the computer's RAM. So what I want to talk about is the immutability of strings. And when we have a string such as subscribe, we can't go change this string to something else. So as an example, let me get rid of 2 of these lines because we only need 2 of them. Let's change the string to something else, like so. And running this, you can see we now get 2 different numbers. So the area of memory that this variable pointed to changed. And that makes sense because we are assigning it a different value. And in fact, strings are immutable, meaning once a string is created, we can't change that string. So if we tried to do something like this, we said task index 0, hey, that's going to get a character, but then let's say we tried to assign that something. So what if we said task index 0 and assigned it a lowercase s? Well, in this situation, we're actually going to get an error. Str object does not support item assignment. So in other words, the string cannot be changed. And the reason they worded it like so is because there are other objects that do support item assignment. So when we get into lists inside of Python, these are objects that are mutable. We can change all of the data inside of the list. And in that situation, printing the list twice, we would get the same exact value even if we changed the data. So if you understand this, great. However, if this is a little bit much for a beginner course, don't worry about it too much because we'll get back into this and we'll understand it better later on in this series. But let's just talk about a few things of why immutability is a good thing and why it's a good thing that we can't change strings. One of the big things with mutable data is that we can pass it around with an alias. We can create numerous variables to point to the same data. And as a result, the data can be changed in numerous different ways. And it can get a little sloppy and we can have unintentional changes to our data. This is actually not possible with Python. So, the only way we could, quote, change the data is if we replace it. But when we assign it to something else, that's not going to take effect. So let me just show you what I'm saying here. So let's say we said task, and we're going to do task plus an exclamation mark. Well, this just replaces the old string, even though it looks like we're adding something to it. So these both have 2 different areas of memory. So if we were to take the task variable and assign it to a different variable, any changes to this different variable will not take effect in the task variable. So if we then went and printed task, we'll take a look at this. It still says subscribe, even though we assigned different task and changed it to hey. This would work differently if we were working with mutable data because different would basically be an alias to point to the same object. To see a simple example of this with mutable data, we'll get rid of that printing the ID. We don't need that anymore. And we'll put this inside of square brackets. And then let's change that first piece of data. So we'll grab that first piece of data and change it to hey. Printing this now, when we print task, even though we changed this other variable different, those changes are shown when we print task. So these two variables point to the same data in memory, and we can avoid that problem when we have immutable data such as strings. So strings are immutable, numbers are immutable, there are some other immutable objects out there, and then there's a bunch of mutable objects as well. So lists are an example of that, which is what we're doing here. And yeah, so that was just a taste of some more advanced Python. Again, hopefully you understood this. Watch it a few times and really try to code out the examples so you follow it. And I'm not implying that this is too difficult. However, the purpose of this course is for absolute beginners. So if this does not make sense to you yet, do not worry, because we're going to come back to this and understand it at a much deeper level later on in this series and in other series on this channel. So stay tuned for the next video, because we're going to learn a very useful function for strings, and you'll be using this throughout your entire Python career. So stay tuned, I'll see you then. Hey everyone, welcome to your lengthy video. And I say lengthy not because the video is long, rather we're talking about a really important function to get the length of a string. Yeah, I know, my puns are fire. All right, let's get started. Let's just say we have message and it's please subscribe, because I'm desperate. All right guys, come on, help me out. And what we can do is we can print this message. Running this, and we get please subscribe. And what we can do is we can also print indexes of this. So for example, we can grab index 6, and that's going to give us a space, of course. And what if we wanted to actually figure out the total number of indexes in this string? So, maybe we wanted to loop through this string later on and grab each character. We need to know when to stop. And the way we can do that is with a special function, and it's actually called len. So here's how we're going to invoke it. Let me just move this down a line. We're going to say len and then pass in message. And it returns the number of items in a container. So the container being the string, number of items being characters. So this is going to return that. So what we need to do is we actually need to take it and put it inside of a print so we can get it out in the terminal, hitting run, and we get 16. So there's 16 characters. Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is correct. Now hold up, I know what you're gonna ask next. Caleb, could you please tell us the association between the length of a string and the indexes of a string? Of course I can, guys. So the indexes, the max index is always going to be 1 less than the length. So if we grab index 15, like so, this is going to be the E. Hitting run, and we grab E. So perfect. That's because the first character starts at 0, so it's shifted over 1. A very common mistake for new developers is they assume the indexes go up to the length, except they don't. They go up to the length minus 1. If you were to put 16, which is the length, we're going to get an error which says index out of range. Bad boy, don't do that. So earlier on we grabbed the last character by saying -1. Another way you might see something like this is actually getting the length, so length of the message, and then saying -1. That'll also grab the last character, and you can see we still get E. And that makes sense because we're going to get 16 minus 1, which is 15. The character with the index 15 is E. Alright, so that is the len function. Hopefully that'll come in handy, and we'll be using that throughout this series, because not only can you use it for strings, but you can use it for all kinds of stuff. So stay tuned, and see you in the next one. Hey everyone, welcome. In this video, I'm going to be showing you how to convert a number to a string, and when you need to do this in your code. So the very first thing is, check out my code here. We got this message. It says, please subscribe, hint, hint, print the length of the message. And when we run this, we get exactly what we would expect, 16. So we don't have to do any kinds of conversions to print a number. However, what if we want to tell the user of our application, your message is 16 characters long? Well, let's think of how we would write that. First, we would put a string here, and we would say, your message was, and then we print the number 16. So we'll put a plus here, and then another plus, characters long. So that is the concatenation that you would do in order to get this message out in the terminal. So running this, we get an error. Can only concatenate str or string, not int to str. So what that is saying is that you cannot automatically concatenate an integer to a string. So what you need to do is you need to say str parentheses, and you can see in here it creates a new string object from the given object. So if we pass a number into this, like so that's all your syntax. Let me zoom out so you can see it all. So what it's going to do is it's going to convert that number to a string, which can then be concatenated. So we'll run this, and it says your message was 16 characters long. So that's how you convert from a number to a string. Now, one other thing is you might not need to do this when you're printing data, and maybe just when you're doing other stuff in your code. Because instead of using the plus here, you can actually just separate your data with commas, get rid of that string conversion, and put another comma there. And this will automatically put spaces between your data and print it all out regardless of the type here. So it says your message was 16 characters long. So we get the same exact output with no conversion and no concatenation. We just have to use those commas. We're essentially passing each thing in as a separate argument. This option is not always going to be available to us when we're working with other functions, or we just need to get some variable with some data in it. However, for print, it works very nicely. So that's how you do that conversion, and stay tuned for the next video because we're going to be talking about nested function calls. Should be pretty simple, but also very cool. So stay tuned and see you there. Hey, what's going on everyone? This video, we're going to be talking about nested function calls and how to understand what's going on. So if you can take a look at this print statement and you can figure out the order of everything and where the parentheses should go, then you should be good. Go ahead and skip on to the next video. However, if you're struggling with balancing your parentheses and figuring out what order things happen, then this is the video for you. So we're also going to get into some tips and tricks, so stay tuned for those. But let's get started looking at this. So pretty much when we run this, we get the value 10, and the actual value that it gives back is irrelevant. I pretty much just nested a bunch of stuff just to get some practice. So when we have nested parentheses, so anytime we have parentheses like this, the thing in the most inner parentheses happens first. So let's take a look at our expression here and try to figure out what's going on, and we'll start here on the left side of this plus, starting with this age here. And when we pass something to this string, it creates a new string object from the given object. So this age 15 is converted to a string. So these parentheses are for the string call. Then these outer parentheses are for this ID call, which is a function we talked about that returns the identity of an object. And then lastly, we have these parentheses here, which includes this plus operation, math.floor 2.6. Once those two numbers are added together, they are converted to a string, which is then passed to the length function, which is then passed to the print function. So if you needed to break this out into the steps, it's going to look something like this. So we have the age, and then we convert that to a string. So we pass age in, and this is going to be age string we're going to need a bunch of variables here, so just follow along here. So that's the first thing we did. And then we got the ID of the age string. So that's going to be ID of age underscore string. Then that whole thing is added with the math.floor. So we could just create another variable other and say math.floor, pass in 2.6, add those up. So we'll say ID age of string plus other. That gets passed to string. So one more time, we will say added underscore string, and then pass that in like so. And then we get the length of that like so. And then lastly, we print that. So we say print and we pass in length like so. Ooh, okay, running that, we get the same exact value. So you can see how nesting is actually a lot cleaner because reading this, there's so many different variables and it would be really hard to go through this and follow. Although you can see step by step what happens, but this is a little bit more concise. All right, so that was pretty obnoxious. However, I think we figured out how to dissect something like this. You basically start on the inside, and then anytime there is an operator such as a plus, you usually go left to right However, there are some operators that go right to left, but we haven't touched any of those yet, so you don't even have to worry about that. And you keep going out and out a layer until you reach the final function. So that concludes the next section. The next video, we're going to pretty much review everything we've talked about from the last review and just go through each of the examples real quickly just to make sure we're all on the same page before going to the next section. Hey, this video, we're going to review everything we've talked about strings. So you can find this code up on GitHub, Caleb Curry, Python, and then beginner Python. And we are interested in O2-strings. And we're just going to go through all these different examples. Shouldn't take too long because a lot of it's just illustrating what we've already learned. And pretty much you should have a pretty decent understanding of all of this stuff before we move on to the next section. You don't have to have everything 100% perfect because, we're going to be using these throughout. However, it is a good idea to understand the majority of what's going on. So I'm going to zoom out. So hopefully it's not too small for you guys, but I just want to make sure we can see enough at a time. So I'm going to run this and we'll just go through the code and see what output we get and so forth. All right, so the very first thing is how to create a string. It's very simple. You just use double quotes or single quotes and we can assign it to a variable. We also talked about escape characters, and a really good example of this is the new line. If you want to print a new line, you would use a \n. If you want to actually print the characters \n, then you would need to use an additional \/ before the first \/ here. And an example of using escape characters is this Caleb here, where I put tabs between each of the characters and ended with a new line, which is how we get this output here. We have that new line after it as well. You can also use single quotes as shown in this example here. Only difference being is that single quotes are easy to put within double quotes and double quotes are easy to put in single quotes. So whatever you're working with more, if you have a bunch of double quotes, then you might want to use single quotes. So the next thing I want to show you guys is that you can print multiple things by passing them in as separate arguments. So in this situation, we printed two strings, Caleb and subscriber, which come from right here. Now here's some examples of single quotes versus double quotes. She said hi. Well, we have two double quotes there, so we decided to use single quotes just to save ourselves some time. However, if you wanted to use double quotes, you would just need to escape those double quotes. Same thing for single quotes. If you're saying I'm learning, you would need to escape the single quote, although within double quotes, you're totally fine to use it. So that's what all of these outputs are here. And then there's some other escape sequences in this link here you can use. I think that actually we should probably be using Python 3.0. It seems that the information there is relevant. However, we are using Python 3, so just make sure you got the most up-to-date info. Now, again, here's an example. If you want to print the \, you have to put 2, so that prints one \/ in the terminal. And actually, we haven't talked about this. This is an example of a raw string, and if you prefix with an R, we can put anything in here, and it works fine. So, for example, the \t is fine. We can do pretty much anything we want. We still have to escape the single quote, though, because that we're using single quotes to mark the beginning and the end of the string. And I just realized I typed this out earlier. I was like, what am I even trying to do here? It says wow. So it's W-O-W. I'm not sure why I typed that out like that. It doesn't really show much. The main thing in here is that you can type the T without having to put two \. It just does it by itself. So this is known as a raw string, and might be nice if you have a bunch of stuff that might be interpreted as escape characters and you want to ignore it, then you can just use R and it'll print it as is. Next up, I talked about concatenation. You use a plus to concatenate. So with numbers, it'll add, but with strings, it concatenates. Here's a simple example where it says Caleb plus subscriber. You can also use comma separated values in print as we showed earlier. So me, comma, the plus character, comma, you. And that works for print, although you don't always have that opportunity when working with functions, so you should understand concatenation as well. You can automatically concatenate literals, which is just actual values typed in your code, by putting them one after the other without a plus. And this is ideal if you need to split a large string up onto multiple lines. Again, the new line character is not put in the string, so it says, my name is Caleb, all on one line. Alternatively, you can use a multi-line string, such as name Caleb, age 58, and in that situation they come out on two separate lines, the new line is printed in that situation unless you use a backslash at the end of the line. So in this situation, if you want everything to be nice and lined up on the left here, you can just start with 3 quotes and a backslash to get everything over here on the left, and that new line is not printed, so we get that in the output nice and clean. And this new line is ignored, which is why everything is on one line here. Next up, we have a multi-line comment, and it's not really a multi-line comment, it's actually a string. We're just throwing a string out there, but we're not doing anything with it. And there's a debate on whether you should do that or not, but just showing you guys that for your benefit. Now, next up, we're talking about indexes. It's very common to grab particular characters within a string. It's also common for collections when we get to them. So for example, in this situation, we're grabbing the index 5. It starts as 0, so T has index 0. So if we grab index 5, it's 0, 1, 2, 3, 4, 5, which is I, which is where this I comes from. 0 will give the very first character, so message 0 will give you a T, and it does. The value is returned and can be assigned to a variable or used within an expression. Here we are assigning that character to this first letter variable, and we are concatenating it with the word acos to get tacos. So yeah, I just thought I'd cook up that example. And now we can also use an index from the right. So in the situation where we use a -1, it's from the right and it grabs the first character. So that is going to give us a period, which comes from right here in this message. We don't use a -0 because -0 is actually 0. And we showed an example of that. 0 is equal to -0, which is why we get true. And even when we print -0, we still get 0, not -0. Next up is slicing. So we have this very important message and we slice it to get high, which is pretty much the only thing important in there. Is a nice greeting there. And here are just some different examples you can follow. So this one prints index 0 to 4 because 5 is excluded. So up to index 5, not included. This one starts at index 1 to the end. You can also use negatives. Here's how you get the last 8 characters. And a bunch of different examples. So here is one with an out of range index. If you grab an index that is out of range directly, so if you say message 42, well, that is out of the range of the string, so this here is not going to work. However, you can fail gracefully using slicing because if it's not a valid range, it's still going to work. So next up is immutability. Strings are immutable, meaning they can't change. So if you try to assign a new value, change Java to Kava, which is the name of my dog, it's not going to let us. So sorry about that, Kava, but we're just going to have to stick with Java for now. We can, however, generate a new string from the old by taking this character and then appending everything except that first character. So that is one way to hack around it. Here's an example where we swap out Java for Python. So we say Python plus and then start at index 5. In printing that, we get Python is my favorite. Here's an example where we take the beginning where we say Java is, and then we append actually coffee, replacing the ending there because we stop before the character with the index of 8. So it's going to say Java is actually coffee, which is exactly what we get right here. Operations that appear to change the string actually replace it. So in this situation, if we append, contrary to popular belief, to this, it looks in your mind, you might think, oh, we're just adding to this string, it stays the same just with some extra stuff on it. However, it's actually replacing that string with another string that says Java is actually coffee, contrary to popular belief. Lastly, we have getting string length. You can get the length using the len function, and that returns an integer which we can print. The last index is always length -1, so index 4 is going to grab that B, even though the length is 5. So length is 5, the last index is 4. Here's some other stuff with strings. So here's how to convert a number to a string. We just pass it to stir and it will return a string which can then be concatenated with some other string. Alternative to concatenating, you can just use a comma inside of the print, which will print them just fine, which is how we get both these messages to look exactly the same. When we do put this in with a comma, it's going to put a space automatically for us. So when we put this space here, you can see there's an extra space right here. So another thing with the comma is that when we use it for a variable, it doesn't work, right? So in this situation, we cannot use a comma. If we say length is, comma, len of name, well, it actually gives us a different result than we would expect. So that's not what we want. Instead, we should assign it to a variable and convert it to a string and append it. Or you can do that all in line if you want. You don't have to use the variable. And that's exactly what I say here. We can also nest the function calls, not method calls. Functions, methods are very similar. Methods are attached to an object. These are technically functions. Try to remember to change that in the source code, but I'll probably forget, so just keep that in mind. All right, so that was a lot. Make sure you understand the majority of the things we just talked about, and stay tuned because we're gonna get into a new section and start to make some cooler applications. I'm excited, hopefully you guys are as well. Hey, what's up everyone? In this video, we're gonna be talking about lists. This is where things get really interesting with programming because we can start putting things in groups. I know, it's so exciting, right? But essentially, this is an example of a collection, and there are a lot of different types of collections in programming. In Python, one of the essential ones is a list, which allows us to add numerous things like so. For example, we can say ages, and we can put numerous values in here like so. Or we could say people, and we could put numerous values in. Let's go with Caleb. And the thing that is special about these in terms of syntax is you put the square brackets around the data, and the data is separated by commas. So this is a list of numbers, this is a list of strings. However, you don't have to keep everything the same type. So you could say something like my favorite things, and let's say we have a list of all my favorite things, such as working out, LOL, 7, and we could even put another list in here. Let's say Amazon Prime. You know, Amazon Prime is great. And Netflix, which just really isn't true. I'm not a huge fan of Netflix. All right, so this situation, we have a list with another list inside. All right, so let's print all these out and see what we get. So we'll print out ages, and when we do this, the list comes out in its entirety. So we don't have to slice or do anything crazy, and it's actually really easy to print a list. Whereas if you're coming from Java or something and you're trying to print an array list, it'll just give you like the memory address or something. So this is a lot easier. Next up, let's print people. There we go. And then lastly, let's print my favorite things. Running this, we get the list with a list inside of it. Now, one thing that is special about lists is that they are mutable, unlike strings. So in the next video, we'll be showcasing the mutability of lists and talk a little bit about indexes and slicing and all that good stuff. So stay tuned, yo. All right, peace out. All right, so you got all these lists, and now you're wondering, what in the world am I supposed to do with them? Well, the very first thing I want to showcase is that lists are mutable. And what that means is we can change them without creating a new one. So to show you this, we're printing my favorite things, and we can change one of the elements. Similar to how you would grab an element with a string using an index, you can do that with a list. So you just say my favorite things, and then inside square brackets, we could put a 0 for the first thing, and then you can change that to some other value. So let's put something a little less extreme in here, such as walking, and then we can print this. But maybe you're not convinced. You're not really convinced that that didn't recreate a list behind the scenes. Well, let's go through a way to prove this. We will say print, and then we'll use ID of my favorite things. And then we're going to do that after as well. So just copy that line. Paste that here. All right. Run it now and check it out. The two values are exactly the same. So we changed the data and we didn't create a new object in memory. It's still pointing to the same object. Now the items itself, well, the first one is a string, and strings are immutable. So when we changed working out to walking, the actual string was replaced, but the list itself stayed the same. So it's kind of like we had a bucket, right? And this bucket contained our favorite things. We took out working out, we tossed that, and we replaced it with a new item, walking. So that's how you can visualize how the mutability and immutability works when it comes to lists being mutable, but the strings inside of them being immutable. We just replace the items inside. Now another thing similar to strings is that lists, you can get the length of the list. So I can go down here and I can say len and pass in my favorite things. And this is going to return a number. So we will print that just to see what we get. Like so, saving and running, we get 3. So there are 3 elements, and you might look at it and think, I'm counting 4, working out, 7, Amazon Prime, and Netflix. However, because Amazon Prime and Netflix are combined within one element, another list, that just counts as 1. So we'll be getting more into 2D lists and how to work with them and stuff in this series, but for now, just wanted to show you those 2 primary things that you can change the data in a list using indexes, and we can get the length of the list using len. Thanks guys. Hey there, so in this video I'm going to be teaching you 2 different ways to copy a list. And you might need to do this if, let's say, you want to modify a list, but you need to keep a copy of the original values. Here's how you can do something like that. And there's 2 ways. So the first requires us to understand slicing, and it works very similar to the way it works with strings, except that it's going to return a list. So here's an example. We could say print my favorite things, and inside of the square brackets we could say we want to start at index 1 and go up to, but not including index 2. We have a pretty tiny list here, so I'm keeping my numbers pretty small. So that's going to start here and go up to index 2, so it's just going to return 7. But the thing is, it's within a list. See the square brackets? So what if we got rid of the beginning and the end, and now it just does the whole thing? Well, there you go. You just made a copy of this list, and you can do something with it. So for example, instead of printing it, we could assign it to a variable. So we'll just say copy and assign it that right there. And now we can print copy. And there you go. And this is pretty cool because if we go in here and we change copy index 0 is now going to be walking. And then let's say we print these 2 things. We say my favorite things and copy. Running this, you can see that the first one remains working out, but the new one is now walking. So they're 2 separate objects, and one change in one doesn't affect the other. And what I just said is important to realize. These are 2 separate objects. And the reason it's important is because you might think to just do this. Instead of doing this, you just assign my favorite things to copy, and then we modify copy. And look, when we run this, the changes is actually in both of them. Walking is here and walking is there. So we're not making a copy right here, we're just making an alias. Copy is an example of an alias. It's a new name to refer to the same object in memory. So changing it actually changes my favorite things and copy because they're the same thing. So you need to make sure you copy the list when you want to make changes and not affect both of them. So that is how you do that there. And another one, it's actually probably simpler. You just say dot copy like so and put parentheses. So that is the other way to do it. And now we can change walking in one of them, and it is only available through copy and not in the original. So this is also an interesting time to point out that this function is attached to this object with a dot. So this is called the dot operator, and it's how we can grab functions for a particular object. So it's a little bit different than putting the function at the beginning and passing my favorite things into it. Such as what we're doing with print. We say print and then we pass an object into it. In this situation, we have the object and then dot and then the function name. So it's a little bit different on syntax of calling them, but they work pretty much the same way, and we will see both variations throughout this series. So that is how to copy a list, but the thing you need to know is that this is a shallow copy of the list. And if you're wondering what that means, you can check out the next video because that is what it's going to be about. See you then. Hey there, in the previous video I showed you how to shallow copy a list, and I think ultimately we can make a deep copy. However, I know I said I was going to show you that in this video, but I want to work with nested lists a little bit first so we can be more familiar with them before we talk about deep copies in the next video. So a nested list is just when you have a list inside of a list. So in this situation, we have a list that says Amazon Prime and Netflix. So if you want to grab that list, consider it to be one element within this bigger list. So it's going to be index 2 because we have 0, 1, and then 2. So if you want me to prove that, all you would do is say print and then pass in my favorite things and then square brackets index 2. And when we do this, we actually get a list returned. So we get that list returned, and now we can treat it like any other list because it is. So we could use indexes to grab elements. So to do that, we just do another set of square brackets and pass in data here. So this is going to grab Netflix and print it out to the console right here. So if someone asked you what my favorite things index 2 is, you would say it's a list. If people instead asked you what index 2, index 1 is, you would say it's a string, in this case Netflix. This is important to understand because we can actually have several layers deep of lists, and it's very dynamic. You don't have to have it in a perfect 2D structure or anything like that. So we can actually go in here and we can make Netflix its own list, and maybe we could add some other streaming services in here. So we'll put a comma and throw in Hulu. And now when we get index 2, index 1, we're actually getting a list of Netflix and Hulu. If you wanted to grab this string, you would just pass in another square, index 0. And there you go, Netflix. Now keep in mind, anytime you're working with a list, there are different functions you can use with it. So for example, let me back up one index here and work with that nested list of Netflix Hulu. Because this is a list, we can get the length of it by passing it to the len function. And running that, we get 2. So now to go back to the whole concept of mutability, if you remember, I've mentioned strings are immutable, but lists are mutable. If we have a list of a list, we have to be very careful when copying it because of this mutability concept and the fact that we can do aliasing. Stay tuned for the next video because I'm going to showcase an example where you need to really be careful with this mutability thing because of aliasing, and it could be helpful to you, but it might also bite you in the butt. So stay tuned and I'll show you that. Hey everyone, in this video we're going to be talking about copying lists, and specifically I want to get into deep copying lists. So when we talked about copying earlier, we were talking about shallow copying. I'm going to show you what the difference is. So first let's talk about how we learned to copy lists before. You would say my favorite things dot copy. And this is going to return a new list, so we can assign it to something such as copy. So now my favorite things and copy have the same elements, but they are two separate lists, and we can print them both like so. And when we run this, you can see we get the first one and then the second one. Same exact data. Now if we go in here and change something, so let's say copy index 0 is now assigned the value walking. Well, this is only going to show up in the copy because it's a copy and they're not pointing to the same thing. So if I print the data again, running it now, you can see walking shows up in copy, but not in the original. But what if I change something within a list inside of the main list? So in this situation, we're going to grab index 2 and index, we'll just go index 0. So we're going to change Amazon Prime and we're going to change it to Hulu. So running this now, the change is apparent here, but the change is also apparent in the original. What in the world is going on? If it's a copy, why is this change to the copy affecting the original? And that's where shallow copies have their issue. Shallow copies make a copy of all of the immutable data, but any of the mutable data that we can create an alias for, such as lists, those are not copied value by value, but rather there's just an alias to that same list. So because this is a list inside of the outer list, the copy is going to point to the same area of memory and changes will be seen in both. So let me word this one other way. Copy of 2 is going to point to the same area of memory as my favorite things to. So this is just an alias for the original. And if you want to see that, what we can do is we can actually use the ID function and confirm that they are in fact the same value. So passing these into ID, and then we'll pass them into print, which, by the way, if you highlight over something and you use the left parentheses inside of Visual Studio Code, it'll surround it, and then you can just say print. So that might save us some effort, like so, print. All right, running this, and you can see we get the same exact value. So with a deep copy, these values would be different, and they would be two completely separate lists. So that's what I'm going to be showing you now. What you need to do is we need to import copy. So up at the top, we're going to say import copy. And then within this module, we can say, instead of copy here, we're going to replace this line with copy.deepCopy. And this is going to take the thing we want to copy. So we're going to copy my favorite things. And this is going to return a new data, which we can assign to a variable. I was using the variable named copy, which is what we just imported. So I don't want to use that. So we'll just call it C. And then you'll want to change C anywhere we used it. So C, C, and C. Running it now, you can see that these numbers are in fact different. So that is how you do a deep copy in Python. If for some reason you had more nesting, you had lists of lists of lists, this method would still work. You would just have to call deep copy once, and everything is going to be copied value by value into a new object. So it's safer if you need to make sure you have a complete copy. But do keep in mind, if you're working with some pretty big data structures, this might hurt your memory. And right now we're not even have to worry about that, but in the future, you're essentially making two of one thing, so you're going to double the memory consumption. So just keep that in mind, and thank you guys for watching. Stay tuned for the next video. Hey there, what's going on? This video, I just wanted to talk briefly about combining lists. So similar to how we can use the plus for math, or we can use the plus to concatenate, we can also use the plus to combine lists. It's very simple. So we'll just do this within a print. So we can take my favorite things and add my least favorite things, which I guess I should put underscore things to keep things consistent. However, not a huge deal. So running this, we get one giant list right here. And I just put JavaScript in there just to start some fighting in the comments. So let me know if JavaScript is the worst thing in existence. We could do something like this to add an element to a list. So for example, we could say least favorite things is assigned least favorite things plus, I can't think of anything else I hate. Editing, definitely the worst task in existence. And then when we are done with this, we will just print least favorite things. And running this, you can see we get onions, JavaScript, and editing. Now there's also a method that you could use instead of doing this technique, just to make your life a little bit easier. And that is going to be least favorite things dot append, and then you just pass in the data, editing. So just showing that there's various ways of doing things, but I would stick to the append method. It's probably the best way to do it, and it works exactly the same in terms of output. There's also stuff we can do to insert at the beginning of the list or in the middle of the list, but these are more advanced things, and we'll probably get into that later in this series or in my next Python series. So stay tuned for upcoming content. That's summing up our introduction to lists. The next video, we're gonna do some review and just make sure we got everything nice and square in our brain. I don't know if that's the right expression or not, but we're gonna make sure we understand things. So stay tuned and I'll see you then. Hey, welcome to your list basics review. You can find all of this code up on my GitHub account, Caleb Curry, and then go into my Python repo and then beginner Python. We're gonna be taking a look at O3 list basics. So you can copy that and paste that in a file, or you can download it. And from here, we're just gonna run this and just see what we get. I'm also gonna zoom out a little bit just so you guys can see everything. All right. So making a list is really simple. We just surround things with square brackets. This is a list of numbers. This is a list of strings. However, you can mix data types. That's totally fine. So in this situation, we have a string, we have a number, and we have another list which also contains strings. We can print an entire list just by using the list name. So here we're printing all three of those lists we just made. which is where these three outputs come in. So we have 20, 25, and 20, which is right here. Then we have our names here, and then we have our My Favorite Things list. You can use indexes to grab particular elements. So if we go ages index 2, that's going to go index 0, 1, 2, and grab 20, which is where we get this 20 in the output. We could also grab a list. So if we grab the index 2 of My Favorite Things, we get this entire thing, which is a list itself. Now lists are mutable, so we can go in and change any of the data. So we changed all of the data for the ages list and printed it, which is where we get 5, 10, 15. The actual numbers themselves were replaced, but we're not creating a copy of this entire list every time we change it. We're just replacing any particular element, which works just fine. The example I gave in a previous video is you have a bucket full of numbers, you take out a number and you put a number back in, but you're not throwing out the bucket and getting a new bucket each time. We can also slice with lists. So for example, we do ages with a 1 colon, and that's going to start from index 1, which gives us 10, 15. So we get these two pieces of data right here. We also show a little bit about updating lists using slicing. So for example, we grab the index 1 forward and we change it to 6, 7. So now when we run it, we get 5, 6, 7. So pretty much we replaced 10 and 15 with 6, 7. Copying lists is pretty simple. You might think to do it this way, but this is incorrect. This is actually going to create an alias. So names and names too both point to the same object in memory, so changes in one will be seen in both. So changing Caleb to Caleb with a K and printing it, you can see that the changes are going to be seen in the original right here. Even though we made that change through this new variable names too, the data is seen in the original variable because they both point to the same area of memory. We changed the area of memory, and then when we access it from a different variable, it's still changed, obviously. So be careful with aliasing. You might want to do it in certain situations, but oftentimes you're probably going to want to make a copy, which you can do like so. So now names 2 and names point to two different lists, and changes in one do not affect the other. You can see my notes explaining how this indexing thing works if you're interested, but just to show you guys, we change it to Caleb really long, and then we print the original names, and that change is not seen. Another alternative is to use copy, and same thing, we print it again, and in both situations, we get Caleb as the output. Next up, we just talk a little bit about methods. So when we do list.copy, this is an example of a method. It's just a function that's attached to an object, so it works pretty much the same way. You just have to use the dot operator on some object, such as this list. Names works fine. I think there's a little mistake here because we should be copying names 1. But I think the output should be exactly the same. Yeah, it's fine. Nested list basics. Well, we can nest lists like so, and then when we grab that index, we actually get a list in return. Treat it like a normal list. So in this situation, we're assigning it to another variable. We can print that, and we can also access individual elements such as Amazon Prime. You can also do 2 square brackets. So My Favorite Things 2, 1, which will also grab Amazon Prime just the same way. If there are a ton of square brackets, you can deep dive into this list using a sequence of square brackets, and in this case is 0, 0, 0, 0 because there's only one element, and that'll get us the deep dive value. Because of the versatility of lists, you'll see them a lot, so hopefully you guys are getting used to them a little bit. Now here I talk a little bit about shallow copying, and this is probably the most confusing part of what we talked about. Creating a list and making a copy of it like so is going to make a copy of the list, so it's not pointing to the same list in memory. However, any nested lists are just going to be aliased. So what that means is if we change the original here and update it to audible, well, in that copy, My Favorite Things 2, that change is going to be seen, and you can see it is right here when we print that second list. So if you want to fix this, you can do a deep copy, and in that situation, you just say import copy and say copy.deep copy. And in this situation, you pass in what you want to copy, and it's going to return a deep copy, which we assign to My Favorite Things 3. So now when we update the original to Hulu and then print the original and this new one, you can see that they're different. So scrolling down a little bit, you see Hulu and Audible. They are not the same thing. So for example, you can concatenate strings, but you can also concatenate lists, or essentially just combine them. So we have the good and then we have the bad. And if you mix them together, you have just right. So, if you eat a little bit of kale, a little bit of fries, you're going to be a pretty healthy individual. Probably not, but you guys get the point. We say good plus bad, print just right, and we have a list containing all of it. And then we just have another example that we can just do the addition right inside of the print statement, just kind of reiterating what we've been talking about through this series, that you don't always have to assign things to variables. So that was a lot. Hopefully it was helpful. Just stay tuned for the next video because we're going to get into some new stuff. Hey, welcome back everybody. We are on video, like 39 or something? I don't know, but I've been going hard on this. Hard on. It's 11:20 and we're going to be talking about input. So what in the world is input? Well, I'm going to be telling you. So let's write a program if I was to ask you a question. So let's say I said print, and in here we just put something like, hey, what's your name? All right, awesome. So we run this and it gives us the output, which sometimes it looks funny. Run it twice. All right, there we go. Hey, what's your name? Now, if you want to actually get this data from input, and this is where things get magical, you just say input. And this is actually going to return what they type. So we'll say name and assign it this function call. So running this, what's your name? We can type in Caleb and hit enter, and the program ends. So what do we want to do now? We can actually output this name. So we can say print and pass in name. So now when we type in the name, it should repeat it back to us. So we say Caleb, and we get Caleb in response. So here is the response. Now this is really, really cool. I know it seems simple, but this is the foundation for building complex applications, because now each time we run the application, it changes because we can put in a different input. And we're actually really far into the series to not have seen any examples of a dynamic program. A dynamic program is a program that each execution is different. We have different paths in our program, and it's all built upon input. It can be input from, in this case, the terminal, or we could get input from a database or a text file or whatever it might be. We can use this input just like any other string. So for example, we can do concatenation. We can say hello, comma, and then the person's name. So you just put a plus there and run it here. It says, hey, what's your name? We put in Caleb, and it says, hello, Caleb. So imagine you sign into a website and it says, welcome, Caleb, or whatever your name is, probably something like, welcome, nerd. Roasted. And in that situation, it's dynamic based on what name you put in when you signed up. Well, this is how something like that is done. It's done with concatenation using some variable that contains your name. We can also get numbers. So for example, we ask another question. Let's say we print and we say, what's your favorite number? And now we say fav num, and we get it from input. Running this, hey, what's your name? Let's go through with the input. We put Caleb, what's your favorite number? 7. And it appears to be working, although we're not doing anything with the number. So what I want to do is I actually want to get two numbers and add them together. So we're going to say fav num2, and that's also going to come from input. And then we'll do another print just so they know what to do. Give us another number, like so. And then after, what we're going to do is we're going to say print, and we're going to add these numbers together. Fav num plus fav num2. So we're going to do some basic addition. Let's say they put in 7 and 10. We want to give back 17. Except this isn't going to work, and you'll see why in a second. So we run this. Hey, what's your name? We say Caleb. What's your favorite number? 7. Give us another number, 10. And it says 710. What? That's not how math works. Well, math with strings works that way. It is actually concatenating these two values. That's because if you take a look at this input function, whenever we say input, you can see that the return here is going to return a string. That's what this arrow here is. So because the data that is stored in these variables are strings, when we say plus, it defaults to concatenation. So we've talked about how to convert numbers to strings, but now I want to talk about how to convert strings to numbers, and that's what the whole focus of the next video is. We're going to be talking about type conversions. So yeah, if you don't want to be lame sauce, you probably want to check out the next video. I will see you there. Well, I'm not actually going to see you, but yeah. So by this point in your Python career, you probably understand that different types exist when it comes to data, because the number 7 can be considered a number, or it can be considered a string that just happens to have a number character in it. And the data type is actually very important because the way our code works depends on the type. You know, if we say 7 plus 7, if it's number data, then we're going to get 14. If they're strings, we're going to get 77. So although in Python, a variable does not have a specific type, so for example, we can just say variable and assign it hello, and then we can say variable and assign it the value 5. This is totally legal. And just to see this, I'm going to get rid of all this for a second. We can run this and we don't get any errors pop up in the terminal. Other programming languages, this is not the case. For example, inside of Java, not to teach you guys another programming language, but you know, it's nice to know some differences. You would have to say something like this, int variable, and then assign it the value 5, because 5 is an int. Then if you went and tried to assign a value to variable such as 5, you would get a type error and it would actually not even allow you to compile your code. Python's a little bit more dynamic in that the variables do not have specific types. That being said, just because the variables don't have specific types, they can change, the actual data assigned to them always has a type. This is a number, and this is a string. And you've probably realized that they're different, but now I want to be a little bit more systematic about talking about how to figure out the type of a piece of data, and we can even check the data inside of a variable, as well as converting between different types of data. So I'll show you guys how to do that, and I'm going to keep this here if you guys want it, because we're probably going to be using that in a second. I'll just leave it commented out and scoot that down to the bottom. That's just working with some inputs, numbers, and strings. So now what I want to do is I want to show you how to check the type of a piece of data. So what we do is we say type, and then inside of parentheses, we pass any piece of data, such as 5. And what we can do is we can print what this gives us inside of the terminal. So running this, we get class int. Now we'll probably get to classes in Python at some point in this channel. We've already covered classes in other programming languages. We just haven't gotten that far with Python. But you know, the future is bright here, and we'll probably get to that really soon. However, the main thing you need to pay attention to is this int. So 5 is an instance of type int. If we try a different piece of data such as hello, well, this is going to say stir, which is short for stir fry. We could also try a different type of number such as 5.5, running this, and we get float. So a float is anything with a decimal value. So now you can see that programmatically, these are seen as very different. They are not the same kind of data. So if you want to know more about this, here is an article so I don't have to teach it. And in this, you can see how to convert data. And in here, you can see examples such as this stir function, where we pass in data and it gives us a string representation. We have used this already in this series, but what if we want to do the opposite, take a string and convert it to a number? Well, we'll find that in this article, but I wanted to mention that these functions are special and that they're known as constructor functions. Don't worry about the details for that, but you can search constructor in here and realize that the constructors int, float, and complex can be used to produce numbers of a specific type. So they work just like functions. The only difference is that they create a new object of int, float, or complex. So that's what constructors are used for. So when we want to create an integer, we would just say int and pass in the data to these parentheses. So let's give it a try. Instead of using a 5.5 here, let's just go with something inside of a string such as 5, and we're going to convert this to an integer by putting it inside of parentheses and passing it to int. So we're taking a string, converting it to integer, then we are checking what type it is and printing it to the console. So there's a lot going on here, but ultimately we should get the result int, even though the original data was string. So the conversion worked. Now again, if you put something in here that doesn't make any sense, it's gonna break. So we try 5GGG and we get an error. So you gotta be a little bit careful. We could also convert this to a float like so, running this, and you can see it's of type float. So this will be important for inputs where we need to work with numbers, because any input automatically is a string. So let's uncomment this and just go through an example. And the main thing in here is we are getting two numbers, a favorite number and then a favorite number 2, and we are adding them. However, these are going to be strings. So what we want to do is we want to convert them to numbers, since we're going to be using them for arithmetic. So we would say int and pass this in like so, and do the same thing down here for the other input. So the way this is going to work is it's going to get the input first. That's going to return a string such as 5. That string is going to be passed into this int here, and that's going to return a number variation. So this will be replaced with 5, which will then be assigned to favorite number. So that's how it's going to work, and we'll just run it just to see what happens. Yes, we'll put our name in there. It's kind of irrelevant, but 7 and 10. And we get the result 17. So that is the basics of type conversion. Now you may want to do a more complex sentence that says what you're doing, so follow along here for a second. We said print favnum plus the plus sign plus favnum2 plus an equal sign. And what does this equal? Well, it's going to equal favnum plus favnum2. So pretty much I want it to visually show us the process in the terminal. So I want it to say 7 plus 10 is equal to 17. So that's what this line does. However, when we run this, we're actually going to get an error. So we run this and we say Caleb is our name. What's your favorite number? 7, 10, and we get a type error. We don't want to do the conversion inside the parentheses, but we want to convert the result. So this will be passed to stir like so, and we'll do that for all of these. So this needs to be converted to a string, and lastly this one as well. All right, so that is the final code. It's a little sloppy, but it does the trick. So we're taking this integer and we are converting it to a string to concatenate with this other string over here, and then concatenating that with the result converted to a string. We'll go through the process here. What's your favorite number? 7, and another number is 10. We get 7 plus 10 is equal to 17. Awesome, so that's the basics of user input, and eventually what I would want to do is I would want a case on the person's name basically saying, hey, if your name's Caleb and your favorite number is this, then you win, you guessed the right info, or like you're welcome to use this app or whatever. So that's why I was getting this name and also some numbers just to get a variety of experience, and later on we'll learn how to branch and do some more complex stuff. But for now, I want to review the user input real quick, and then we'll get on to new types, and it should be pretty exciting. So stay tuned for the next video because it's going to be awesome, like you. Hey guys, welcome back. So in this video, we're going to review user input. And I know we just talked about it for a couple videos, but we got the essentials, and honestly, user input is actually very simple in Python compared to something like Java, which probably makes you want to pull your hair out if you're a new developer because it's just a pain. Heck, why don't I just show you how to do it in Java? You know? Oh, it's broken. We're already off to a bad start, guys. Psst. What is going on, man? Oh, there we go. All right, it's doing something, guys. So first thing, you got to create a new project, which I did to save time, and then new class. And then you got to select this public static void main args and give your class a name such as input. And then this is the boilerplate code just to get anything running. And then if you want to get data from the user, you have to say scanner is a new scanner. And then inside of the parentheses, you have to say system.in. And then you have to hover over scanner, import scanner from java.util. And then to get the actual value, you have to do string name is scanner.next line. And then if you want to print the name, you have to do .print line and then pass in name. Whoops. Name. All right, and then you're supposed to hit run, and it's supposed to do something, although it's not. So you can see that it's a lot of work inside of Java, which you can do the same thing in Python in like one line of code, which is literally just input, and then you assign it to a variable. So anyways, you can get this code up in GitHub. My username is Caleb Curry, and then just go to the Python repository, and we are under 04 user input. And I'm going to take all this and paste it into an editor, and we're just going to go through it, make sure we understand everything. So paste that in here. So the very first thing I wanted to show is that you can get user input and assign it to a variable, and then use that variable within an expression such as this here. And it can automatically be concatenated. We're using a string and a string, no issues at all, and it will get that input right here. So we put in Caleb, and it says, hello, Caleb, right there. Next up, asks us for our favorite number and a second favorite number. So we can throw some numbers in here, 50, and another one would be 25. And it says 50 plus 25 is 75. It also shows the types here in case you're interested in seeing them. So it prints the type of number 1. It's of string. And then if you want, you can cast those to new types like so. So we assigned it to new num1 and new num2, which we printed those types, and we get int right there. And then we showed how to print that back out. You actually have to convert it back to a string. That's one of the downsides of Python. In Java, anytime you print to the console, it'll automatically convert stuff to string. But nothing's perfect, so we just have to do a little bit extra work, convert that to a string. This situation, num1 and num2 are already strings because we are using the original variables, which we got from the input, and then new num is the integer version. So in the example we did in the previous video, we just converted automatically from the console, so we had to do another conversion there, but in this case, we're already in string, so we're good to do concatenation. If you're certain you're going to get a number, it's best to cast it right away, which is pretty much what I was just saying. So in this situation, we know we're going to get a float. Give me a third number. I'll say 5.5, and that's going to be assigned to num3. And then it adds all the numbers together to get 80.5. Which we can do seamlessly. We don't have to do any conversions. And this is an interesting thing to point out. We have two integers and a float, and we can add those all together. We don't have to do any type conversion there. That's different than if we had a string and a number, which we can't automatically add together. So that is the basics of input, and it's really the foundation for dynamic applications, and we're going to be using it for the rest of the series. So make sure you understand everything, and I'll see you guys in the next one. We're going to be getting into new types, so Booleans. Booleans are great. Now the question is that a true statement? I don't know, that's up to you, and that's what we're gonna find out in the next one, so see you then. Hey, welcome everyone. In this video, we're gonna be introducing the concept of logic in our program. And logic is actually really cool because it is used to branch in our software to do different things, as well as loop. So if we wanna do things forever or for a certain number of times, we can do that using logic. Now, the basis of logic is something known as the Boolean data type, which has one of two values, either true or false. So we can create a variable such as happy, and we can assign it one of these values. But how do you actually do it? Do you put it in quotes, or is it just a word by itself? Well, it's actually a word by itself, and the first character has to be capitalized. So we would say true. So that is how we create a Boolean literal. This is a Boolean literal of the value true. We could also instead put false. And I'm not happy when the phone rings, so I'm going to leave that at false. I don't know if you guys can hear this, but man, I must be popular today, or that psychopath Claire is on me again, so we're just going to move on and pretend that's not ringing. So what you can do now is you can print this variable like so, hit run, and we get false in the terminal. So this is the basis, but we can do more complex things. So we can check things and see if they evaluate to true or false. So let's say instead of having a false value right here directly, we have some number, age, and let's just say this person is, we'll just go with my age, 15. And yes, that's true. I started my YouTube channel when I was 4.5. And we're going to print age greater than 21. So this is an operator. It's a comparison operator, and it's one of the things we can do to check values. And that's going to be used in the if statements we're talking about next, as well as the loops coming up. So run this bad boy, and we get false, because obviously it's not greater than 21. Another one would be less than 21, which would actually return true. So that's what these operators do. They compare values and they return either true or false. So just like we assigned true to age earlier, we could assign an expression like this to a variable and it's going to have the value true or false. So let's see. Let's say we have a variable can drink, and we can check it using this expression. Age is greater than 20. And instead of printing this comparison here, we could just print can drink. So at least where I'm from, you're not allowed to drink until you're 21. So the first time I tasted even water was age 21. It was crazy. I was really dehydrated, but somehow we survived. And when we run this, we get false. So let's break this down. Age is 15. It checks to see if age is greater than 20, aka 21 or higher, and it evaluates to false. That gets assigned to this variable can drink, which we then print the value and get false. Now, wouldn't it be cool if we were making an app for like a wine service to send wines to people, and we wanted to ask the person's age, and if they are 20 or under, then we say, hey, we're not able to service you. However, if your age is 21 or higher, or whatever the age is for their country, then in that situation, we would allow them access to the app. Well, we can do something like that with an if statement, and that's what we're gonna be talking about in the next video. And this is where programming gets a little bit fun. So let's go have some fun finally after like 41 videos of boring. All right, I'll see you then. I'm ready. Hey, welcome everybody. In this video, we're gonna be branching for the first time in our program. That is, if you're ready. All right, that was pretty bad. I actually recorded this once and said that accidentally, and I was like, dang, that's pretty good. All right, so what are we going to be doing? We're going to be creating an if statement, and this is what it's going to look like. So right now, we're checking if this person can drink alcohol, because we're going to be building like, a wine subscription service where we send wines to you every month, and you have to be 21. So at some point, you could probably calculate this from a birth date, but we're just going to be using simple integers to keep it nice and simple. But later on, you can do whatever you want. So where I live, you have to be 21 to drink. Now, if you're from like Germany or something, maybe it's like 12. So change it as needed. But for us, we're going with 21. So that's why age has to be greater than 20. So instead of just printing can drink and getting false, what if we checked and branched depending on what that value is? Here's what that's going to look like. We would say if, and then we could take this comparison right here and cut it and paste it right here. And we can just get rid of that variable. So if age is greater than 20, colon, and that's important, don't forget the colon. That's the first time we've used a colon in any of our code. Then what you do is you hit enter and you put what you want to happen if the person is over the age of 20. So we can print, welcome to our app. So right now age is 15, so this is going to be false, and it doesn't execute if it's false. So every time I run this, nothing happens. But if we were to change age to 50, well, hey, now we run this and look at that. It says, welcome to our app. So there is your first example of branching. Now, the cool part is we can actually get this number from input as long as you remember to cast it. So we need to pass it to the int constructor like so. Run this bad boy and check this out. It's asking us for our age. We put 50 and it says, welcome to our app. Now, anything after this if statement is still going to execute. Just make sure you unindent. So we'll say print, thanks for trying our app. This is going to execute either way. So if we run this and we put the value 50 for our age, it says, welcome to our app. Thanks for trying our app. If we run it again, and this time we say 12 is our age, it says, thanks for trying our app, and it completely skips this line right here. So yeah, now our app is dynamic. We've covered two different cases, one where the age is greater than 20 and one where the age is 20 or lower. The only improvement I would suggest is to actually prompt the user for their age. So we could say, print, what is your age? Now when we run it, it asks us our age, which is a more appropriate thing to do for our application. You can say 21, and it says, welcome to our app. Now we are going to build upon this if statement, but one thing I wanted to talk about in the next video is this whole argument of spaces versus tabs and what in the world's going on with that. So stay tuned for that, and don't you dare forget to subscribe. All right, see you then. Hey, welcome to tutorial 44 for Python. This one, we're gonna be talking about tabs versus spaces. So the thing about Python is that it's very touchy when it comes to indenting code. So for example, if I take this print and I tab it over and try to run this, well, it says indentation error, unexpected indent. This is different than other programming languages, for example, Java. That's because the indentation is important for Python to determine when to run your code. So, for example, in this if statement, this indentation indicates that we only want this print statement to execute when this is true. This one, however, is not indented, so we want that to execute all of the time. So it is not a matter of good coding practice or proper style. That's not the issue here. This is an issue of correct or incorrect code. If you indent something incorrectly, then your code is going to run incorrectly. So this content is vitally important, and it's essential you understand when to indent. And I will be telling you guys that, but essentially, if you're in an if statement, you can indent. If you're in a loop, you can indent, and we'll show you any cases that come up in the future. But here's where it gets less important, and it's more of a proper style thing, like what is the convention? And that is, for this space here, should you use a tab or should you use spaces? So a tab is going to be able to push everything over like so, but so would 4 spaces. So if I brought that back and said space, 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 that works as well. And either way, the code is going to execute the same. So you don't have to be freaking out about making sure you don't accidentally put a tab so your code breaks. That being said, it is proper style to use 4 spaces inside of Python. Now, maybe I'm just picky and I don't want to be pushing spacebar 4 times. I mean, that's crazy. So I actually use a tab. However, the editor that I'm in replaces that tab with 4 spaces. So you can see all 4 of those spaces are still there. So tabs are automatically replaced with 4 spaces. So I'm able to use tab to my advantage, but I know that my code is correct. So if you're in a really crappy editor or you're just using like Notepad, which please just at least do Notepad++. But anyways, there might not be an automatic conversion from tabs to spaces, so you just got to watch out, and I would recommend to do 4 spaces. And if you're wondering where I got that crazy idea of using spaces over tabs, well, I actually got it from the Python documentation, so I would consider that to be the official way to do it. Now, you will find religious camps of like, if you use tabs, you're like a terrible human and deserve to die. And you'll find other people that say the same thing about spaces, but I think the majority of people have come to agree that spaces are the way to go and that those tab losers need to stop programming because they're worthless and you got to use spaces. All right, but enough on the tab versus space war. What I want to do is move on to making this if statement a little bit more complex by adding some different conditions to it. So stay tuned for that. I'll see you in the next one. Hey there, everyone. This video, we're going to be talking about how to create extra branches in your if statement using elif and else. So right now we are checking if your age is over 20. We can actually make another condition by pressing enter there, backing up so we're no longer indented, and then say elif, and then we put another condition here. So let's say, you know, if you're like a senior citizen, you get like a discount on our app, right? So I don't know, I think it's 65 when you're considered old. Oh, not sure. And then we'll say is print, and we'll say, hey, you get a special discount. Now the thing is, only one of these will ever be hit. So it's not the case that if someone is 75, that this is going to happen because it's true, and then this is going to happen because it's also true. Because there's this L part, which is short for else if, so it's one or the other. And since the first one's going to be hit first, then that is always going to be hit. So let me show you what I mean. We run this, what's your age? If we put in 85, it says, welcome to our app. So this passed as true. It said, welcome to our app. And then it jumped down to this line here. Oh my golly, Claire. Hello, this is Taco Bell. How can I help you?
Like 50 tacos.
50 tacos?
Yep.
You're not Claire. I thought this was Claire. Okay, I lost my train of thought there. So the elif is short for else if, so only one will ever be executed. So what you can do is you can switch the positions of these. So we could take this one, cut it, and move it to the top. So I'll show you what I mean in a sec. Just follow along here. Paste that there, and then switch the elif to down here. All right, so now when we run this, we put in 85, and it says you get a special discount. We run it again, and we say 30. It just says welcome to our app. So the order does matter. Now there is another option, and that is a catch-all else statement. Now I call it a catch-all because if we go through all of the if or elifs and none of them are true, the else will be hit. And it is optional, like I just showed you the app worked fine, but if you want to say like, oh, you're not old enough, this is where you would do it. like so. Running this, we can try to put in a really low age, such as 1. Running this, and it says you're not old enough. Although this is always hit. So after the if statement, all of these together, you can just consider it as one giant block. It'll just go down to line 11 and continue executing. So let's open those back up, and we're going to be building upon the logic for our application. Right now we're using the greater than comparison operator. There are other ones. So, maybe there's this really special case. If you're 21, this new wine app is going to give you a special to try to get the new people that just turned 21 subscribed to this monthly wine service that we're working on. So we could do that after this one here. And we would say elif age equal to 21. So that is how you check if things are equal. You use 2 equal signs, not 1 because that's the assignment operator. That's what we use to assign values to variables. So if your age is 21, we're going to print real big, super special. So let's try this. We run this thing and we enter our age of 21. It says super special. If we put in a different age, such as 30, it just says welcome to our app, so it skips that one. There are also a few other comparison operators. So there is the less than operator, which is just this pointing the other direction. There's also the less than and equal to operator, where you just append an equal symbol, as well as the greater than or equal to comparison operator. So those are some of them you'll see, and there's some other stuff you can do with if statements, which we'll be doing in the next couple videos. So we will put that back to greater than 65, and we will move on to the next video. Hey, what's going on everyone? This is a continuation of our if statement videos. In this one, I wanted to talk about how to do an if statement when we're working with Boolean variables. So when we're using these comparison operators, you can think of them as a black box where we pass in some data and it gives us back either true or false. So we pass in age and we pass in 65, and it's going to check, and it might be true, it might be false. So ultimately it needs to evaluate to one of these two values for the if statement to work. So if you are working with a Boolean variable, it is already true or false. So let's go through an example, but instead of using these operators, we're going to use a Boolean variable. So let's clear this out. I just wanted to show you guys that for reference of what it normally will look like. However, sometimes it'll look a little different. And in that situation, let's just say we have something like happy is true. And what you can do is you can say if happy equal true, print yay. However, this is a bit redundant, and I used to do this before I understood why, but basically we're saying if true is true, do this. But this comparison operator is going to return true or false. So instead of that, we could just put happy, and this will work just the same. So if happy, print yay. And in that case, it prints yay. So that's going to save you some syntax. It's going to make your life a little bit easier, and it's a lot easier to read. I also wanted to mention, just as a side note, that you can put any variables or any kind of expressions inside of if statements. So let's say we extend this with an elif section. Inside of here, we can use something totally unrelated. So for example, you could just do 5 plus 5 is equal to 10. Like, it has absolutely nothing to do with happy. However, in this case, it's always going to be true, so it's kind of stupid, but you can use other variables, and that's fine as well. So if this was false, for example, then the elif will be hit, and it says true here. I guess I should say the math part, just so we're not confusing anybody. So the expression here is totally unrelated to happy. Just wanted to mention that you can put any expression inside of the different elifs. You don't have to always do it on happy, but if you wanted to, you could just say else print sad face. So in this situation, it's completely dependent on the happy variable. It's either going to be yay or it's going to be a sad face, depending on the value of happy. So that's how to use a Boolean variable inside of an if statement. Next up, we're going to talk about logical operators, which are essential for complex conditionals. It's going to be pretty awesome, so stay tuned. I'll see you then. And don't forget to subscribe. Hey, welcome. In this video, we're going to be talking about your very first logical operator. And this is the OR operator. We often use this within an if statement. So we're going to go through an example where you have to be really cool to use this application. Your name has to be either Caleb or Caleb with a K. So let's say my name is Caleb, and we're just going to hard code that for right now. And then we'll say if name equal Caleb or name equal Caleb with a K. So you Calebs out there with a K, you are considered special to me, at least today. And then you need to put that colon, enter, and we'll just say print unite. So we're getting together, we are making a cool group of Calebs. So silly. All right, and it says unite. And in this situation, your name can be Caleb or Caleb with a K. So if I go in here and change it to a K, we run this, we still get the same exact output. But if we put some stupid name in here like Claire, check this out. We run this, nothing happens. No offense to you Claires out there, your name's not Caleb, so you're not really on my level, you know? So the next thing I wanted to mention to you guys is the concept of short circuiting. If Python can know that it doesn't need to check every single option, then it will just stop and print the value. So for example, in the situation where the name is Caleb, well, it automatically will check Caleb first, and it's true, so there's no reason to check if this is the case, and it'll just print. And I can prove this happens, I'll show you how. If I said if true or print, hey, let's run this, see what happens. So this is a little bit interesting because we're actually invoking a function within an if statement, but this is legal. And when this is true, which by the way, true is always true, it prints unite. But if I went in here and made this false, which is always false, ran this now, it says hey. So that function is only invoked when false is evaluated from the first one. So it's a little bit harder to see when you're just comparing values, but the short circuiting does happen. If you have a bunch of comparisons with OR operators, it will go until the first one is true, and then it'll just jump into the body and print this value. Another thing I want to mention is that you can do a lot of stuff in here. You don't have to just print, you can also get input. And let's just label this as true so it runs. We can run this and you can see it prints out twice and then it's getting a user input. So as long as that indentation is there, it will execute within the if statement. Next up, we're going to learn a new operator, and that is the AND operator. Stay tuned. Hey everyone, in this video, we're going to be talking about the AND operator. Now this is sort of a follow-up to the previous video where we talked about the OR operator. And the thing about the OR operator is one or both of the operands, the things we're working on, can be true. So in this situation, if I wanted to say, if you're subscribed or your email is activated, print welcome, here's how you would do it. Type it out like that, hit run, and it says welcome. Now the thing here is that they're both true and it runs. So it's not the case that only one can be true, either can be true or both. When it comes to the AND operator though, they both have to be true, otherwise it will not run. So if we switch it to AND, it will still run because they are currently both true. However, if either one of these are changed to false, then it will not run. So if two conditions need to be met, then the AND operator is for you. Now the way this short circuits is if the first one is true, then it will check the next one. If the first one is false, then it already knows the expression is false and it short circuits. This is the opposite of the OR operator, where if the first one is true, it automatically returns true, but if the first one is false, it'll check the next one. Now you don't have to just use booleans here, you could also use an expression that evaluates to true or false. So for example, let's say we have some part of our website where you have to use points that you occur for using the website, and let's say we have 50 of them. Well, what we can do is we could say, and points is greater than 30. Running this now, it still says welcome, but we could actually subtract points if we wanted by saying points is now subtracted down 30 points. So if you have 31 points, you spend 30 of them and you're left with one over. We have 50, so we should have 20. And what we can do is we can actually print that. Points is now, comma, points. So running this, and we now have 20. So that is your introduction to the AND operator, very important to know. And the next one, we're going to talk about the NOT operator. So this video, we're going to talk about the NOT operator, which actually just takes whatever expression you have and inverts it. So if you're working with a Boolean, let's say subscribed, what you can do is say not subscribed, and it will check if it's false. So let's get rid of the and for a minute just so we can focus. If not subscribed, then it'll say something like redirecting to subscription page. And we'll get rid of this other stuff here. So now we're not looking for a true value, we're actually looking for a false value. So if subscribed is true, and we say if not subscribed, it's not going to run. Running this, you can see, I actually forgot a colon, geez guys. We run this and you can see nothing happens. However, if we are not subscribed, then it'll redirect to the subscription page right there. Now the if statement still has to evaluate to true to execute, it's just that the condition we're using is a little bit different. So it looks at this and says, not subscribed? That expression is true. And if you want proof of that, you can go in here and say print not subscribed. Run this and you get the value true. That's because subscribed is currently false and not will negate it to true, which is why the if statement executes. So if you're new to logic, it can be a little bit confusing, and it might even be more confusing when you do it in compound statements, but you can. So for example, we can say if not subscribed and points is less than like 30, for example, then it'll redirect. And let's say our points are 20. In this situation, it should still redirect. If one of these was different, let's say subscribed was true, it would not execute. There you go. Oh, you know what? Here's a better illustration of the not operator. If not subscribed to my YouTube channel, then what do you gotta do? Slap that sub button. And of course, you're already subscribed, so this is not gonna happen. You don't need to hit that subscribe button again. No worries. Thanks guys, and stay tuned for the next video. Hey, welcome everybody to your 50th Python tutorial. First off, I wanted to say congrats for sticking through it all this way. Hopefully by now you're starting to piece together things and see that we can start making really cool complex apps. We're going to go through the 5th review page, which you can find up on my GitHub at calebcurry/python. And we're gonna copy this and just go through it line by line. Shouldn't be too complicated. So I'll paste that in here and we'll just clear out the terminal, just keep it fresh. And let's just start at the top here. So any complex program is made possible thanks to control flow statements. Control flow is just a fancy word to include if statements and loops. A foundational concept to doing this is logic, which deals with Boolean values, either true or false. And true is a keyword, so you don't use quotes or anything like that. And we're gonna run this and see what the output is, so we'll scroll up to the top. Starts with true right there. Now operators can return true or false. So here are some examples. Comparison operators, 5 is greater than 3. Well, heck yeah, that's true. Age being 21, is it greater than or equal to 21? Yes, it is. You can even do this with strings. So here we have two strings, me and you. Are we equal? And no, it's false. I mean, obviously, I'm way above you. I'm just playing. Wow, savage. All right, what else? We have two grades lists, and these are different. And you can even check to see if they have the same grades. Now, what we do is we change your grades to match mine, and now we run it, and it's true. So that's what these two outputs are right here. Now, in some languages, this is just a call out, is that equals equals will compare by memory address to see if they are the same object. This is done in Python using is. So our grades the same object, and then it says my grades is your grades, and it's false. Even though they have the same values, 100, 100, 100, it doesn't matter. They're not the same object, which is why we get false here. If we were to assign one list to the other, so we say my grades is equal to your grades, they are now pointing to the same object in memory, and in that situation, our grades the same object, we get true. So it's basically an alias. My grades and your grades are two names we can use to refer to the same exact thing. What else here? You can do order testing for strings. Does A come before B? You can do ABC is less than BCD. And it's true. So this is considered less than B. So it could be read as ABC coming before BCD in the alphabet. First letter decides that yes, ABC comes first. You can also use the not operator to negate anything. So A not being equal to B, that is true. And notice here we used an exclamation mark equals. This is actually different than what I showed you earlier. Alternatively, you could say not. Next up, we got if statements. So this is going to ask for our name and our age. If it's Caleb, it's going to say, hey, Caleb. Otherwise, it's not going to do anything. And that indent there is really important. We're going to use 4 spaces for that. And let's go ahead and put our name in here, Caleb. And notice this is dynamic. You get to choose what the input is, and the application branches. What's my age? I don't know. Let's go with 150. All right, we get a bunch of outputs, so let's scroll up here. We just typed in 150. It says, hey, Caleb, because my name is Caleb, so that's where that comes from. If age is greater than 100, wow. Now the thing here is this next statement here is not indented, so it's going to execute every time. It says you are so old. However, even if I put in age 40, it's still going to execute that. So you got to make sure you remember to indent. It should look like this with both of them indented to the same level. That's why we get this output again, because it runs and evaluates to true. Now what else? If age is greater than 100, which it is, it says you're old, which is that output right there. This is an elif statement with an else at the bottom. And then lastly, we can use Boolean variables inside of our logic. Caleb is cool is false. If Caleb is cool is true, then you're willing to be friends with me. Otherwise, you say ew. So yeah, story of my childhood. Now this equals equals operator will check equality. However, since Caleb is cool is a Boolean already, we can bypass that and just say if Caleb is cool, which also makes more sense if we're reading it like English. Last up, we got logical operators to make complex conditionals. So we got and, or, and not. So here's an example. We have thunder is false, lightning is true. If lightning or thunder, don't go swimming. Now I know there's some relationship between lightning and thunder, like one's visible and one's sound. However, it doesn't really matter. Sometimes you get one without the other. So if you see or hear either one, you don't go swimming. With and, here's another example. If a car is nice and it's on sale, you buy it. But if it's only nice but it's not on sale, you don't buy it. There's always nice cars out there. And just because a car is on sale doesn't mean you should buy it. You want to make sure you get a nice car and a car that's on sale. So because one's true, one's false, it does not execute. We could also use the not operator. So if temp outside is 50 and the pool heated is false. So if it's less than 60, which it is, and it's not heated, then you don't go swimming, which is why it says don't go swimming. If it was heated, then it'd be fine, right? Who cares what the temperature is if you have a heated pool? Then I got some extra notes here you can read if you're interested. And yeah, that pretty much sums up the last section on control flow. Next, we're going to continue our control flow discussion by talking about loops. So stay tuned for the next one, and I'll see you there. Hey everyone, in this video, I want to talk about a loop called the for loop. And this loop is ideal if you want to take a list of stuff and go through each element in this list. So let's go through an example. I'm going to create a list called friends, and inside of this list, I'm just going to put some string data in here of various people. All right, so I have 4 friends on here, and if I wanted to display each one of these into the console, then we would use a for loop. But what we know so far is if we do print and put friends in here, it's going to print everybody. And when we do this, it prints it as a list in one entity. If we wanted to do each name individually, that's where the for loop comes in. So what we do is we say, let's get rid of this original print here. We say for, then what we do is we create a variable to store one of the people. So we would say friend, and then you'd say in friends, and then a colon. So we created this variable. We decided to name it friend. You could have named it whatever. And then all you have to do is say print friend. Like so. So we're going to print that variable. Running this, and we get Abby, Jonathan, Becky, and Ryan. So each time through this list is known as an iteration. The first iteration, the friend variable is assigned Abby. The next iteration, friend is assigned Jonathan. The next iteration, Becky, and then the last iteration, Ryan. That's your introduction to the for loop. The next couple videos, we're going to be talking about different variations and the different things you can do with this loop. So stay tuned. Hey everyone, welcome back. So in the previous video, we created this for loop to print each one of our friends, and every single one is on a new line. And what I'm going to be teaching you is how we can put all of those on the same line. So there's actually a different variation of the print function that we can use to do this. So what we can do is we can pass in another argument. It's called end, and then we assign it a value. So we could assign it a space as an example. And what this is going to do is instead of doing the default new line after each print, it's going to just put a space instead. So running this now, and we get Abby, Jonathan, Becky, Ryan, and then the original prompt from the terminal. The other thing I wanted to show you guys is that sometimes you'll want to do that for a loop, so not everything gets its own line, but then at the end you might want to put a new line, but just for the very last one. So for example, you might want to put a new line right after Ryan so that this prompt goes down on the next line. The absolute easiest way to do this is after the loop, not within the loop, just say print. And you can just leave it blank, and it's going to default back to the new line for each print. So this end only applies for this statement right here. So running this, we get that new line, and this prompt goes down to the next line. So there you go, just a little life hack to make your life a bit easier. Next up, we're going to talk about a cool variation of the for loop that you can use for other things than just going through items in a list. Hey everybody, in this video I'm going to be giving you an example of using the range function inside of a for loop. So this is the for loop we had in the previous video where we're basically going through this list of people and printing each one. We're separating each of the people by a space. At the end, we're doing a new line to bring the prompt down to the next line. However, sometimes you're going to want to do a loop like this, but you don't want to be working with a list and printing each one. Well, in this situation, we can change this loop. So let's start fresh, and it's going to look very similar. You're going to say for, and then you're going to create a variable to represent the data in each loop. So we'll say I, and then you say in. And based off of the previous video, you would put the list name here, but we don't have a list to work with. So instead, we're going to say range, and in here, we are going to pass in a number to stop at. So let's say 10, and then a colon, just like normal. And then what we can do is we can print I to see what the data is. So running this, and it looks like we get all the way from 0 to 9. So that's what the range function does. When you create a range, it's going to stop at 10 exclusive. So it goes from 0 to 9. Another way you can think of this number is how many iterations of the loop. So this is the first iteration, this is the second, all the way up to the 10th iteration. So if you know you need to make a loop that executes 10 times, here's how you would do it. You would say for I in range 10. Now if you don't want to have the value 0 through 9, you actually want to have 1 through 10 or some other variation, you can just modify the print here. So I could say I plus 1. Running this now, and we actually get 1 through 10. So you could use this for something like this. We could say iteration, and then we could put that number, and it's going to say iteration 1 all the way through iteration 10. Next up, I'm going to give you some variations of range, so stay tuned, it should be pretty fun. Hey everyone, welcome back. In this video, we're going to take a better look at range and see what we can do. But right now, just make sure you understand what this loop is doing. It's going to give us a number 0 through 9 and print a space after each number, and then it's going to end off with a new line just to get everything by itself on a line like so. So after that 9, it prints an empty statement, which brings this down to the next line. So what I want to do now is I actually want to pass in an extra value into range. And you can see some of the possibilities here. So right now we said range stop. This is going to give us a value from 0 to that number, but we could also say start and then stop. So in that situation, the first argument we pass in is going to tell it where to start, and then the second argument is going to tell it where to stop. So if we wanted to go from 10 to 20, let's say, well, we run this and let's see what we get. We get 10 all the way up to 19. So similar to the way slicing works, the first one here, the 10, is inclusive. It is included in the output. The second one here is exclusive. It is not included in the output. It stops at 19. So this is still printing 10 numbers. It's just starting at 0, but now everything is prefixed with a 1. So we got 0, 1, all the way up to 9. So if you want to practice this, why don't you try creating a range from 231 included all the way up to 500 included. If you want to know the answer, it's this right here. You would say 231 and you would stop at 501 because the 1 is not included. So it stops at 500 and includes it, and then 501 is excluded. Running this now, it's probably going to look a little bit funny, but it does the trick. So we start at 231, that's included, and it ends at 500. Next up, there is a third argument you can use with range, and that's what we're going to be talking about in the next video. Hey everyone, in this one we are going to continue our discussion on range, And this is an output we had from the previous video, and it seems to be working fine. It's counting up one number at a time. However, there's actually a third argument you can use with range, and that is going to change the interval of how it counts. So if you go in here and you put in another argument, and you can see there's actually a third option here, which is the step. So if we go in here and put a 1 and run this, we get the exact same output because it's going to count by 1, which is actually the default. However, if instead we go in here and put a 2, well, check this out. Now it's going to count by 2. So this is an interesting way you could get all even or all odd numbers. You could just start with an even number and count every 2. In this situation, we're getting all the odd numbers because we started with 231, we get 235, and it just skips all the even numbers all the way up to 499. 500 does not get included because it skips that. 2 after 499 would be 501, and that is exclusive because that's the stopping point for range. You can also manipulate this to do other things, such as count backwards. So let's say we started at 200 and we went to 0, and then we put a -1 here. Well, if we start at 200, remember this is inclusive, so 200 will be in the output. 0, the second argument here, the stopping point, is exclusive. So the 0 is not going to be included, so it's going to stop at 1. So running this, we run it all the way from 200 and it stops at 1. If you wanted to include the 0, all you would have to do is make that a -1. Running that, and you get all the way to 0. So there you go, guys. That is your introduction to range. Stay tuned for the next video because we're going to use range to create a pretty cool program. So yeah, be sure to subscribe too, you know? Gotta hit that sub button. Hey everyone, in this video I'm going to be teaching you how to get the sum of numbers within a range. So maybe you want to add up 1 through 9 and see what that value is. I'm going to be teaching you that here. So first we'll start with a loop for I in range, and we'll put a range that'll go up to 10 but not include 10. And we're just going to print I. So running this, and we get 0 through 9. So there's actually a super easy way to do this. All you have to do is say range 10, and you're going to take this and pass it into a function called sum. And this takes, you can see here, an iterable, and range is an example of an iterable, something you can iterate through with a for loop. So what we're going to do is we're going to print this like so, and run this, and you can see we get the value 45. So that's the easy way. Now if you need an algorithmic way, like step-by-step how to do this, maybe for class, or maybe you just need a better understanding, I'm going to show you guys how to do that now. So what you would do is you would create a variable, we'll just call it sum, and start it with 0. And each iteration of this loop, we're going to add to sum. So we'll say plus equals I. At the end, what we're going to do is we're going to print the sum. So running this now, we can still get the value 45. So that is how you would create your own sum algorithm. Thank you guys for watching, and stay tuned for the next one. Yo nerd, what's up? This video, we're gonna be teaching you how to take a range and turn it into a list. So in other words, you have this range and you wanna save it for later so you can reference each one of the elements in that range. So when we run this right here, we get this value 0 through 9. And that's cool and all, it seems to work, but it actually is built using this variable over and over and over again. What I want to do is I want to take this and I want to put it within a list. So your first instinct might be to say, let's just call it my list, and then we say range 10. This actually does not work the way you would expect. See, if you print my list, run this, we get range 0 to 10. That's not what we were looking for. And that's because when you invoke range, it doesn't give you a list back. It gives you a range object. So we're basically creating a new range object, which happens to be able to be iterated through in a loop with a for loop. But it's not a list, it's different than a list. If it was a list, when we printed it, it would look a little bit different. So for example, let's create my list and assign it some values. So we put all those values in here, and then we print my list. Running it now, we get what we were expecting, a list of numbers. So this here and this here are not the same thing. So if you want to take a range and assign it directly to a list without typing out all the elements manually, it's really simple. All you have to do is say list and put it inside of parentheses. So hovering over it, you can see it's a list class. So if you want to make a new list object, you just pass in a range to that list and that works. So running this now, and we get that list we expected. So hopefully that makes good sense. It can be a little bit confusing because you would think range would return a list. However, it doesn't work exactly that way. So stay tuned for the next video. We're going to continue our discussion on the for loop. Hey everyone, welcome back. So far we've talked about two real big variations of the for loop. One is used to print numbers in a range, and then another is to print elements inside of a loop, which looks like this: for food and foods. And then you do something with food. So you say print food. And both of these will iterate the same way, but they're different because this one grabs numbers and this one grabs elements. But what if you wanted to do both? That's what I'm going to be showing you in this video. So let's go down here and create a third variation that's going to combine these. So basically we can count along with using the elements. So first let's run these and see the outputs. The first one is 0 through 9, and then the next prints some foods. But now what I want to do is say what element each one of these foods is. So here's how we would do that. We would say for I in range, and then for the range, what we're actually going to do is we're actually going to use the length of the list. And the way you do that is you say len and pass in foods. So that is the syntax to do the loop. And inside of here, I is going to refer to the index. And if you want to grab the element, you can say foods index I. And we'll also say end is just a space, just to save some space here, and print a new line at the end. So there we go. So running this, here's what we get. 0 asparagus, 1 tacos, 2 strawberries, 3 yogurt, 4 bagels. So it is printing the index of each of the elements. So if you totally understand this, great, that's awesome. You probably good and you can move on to the next video, but here's just a little bit of a better explanation if you need a little bit more. So range, when we pass in a number in this, such as 10, it knows to stop at that number. But instead of passing in a number, we're passing in the length of foods. So if we say print len of foods, we could see what that number is. So running this, you can see 5. So when we say len of foods, we are essentially putting in a 5 here. But instead of hard coding the value 5, we're making it dynamic by actually asking to see how long the list is, rather than using a solid number that we might have to go back and change. When we do this, the number gets assigned to I, so that's why we use I inside of the print. We don't have a variable such as food to print, so we actually have to use that original list and index using that I variable. So the first iteration I is going to be 0, which gets asparagus. The next iteration it's going to get tacos, strawberries, and then yogurt, and then bagels. So those are the 3 main variations of the for that you're probably going to run into at some point in your life. The first one to iterate through numbers, the second one to iterate through elements inside of a collection, and then the last one to iterate through elements, but it's also going to have that number paired with it. So there you go guys, stay tuned for the next video. We're going to review everything we've talked about with these loops and then move on to something new. I'm excited and hope you are as well. Hey everyone, welcome. This video we're going to do some review of the loops we've been talking about. So up in my GitHub you can find the source code for this in beginner Python and then loop basics. So what you can do is you can go through and read this, or what I would recommend is actually scroll through this and copy it over to your text editor. So we'll copy and then we'll go to Visual Studio Code. Alright, so I'm just clearing out everything we had from the previous videos. And we'll just run this and start from the beginning. So we get a bunch of different outputs, and it starts right here at Python. So the very first thing is we make a list of languages: Python, C++, and Java. These are all programming languages. To iterate through these, we create a for loop, and we create a variable to store each element, and each iteration, that variable is going to be assigned a new value. The first iteration, it's going to be Python, the next C++, and then the last Java. So we print that, which is why we get the output Python, C++, Java. So that's the first output. Here's some extra information if you want. Next up, you can change the variable. So I was just showing that the variable name is irrelevant. Just make sure you use the right variable name in the loop body if that is what you're trying to do with the loop. So that's why we get the same exact output again. Now what I wanted to show is that you can actually change the ending, so you can say end equals and assign it a new value. So 1 and line show up on the same exact line because we're just printing a space after the first one. Line, however, does not use end, so it goes back to the default of putting a new line, which goes down to here. So next up, we can print all of the elements using just a space and then end with a new line just by printing an empty print statement. So that will go down to the next one right here. And lastly, just showing that there are some variations. You can use a tab, or you can use no space at all, or whatever you want. Now here's a little bit of an explanation that we haven't talked about, and that is, why do you have to put end equals and assign it some value? Why don't you just pass it in as another argument like you might do here? Well, if you remember, print can take numerous arguments. So when you pass in a comma and then just an empty string, well, it actually just sees it as another thing to print, which is why it just prints like normal, just with an extra space at the end. So we have to use end equals, which is an example of a keyword argument. Next up, we have the range function, and it's actually a way to create a new object. So it says class range. So when you invoke this, it's going to return a new range object. But we haven't really talked about objects and classes a whole lot, so don't worry about that all right now. Later on in our more advanced Python, we're going to talk about how to create instances of classes, also known as objects. But for now, you can just think of it as a function. It works pretty much the same way. And we say for I in range 10, and then in this situation, we're actually not printing I, we're actually printing loading with a space. So we get loading 10 times. The actual numbers of I are 0 through 9 because the 10 is exclusive. So when we print out like so, 0 through 9. Next up on here, we pass in a starting position. So we start at 1 and go all the way up to 11 exclusive. So we get 1 through 10. So that's how I get this output here. Alternatively, if you're just worried about output, you could take the original situation and you could just print I plus 1, and that's going to change the output. So it'd start at 1, but the actual index variable, the I, is unaffected. So either one works, whatever you prefer. So that's one option. Alternatively, you can change the range such that I is the appropriate value. Here's how to start at any value and end at any value. This one prints 5 and 6 because the 7 is exclusive. Next up, we have the range, so you can count negative, you can count downwards. So we go 9 all the way to 0. And another one is we count down by tens, so we go 100 all the way down to 0. -1 is the second argument here because I want to go all the way to 0 and include 0. Next up, we showed how to create a sum. So here's actually a shorter version than what we showed. We just say the sum of the range of 1 to 11. Next up, how to get a list from a range, which is just to pass it to the list and assign it to a new variable, and that will print the numbers within a list. And then lastly, you can use with indexes, if you say for I in range and then pass in the length of a list, you can print I and then languages of I to grab the particular element at that index. So that is pretty much all when it comes to for loops. Lots of information. Make sure you understand each and every piece of that before you move on. If there's anything you're a little shaky on, you can rewatch the video and get a little bit more practice. Next up, we're going to talk about some keywords you're probably going to run into fairly soon when you start doing control flow. So stay tuned. I will see you there, and don't you dare forget to subscribe. Hey everyone, welcome. You know what? I was really tired of just creating loops and printing stuff. I really wanted to take a break from that and learn about a really important keyword inside of Python, as well as pretty much every programming language. So the keyword is break, and break is used to break out of a loop. So if you want to stop a loop early. So let's go through an example, and you could build off of the example what we had in the previous video if you've been following along, but I'm gonna start fresh. And what I'm gonna do is I'm gonna say languages, and I'm gonna assign some languages in here. We're gonna say C++, Java, Python, and JavaScript. So we got different programming languages in here. And what I want to say is language in languages. So we're going to iterate through this. And if I find a particular language in this list, I want to break from the loop. When would you want to do this? Well, let's say you have some list and you don't know all the elements in it and you want to search for something. Here's how you would program that. So we can check to see the value. If language has the value Python, then what we're going to do is we're going to break. Notice we have two indentations here. The first indentation is for stuff inside of the loop, and then the next indentation is for stuff within this if statement. Each iteration of the loop, this if statement is going to run. So right now, if we ran this, it's not going to do anything because we're not doing any outputs. So what we could do is we could print the language. We'll say print, pass in language here, hit run, and let's see what happens. We get C++, Java, and then Python. But JavaScript is never printed. Why is that? Well, as soon as language is equal to Python, which is this case right here, we break from the loop and it stops going through, so JavaScript is never hit. And if you were considering this to be some kind of search, you could say print and then say something like, we found Python. Running this and it says we found Python. We could generalize this a little bit more. So for example, let's get an input. And we're gonna use this input to ask them what we want to search for. And we'll print before this, what are you searching for? So lang is going to contain the value Python if we type that in. So now instead of hard coding Python in here, we could actually put lang, which is their input. And then inside of this print, we could say we found lang. All right, so let's try this now. Running this, what are you searching for? We will type in Python, hit enter, and it says we found Python. Run it again. This time, let's search for something else. And notice it does not say we found pizza because it wasn't found in the list. When this break is hit, it's going to immediately cut out of the loop. So what that means is if I had something down here and we ran this, and let's say we are searching for Python, at the end of each iteration, it's going to print that. So C++, then it hits this print. Then Java, then it hits this print. Then once Python is found, it prints we found it, it breaks, and it never reaches line 11 for that iteration or ever again because the loop is now complete. So that's an introduction to the break statement. We're going to be using that a lot in our programming, so make sure you understand how it works, get a little bit of practice with it. There is another important keyword you should know, and that is continue. Stay tuned, or should I say continue, with the next video because we're going to be talking about that there. Hey everyone, welcome back. This video, we're going to talk about the continue keyword, and I would say it's pretty important to understand how the break keyword works, which we talked about in the previous video, but just to get a quick review, pretty much anytime this break is going to be hit, the loop is done, it's not going to execute anymore. The continue works in a similar nature in that it interrupts the loop, but instead of quitting the entire loop, it just stops that iteration and jumps to the next one. So in this situation, we might want to search for, let's say we're searching this languages list for something we type in such as Python. Instead of stopping after we find Python, we still want to go through that list and continue to check for more instances of Python. Well, that is where you could use a continue instead of a break. So let's just see an example of this. First, we'll go with break. Running this, we can type in Python, and it stops at Python and says we found Python. But if we had Python in here more than once, like so, this search is only a yes or no search, whether or not Python is in the list or not. It doesn't say each time we found Python because it hits that first Python and it stops. So what if instead we used continue? And then let's say if we don't find it, we say print, and inside of the print, we're actually going to print the language that we're currently on, plus a statement saying, not what we are looking for. So let's run this and see what happens. What are you searching for? We'll search for Python, hit enter. We get a bunch of different outputs. So first up, this is what we're searching for, Python. Find C++, not what we're looking for. Java, not what we're looking for. Python, we found Python. JavaScript, not what we're looking for. So you notice it continues on to JavaScript even though we already found Python once. And then it does that every single time it hits Python, it says we found Python. So this kind of algorithm could be used to count the instances or to continue the search for another instance after you already found the first one. If you wanted to clean up the output a little bit, we could get rid of this extra print here, and we type in Python. It just says just the output, C++, not what we're looking for. Java, not what we're looking for. We found Python, JavaScript. Not what we're looking for. We found Python, we found Python. So if you need to treat a certain case special, you can use the if statement to check for it. And then within that if statement, use the keyword continue to go to the next iteration. And then line 10 will not be hit in the case that the if statement is true. So hopefully that's not too complex. Just go through some examples and just type it out, try it yourself, see what output you get. Now there is a variation that you might see that does not use the continue keyword, but it does the same thing, and that's what I'm going to be talking about in the next video. So stay tuned for that one. Hey everyone, in this video we're going to talk a little bit more about continue. And pretty much in the previous video, we created this algorithm that's going to search a list for a particular word. In this case, we search for Python, and every single time it finds it, it says, we found Python. And that's generated from this statement right here. We found plus lang, which comes from the user input. If that word is found, then we continue to the next iteration. So in other words, we're either going to print this, or we're going to print this. So instead of using the continue keyword, you may see the same structure using an if and an else. So I'm going to show you that variation. I'm going to get rid of the continue and I'm going to say else and indent this. So running this, we can still type in Python and we get the same exact result. If it's not Python, we get this result. If it is Python, it says we found Python. So personally, I think the continue keyword is a little bit more clear. However, the output in this situation is the same. That's because the continue pretty much says, hey, this case is special and we're going to go on to the next iteration. We're not going to do the rest. Whereas the else does pretty much the same thing. You know, if the if statement wasn't true, then we're going to execute this on all other cases. So it's just kind of like two ways of looking at the same thing. Personally, I like to use continue because it reduces the need for extra indentation, extra structure, which you would like to avoid that whenever possible. And another thing, this algorithm is checking for that word. However, if you don't need to do anything for if it's not found, you can just get rid of this altogether and then just print when it's found. So in this situation, if we say we are looking for Python, it's only going to say we found Python when Python is hit. We don't have to worry about all the other things inside of the list. So hopefully you're starting to see that, there's different variations. You can choose what you want to do, what looks best for you, and you can control what the program does by your code. So yeah, it's pretty cool. Next up, we're going to talk about another keyword in Python that is actually fairly new to me. So see you then. Hey everyone, in this video, I'm going to be teaching you about a word in Python that literally does nothing. And that keyword is pass. Anytime we use the keyword pass, we are saying do nothing. It's really weird at first, but I'll explain why it's useful. So as an example, we can go up here and we can say pass. We can just put the keyword pass anywhere in here. We'll put it inside of the if statement here, and I'll even put one after the if statement as well. And heck, why not put one at the end? However, when we run this program, it works exactly the same. We can search for something and it'll tell us when it found it. So why in the world would I want to use this keyword pass? Well, first you should know about it because you're probably going to see it, and I don't want you guys to be confused on what that word means. But the second thing is you can use it as a placeholder until you have a better solution for the problem. So it's the equivalent of saying, hey, this does not do anything right now, but we're going to implement this in the future. It's a little bit more clear to developers when you explicitly say, hey, I'm going to pass on filling out this part right here, but I'm going to get back to that, rather than just leaving it blank. And on top of that, sometimes if you need to leave it blank, you have to use the keyword pass. So let me show you an example of this. First, let me just get rid of all of these passes in here, and we have this if statement. Let's just go ahead and say, I'm not sure what to put there. Let's just put pass. And when we run this, our program works and we can run it. It's happy. It doesn't really do anything because we didn't implement the if statement. However, it runs. Now watch this. If I get rid of pass and run it now, look, we're getting an issue because it's expecting an indent. It's expecting a line here. And even if we put that indent there, we run this, it's still not going to work. So anytime it's expecting an indent or expecting some line of code, but you don't have anything to put there, you just use the keyword pass. Another common example of this is with classes and functions, which we haven't even talked about this yet, but you can say something like def do something, and if you're not ready to make this, you can just say pass. Or you might have class test, and you're not really sure what you want to do to implement that, so you can just say pass. Inside of this if statement, we'll say pass. And all of this code should be fine. You should be able to use it. And it's not going to do anything, but it allows you to run the code. So that's all I got for you guys on pass. Pretty simple. Yeah, I don't really know what else to say, so I'm just going to move on to the next one. But before we go, I'm going to put this back to how it was and say language was found. All right, there we go. We have a search algorithm, and there's no passes involved, so we're all good. All right, let's get started with the next video. Hey everyone, in this video we're going to talk about a really important keyword, and that is the keyword else. And you might be confused because didn't we talk about else with the if statements? Yes, in fact we did. However, this is a different context. We're going to be talking about the else with loops. And this concept of using an else with a loop is actually fairly new to me. However, the same concept I've implemented, I just haven't used the else keyword with it. So I'm going to be teaching you something pretty cool, and it should make your life a whole lot easier. So what it's going to do is it's going to execute a section of code once the for loop or while loop is done. So for example, we'll go in here, go back to the correct indentation with this for loop and say else and a colon, and then we'll print loop is done. So running this, we can put whatever we want in here, Python, running this, and it says loop is done. It only says it once and it happens after the loop. So that's the statement, that's how it works. However, it doesn't really add any value right now, because if you get rid of this else, look, it's going to do the same exact thing. Now it's just going to jump down to line 10 and execute that code. So if we search for Python again, it still says loop is done. So how is this any different? Well, the main thing is if you break out of the loop, the else is not going to be hit. So let's say we're looking for a particular language and we want to break as soon as we hit that language, then the else is going to be skipped. So let's try that out. So if it's found, we break, and instead of saying loop is done, we can say not found. And this needs to be in an else, like so. So running this, what are we searching for? We're searching for Python. Python was found. Let's run it again, and what are you searching for? Let's go with py, not found. Before I knew about the else with the loop, I would do something very similar with what would be known as a flag variable, which is just pretty much a Boolean variable that tells you to do something later on in your code. And that would look something like this. Found, and you'd set it to false. And then if it's found, we would say found is now true. We would not use the break, and we would not use the else. And down here we would say if not found, then we would print not found. So running this, let's try it. What are you searching for? Chicken, not found. So that is the equivalent of doing this without the else for the loop. Either one gets the job done, so whichever one you prefer. Some people do not like the concept of flag variables and would prefer to use the else. Although in my career, I haven't seen an else with a loop very much, so maybe it's not super popular. I don't know, I think it's best just to know both options. So thank you guys for that, and I'll see you in the next one. Hey everyone, in this video, I want to talk about a brand new loop for you guys, and that is the while loop. And it's going to look something like this. You say while, and then you put some condition here. So for example, we can say I less than 10. So this is how we can create a loop that goes from 0 to 9. So we'll start at 0, and we'll just keep adding 1 to it until it hits 10 and it doesn't execute anymore. So this would be the equivalent to saying range 10 for a for loop, because that 10 is not going to be included. All right, so then what you do is you put a colon, and then you put some statements inside of the indentation. Now this I here doesn't come from nowhere. We actually have to create it. So up above, we will say I and set its initial value to 0. Then inside of the while loop, we can print I, and then lastly, we have to increase the value of I. So we would say I plus equals 1. We got 0 all the way to 9. So there's 3 pieces for this loop to work. We have the initialization, we have the condition, and then we have the update. And I remember these 3 pieces using I, C, U. So then I always remember if I have all the pieces or not. If you leave one of these out, the loop is not going to work. So for example, if I got rid of the update, well, then we're never going to progress to getting closer to 10. So the loop's just going to go on forever, printing 0. And when I run this, we got an infinite loop. So to get out of this, what you're going to do is hold Control and hit C. That'll send a keyboard interrupt. It'll stop the loop. You can alternatively right-click Kill Terminal if you're in Visual Studio Code, or if you just got the terminal open, you can just close out of it. Whatever you got to do to get that to stop. And make sure you don't forget that update. So we say I plus equals 1. Same thing with the initialization. If we don't put this in here, it's going to say I doesn't exist because it's not defined. We didn't say where I came from. So you have to have everything. You can modify the way the loop works by messing with different numbers. So for example, we can count by 2. Doing this, you can see it goes 0, 2, 4, 6, 8. If we wanted the 10 inclusive, all you would have to do is say less than or equal to 10. Running this, and you get 0 through 10. Now it is a common convention to use less than, so you may also see this as less than 11, which will still include that 10, but it doesn't use the less than or equal to. So we still get 0 through 10. So that's your introduction to the while loop. I encourage you to try some variations, maybe try counting by 5, or count backwards from 10. So figure out how to modify the loop to do that. Be careful not to create infinite loops and make sure you have all of the different pieces. The initialization, the condition, and the update. Consider it like this. The initialization is the starting point, the condition is the ending point, and the update is how to get from one to the other. So thank you guys. In the next video, we're going to talk a little bit more about while loops, so stay tuned. I will see you then. Hey everyone, in this video, I'm going to be teaching you how to go between a while loop and a for loop, because they actually share the same components, it's just the way it's set up is a little bit different. So in the previous video, I explained that with a while loop, you're going to want to make sure you have an initialization, a condition, and an update. And that's for the very simple loop. But to generalize that, you pretty much have to have a starting position, an ending spot, and progress. You have to make progress as you iterate through the loop, or you'll have an infinite loop. Well, the same thing exists with the for loop, it's just set up a little bit different. With the default for loop with the range, the starting position or the initialization is going to be 0. The update is going to be increasing by 1, and the stopping position is going to be 10 exclusive. So it's the same exact setup. These actually give you the same exact output. Here is for the for loop, and then if we scroll up a little bit, here is for the while loop. But these three pieces can actually be customized with the range, as we've seen when we were talking about range, but just so you can coordinate the two, it would look like this. We have the initialization, the equivalent to the condition for range, which would be the stopping position, and then the update, which is the step. And this coordinates to this call right here where we have a start, a stop, and a step. So this should work exactly the same way, and we get the same output twice still. One from the while loop and one from the for loop. The reason I'm going through this, although it seems a little bit simple, is that I want you to see where each piece of the loop is shown for the while loop and then for the for loop. The only thing is that the positions are different. However, the step still happens at the end of the loop, just like in the while loop. With a while loop, you can customize it. So I could take this and I could put it here, or I could do it within some kind of condition. So it's a little bit more versatile, and maybe it's a little bit more visual seeing where things happen. However, the for loop is less verbose. There's less text you have to type to get the job done, especially if you don't need the step and the starting position. You can just say when to stop. That's very clean, very simple. The while loop, it's more verbose, and you have to make sure you put the update in the right position for everything to work right, and maybe it's just a little bit more complicated. So either loop is fine, whatever you prefer. We're going to be using both throughout this series. So stay tuned in the next video because we're going to get a little bit more with the while loop and talk about a popular variation on how to use the while loop. Hey everyone, welcome. It is my first video for the morning, so hopefully everything is set up nice. The video sounds great, the audio looks amazing. Let's just jump in here, and I want to talk about the else clause, but combined with a while loop. So we're going to actually do something a little bit different. We're going to create a while loop to look through some numbers and see if when you square these numbers, if any of them are larger than some particular number. So we'll make up a number. So let's say 500. If any of the numbers in the list is larger than 500, then we're good. We're searching for that. So here's how we would do that. First, we can create a list of numbers, and we'll just put some random numbers in here, like so. And now I just want to set up a basic while loop structure. So I'm going to say I is 0, and then while I is less than the length of numbers. What are we going to do? Well, we're going to put some code, and then we're going to increment I. So first thing, let's just print the number so we can see it. So we'll say numbers index I. So numbers of I, that's going to grab the element and print it to the terminal. So running this, we get 5, 3, 6, 40, whatever, anything we have in this list here. Now the next thing I want to do is I want to take the number, multiply by itself or square it, and see if it's larger than 500. So here's how we're going to do that. We're going to get rid of the print. We don't need that right now. We know the loop is working. And then we're going to say asterisk asterisk 2. That'll raise it to the second power. And we're going to check to see if this is larger than 500. So we can put this in an if. If numbers of I raised to the second power is larger than 500, and what we could actually do is we could actually use a variable for this. So we'll just say square here, and we'll assign it 500. So then we can just use that variable, and we don't have to change our actual algorithm to change the number we're looking for. So we can go in here and say larger than square. So if that's the case, what we're going to do is we're just going to print. We'll print some message, and then we will break. So what do we want to print actually though? We want to print numbers index I, and then maybe we can do some other stuff in here. So we'll say squared is larger than square. All right, so let's just test this out, run it, see if anything happens. 40 squared is larger than 500. So at least one of these is greater than 500. And I say at least because we are breaking from the loop. We're not continuing the loop. So we could have a number here, like let's say a really large number here. Run this, and it still stops at 40. So it's fine. We don't need to check every one. We just want to see the very first one in here that is larger than 500. Now when we put an else, you might intuitively put it on this if statement. And if we do that, here's what's going to happen. And in this else, we can do something like print some message. We'll just say numbers of I, and then squared is not larger than square. So running this now, that's going to pop up for every single element that is not larger than 500 when it's squared. So when it hits 40, it still does this, but now we get these outputs for all of the previous numbers. So the else attached to this if statement inside of a while loop, that's going to execute every single time. And because we actually have this break here, we don't even need this else here because the only way for this to execute is if the break does not get hit. So that is another way we could structure this. Running it, and we get the same exact output. Now if we put an else on the outside lined up with the while, this only executes if the while loop finishes, which it doesn't because we're breaking out of it right now. But in here we could say none squared are larger than square. Now in this situation, let's just say we get rid of 40, we replace it with 4, and we get rid of 20 and replace it with 2. Running this now, it goes through every single one, and then it says none squared are larger than 500. It's kind of a weird sentence, but you guys get what I'm trying to say here. So that's how the else with a while loop works. It only executes if the loop finishes and it does not hit a break. If it does hit the break, so let's go in here and put a 70. Running this now, it does not say none squared or larger than 500. So that's how an else works with a while, just a little bit more practice using that. Again, you can use a flag variable, and we're actually going to show you how to do that again in the next video. Be sure to hit that sub button, do it for me, please. Hey everyone, in this video we're going to be talking about flags. And a flag is typically a Boolean or an integer to indicate whether or not something happened or some condition was met within an algorithm. And then later you can check the value of that variable to act upon it. So in this situation, with this algorithm we have here, we are taking a list of numbers and we are squaring them and seeing if any of them are larger than this value 500, which is arbitrary. You could change that or get it from user input, whatever you needed to do. And right now we're using this else clause attached to the while, which we talked about in the previous video. This will execute if none of the numbers are found to be large enough. And although this works, you should know both strategies. I would say that the else clause attached to a loop is fairly uncommon compared to flag variables, especially for other languages which may not support else clauses with loops. So here's how you're going to do this. You're going to create a variable and give it some name, it doesn't really matter, success, and we will default it to false. So if you think about going through this sequentially, before you start, none of them are larger than 500 because we haven't even checked a single one. However, if as we're checking them, one of them is found to be large enough, what we would do is we would set it to true. Success is now valued to true. So we change that flag, throwing up that flag. Later we can check that flag and say, hey, one of them was large enough. So we can actually replace this else here, get rid of that, and we're going to do another case down here, so another if statement. And let me get a little bit more room for you guys. So we will say if success, and we can print one of them was large enough. Now, if you want it to be exactly what we had, we could invert it and just say if not success, and say none were large enough. So that is how you would do the exact same thing that we were just doing. So let's run it, make sure it works. So 70 squared is larger than 500. So one of them is found. So that is why this is not executing. And let's just decrease this to some really small number, run this, and none were large enough. So that is how you use a flag variable. Hopefully it is helpful. Essentially, again, it's basically to assume something has not happened unless it does, and then we can change the assumption. You can also think of it as you're approaching this saying none of them are large enough unless you prove otherwise. So thank you guys, stay tuned for the next video. Hey everyone, this video we're going to be talking about a do-while loop. And for other programming languages, there's actually a new keyword for this. However, in Python, we're just going to use a normal loop and modify it to get the same behavior. So what does a do-while loop do? It executes one time whether or not the condition is true or false. So if you're printing numbers, it'll always print that first number. And this might seem a little bit weird, like why would you want to do this? It's kind of like learning how to speed read, but you're 5 and you don't barely even know how to read yet. This is kind of like learning the do-while loop now, because we're just touching on loops and we haven't done a whole lot of application. But later on, just trust me here for a bit, that you're going to want to do something one time, and then if a certain condition is met, do it again. You know, for example, you're trying to log into a website, you put in your username and password one time, and if it's not correct, you do it again. So that's a simple scenario, but let's just go through a normal standard while loop and show you how this works. So we say I is 0, and then we'll say while I is less than 10, we're going to print I, and then we'll increment I by 1. Running this, and we get 0 through 9. Alright, so what if we set I to 90? Running this now, we get nothing. With a do-while loop structure, we would essentially have this print 90 one time, and then no more because it doesn't meet the condition. And there's two ways to do this. So the first way is you just take the body and you pretty much put it on the outside as well. So you put one here and make sure the spacing and everything is right. So it's going to look like this. And now the 90 shows up at least one time and the condition is no longer met, so it stops. You could also increment I here if you want. So you could say I plus equals 1. And then it would increment it to 91 if you need to do the increment for every single iteration. But in this situation, it doesn't really matter. So that is one way to do it. And that's pretty much the simplest structure. However, one problem is if you have a really big body for the while loop, you might not want to duplicate all of that code. This one's really simple because we just have a print statement, so it's not a huge deal. So I'm going to teach you another structure where you don't have to do the repeating code before and within the while loop. So it's going to look like this. We're going to say while true. So we're just going to create a loop that goes on forever. Within this loop, we're going to print I and then increment I by 1. And then we're going to check for a condition to break. So if I is greater than 9, then we're going to break out of the loop. So let's get rid of this code, and now this is our code. So running it now, and we get 90. So let's go through this step by step. We set I to 90, we print I, which comes out as 90, we increment it, which goes to 91, and then we check if it's greater than 9, which it is, and it breaks. This loop can be used in a similar way to the original loop. Let's set I to 0, and we run this, and we still get 0 through 9. So everything works exactly the same. However, now we know it's going to execute at least one time. So that is a do-while structure in Python. Stay tuned for the next video. So musical, I know. Hey everyone, welcome. So this video we're going to be talking about creating an indefinite loop, or you might hear it as sentinel loop if you're in university or whatever. It's a little bit more of a fancier name to mean the same thing. But pretty much, we're going to create a loop that is an infinite loop, but we can create some way to break out of the loop if we want. So that's the magic of an indefinite loop. We do not know how long it's going to go on. It'll just go on indefinitely. All right, so where do we even start? Well, there's a lot of different ways you could construct something like this. My best way to think through this is to come up with an example of maybe a menu or something where you ask the person if you want to continue. You know, maybe you're reading some data from the keyboard and you want to keep doing that indefinitely. So let's just go through an example where we ask the user if they want to continue and they can hit yes or no. So what we do is we print a question. Do you want to continue? And then we get the response through input. So we'll say response and say input. And now this is really interesting because something so simple can cause someone a lot of headache. Because if you're getting input and you're trying to ask them if they want to continue, you might think, oh, I'm going to assign this to a variable called input. And the problem with this is that, well, we can't use input because that's the name of a function here. So that's not going to work. So you might shorten that. Oh, I'll just use in. That'll work, right? Well, no, because in is a keyword to check if a value is in something. So you're like, oh, you know what? The ultimate solution here, I'm going to use the word continue to see if they want to keep going. And nope, that's not the keyword you want to use either, because continue is used to continue the next iteration of a loop. Whoops. So we have three different names that you might think to name this variable, but you can't. So what we need to do is we need to do something else, such as response. Fortunately, we have some syntax highlighting, so if it's white, we know it's good. And now what you can do is you can do a while loop to see if the response is yes. And actually, a common convention is y or n. So y being yes, n being no. So while response is equal to the value yes, then what we're going to do is continue the process. So we can ask them again if they want to continue, and then we can get their response. So, this looks oddly familiar to exactly what we did in the previous video. So this is essentially a do while loop, even though there's no do keyword inside of Python, where we're doing something at least once, and then we do it again within the loop if the condition allows for us to do it again. So this was one of the two ways I taught you guys how to structure a loop like this, where we have a little bit of redundancy with our code. We have it in here twice. For such a small loop, it's not a huge issue, but if you have a larger loop, then you probably just want to say while true and then have some condition to break. And maybe we'll get into showing you that in this video. But for now, let's run this and give it a try. We hit run. Do you want to continue? You type Y, hit enter, and it keeps going. So this is how you create an indefinite loop. Then if you don't want to go anymore, you could put n, or actually you could just put literally anything else because it's just checking to see if it's y. So we could actually do q, whatever it might be. Another common example of this is you might have a loop and then you can use q to quit. So a setup like that might look like this here. This is just a different example. I'll separate this out so we can reference the old code and then we can replace it in a second. So we'll say while true, and then we could do something like print q to quit, continuing, how do you even spell that, man? Continuing, all right, spelling is not my strong suit. Don't worry about it, guys. Continuing, ... And then we can get some user input here. So we'll say response is input. And then if response is equal to Q, actually we'll just do uppercase Q. Then what are we going to do? We're going to break. So that's another structure you could do for this. So let's get rid of the old one, run this, and it's going to just continue anytime we type anything. And then when we're ready to quit, we can hit Q, make sure it's uppercase, hit enter, and it stops. So that is another example of an indefinite loop, and you'll probably see variations of this throughout your programming career. Next up, I want to talk a little bit about casing and characters, so stay tuned for the next one. Hey, what is going on? This video, we're going to talk about another variation of an indefinite loop, and we're going to be talking about characters because this can cause some issues when you're doing these comparisons here. So I modified the loop from the previous video. You can copy this here, but essentially here's how it's going to work. It's going to ask you if you want to continue, And if you hit Y, it's going to keep asking you. And yeah, it's kind of pointless, I get it. But the point is that continue question can be a large section of code. The point here is that we're building the structure to allow repeating code indefinitely. And when we want to stop, we can put something like N to quit or whatever else we want to put there. It doesn't really matter what we put there. So as an example, you can put lasagna and it still stops. That's because we're just checking for this Y here. And the funny thing here is you can actually put a lowercase y and it still breaks. That's because it's only checking for an uppercase Y and they are two different things. So if you want to check for both, you actually have to be careful here because I made this mistake earlier. We need to use and. So my first thought, here's what my first thought was. We could say or response is not equal to lowercase y. This actually doesn't really cover the logic properly because if response is not equal to y, that's going to break automatically because we're using or. Meaning if you put in a lowercase y, this is still going to be hit as true and it's going to break. So when you're using the not equals operators twice here, you may need to use an and just to make sure you cover all of the cases here. So running it now, we can put a lowercase y and it still runs. If you want to use or, then what you actually need to do is you need to replace the not equals with equals or response is equal to y, and you don't want to break, you actually want to continue. Otherwise you want to break. So that's another way you could write the same exact loop. Running this and we can try it out and it seems to be working the same exact way. Good. This concept of switching between the equals with or and the not equals with and, that's a thing called De Morgan's law. You can learn about it in electrical engineering or just logic with computer science, but you just got to really think about what you're actually saying in your if statements. So another thing is you got to watch out with these y's because they are two different things. That's because capital Y and lowercase y are two separate characters, and this is based off of a thing called an ASCII table, which is basically all the characters we can use in simple text. So we got some stuff that doesn't actually show up in here like null and bell and backspace, but the main thing we care about here is the characters. So you can see this is uppercase Y and this is lowercase y. And you can see that these are two separate characters with different values. So they're not one and the same thing, which makes sense because how would a computer be able to tell between an uppercase y and a lowercase y if they were the same thing? So you can use the or here or the other variation where we had the and, or what you can do is you can use the lower method. So here's what it's going to look like. We're going to say if response dot lower, that's going to replace the string with a lowercase version of the string. So in that situation, we only have to check for a lowercase y, and we can get rid of this or, which honestly just makes our code a whole lot simpler because we don't have to worry about any weird logic issues there. And we can switch this back to not equals to y, then we're going to break. So if your response is not y, then we're going to break out of this loop. So running this, we can try an uppercase y, try a lowercase y, and we can try a q, and it seems to be working just fine, but now our code is much easier to read. There is also an upper method. So it does the same thing, it just makes it uppercase, and in that situation you would need to check for an uppercase y here. But you'll often see these methods for string comparisons as well as just lowering or uppercasing a string for presentation. Now again, I'm using the word method, and it is a function, but the difference here is that this function is attached to something using this dot here. When you use the dot to access the function, that function is classified as a method. So function and method, pretty much the same thing, just that function stands alone and method is attached to some object, such as this response here, which is a string. So strings have a method called lower that we can use to replace it with a lowercase version of the string. So that's all I got for you in this video. Stay tuned for the next one. Hey everyone, welcome back. This video we're going to be talking about a special function to check if a string is lowercase. And there's actually another function to check if a string is uppercase. When would you want to use this? I have no idea, but it's good to know that it exists. Especially when you have methods like lower, that lowercase a string, it's nice to be able to check if something is lowercase. Also, apologies if there's background noise. The person above me has decided to run on the treadmill of all times. Psh, unbelievable. Anywho, let's go through this example and check to see if a string is lowercase. So this is the loop we had in the previous video, and we're just showing a use case of this lower method where we take an input and we lowercase it to see if it's equal to the value y. It reduces us from having to say if response is y or if response is uppercase y. Then there's two things that we have to worry about. Instead, in this case, we only have to worry about one. So to check, we're going to need a string. We'll just say if response.isLower, parentheses. Then what we're going to do is print it's lowercase. So that'll be interesting. Continue. And what is our response? Let's say y with a lowercase y. Press enter and it says it's lowercase. Put it with an uppercase y and it just says continue. It doesn't say it's lowercase. And we need to change the text to it's upper. So running this now, if we say y capital, it says it's upper. Now what happens if you have multiple characters? So like what if we put yes? Well, in this situation, it just ends. That's because this does not evaluate to true, and then we break from the loop. So in order for something to be upper, every single character has to be uppercase. In order for something to be lowercase, every character has to be lowercase. So let's try again and put a full uppercase string. Yes. We run that, it says it's upper. The loop still ends because we're checking for the single character y and not the string yes, because we're looking for this here. However, we can definitely tell that it's uppercase. So we could put something in here. No need to yell. Running this now, the same exact thing happens, we just changed the output, so now it'll tell us to stop yelling. So that's how you use the is upper and is lower methods. Thanks guys, stay tuned for the next one. And yeah, I'm definitely looking forward to the next one because we're going to review everything we just talked about. And who doesn't love reviewing hundreds of lines of code? I mean, it's going to be a blast, so stay tuned. Hello ladies and gentlemen, in this video we're going to review everything we've talked about since the last review, which is pretty much some variations of loops and how to be a little bit more fluent in them. So you can find this up on my GitHub at Caleb Curry, and you can go into the Python folder and then go into beginner Python, and this is called 07 more looping. So I'm just going to copy this, paste it all in our editor, and go through it. You want to make sure you have a pretty good hold on all of this information before we go to the next section. However, this is going to be a little bit different than everything we've talked about, mainly because I don't do the examples exactly as they are in my notes. I just use the same principles. So you might see a few other variations or a few different things in these notes. However, the principles stay the same, so you should be able to understand fairly well. So let's just run through this and go through everything. So the first thing we talked about was break, which can be used to break out of a loop. And this is often used if you're going through the loop and you only need to go a certain amount of times into the loop and stop when something is found or some condition is met. So for example, if we're looking for Python, what we can do is we can iterate through the language list and we can print if the item is found and break out. And Python is the first element in this list, so immediately it finds Python, prints Python found, and breaks out of the loop. Things in the same block of code after the break never get hit. So if we put this print here, you can't see me, is never going to execute. However, this print here will execute because it's on the outside of the if, and the if is only hit on occasion. So if the condition in the if statement evaluates to true, the break is hit and nothing left for that iteration executes. However, if the if does not evaluate to true, then anything after the if will be printed or executed. So in this situation, we're looking for C++, which is the second item in this list. So for that first iteration, it's going to print it's John Cena, which is the exact output we get. The next iteration, C++ is found, so it says C++ found, and then it breaks and nothing left is executed. Continue works in a similar way, except it's only going to skip to the next iteration and not break out of the loop altogether. So the example given here is that if we're searching for Java, and if you look back at the list, Java is here, and what is going to happen is it's going to print that and then continue. That means this print statement down here, it's only going to be executed when that continue is not hit. So for every other language, it'll hit this print, but for Java, it's not going to happen. So we have searching for Java, and then it says Python, not what we're looking for. C++, not what we're looking for. Java found. Perl, not what we're looking for. C#, not what we're looking for. An alternative structure for this is to use an else within the if. So we can say if language is Perl, then we can say it's found. Otherwise, we can say it's not what we're looking for. So that's why we have this other one, searching for Perl. We get these here, and then eventually Perl is found, and it continues the search. C# is not what we're looking for. All right, so that's enough on break and continue. I'm kind of sick of talking about those. So let's move on to the next thing, which is how to do nothing, which sounds a lot cooler. So if you want to do nothing, you can say for x in range 10, pass. It's going to do absolutely nothing each iteration. Why would you want to do this? Well, this is the equivalent to a to-do, which is pretty much saying, hey, we're going to implement this later. So you often see to-do in comments, like to-do. In Python, if you have to put something there in order for it to run, such as indented within a loop, you can just put pass. You can also use this for classes and when you're defining your own functions. You may also see this for a busy wait, which basically just keeps your processor busy for a certain length of time or a certain number of iterations. The next thing is using else within loops. So we have one with the for loop. If we have the else here, it's going to execute no matter what, because we're not hitting a break. The only time the else isn't going to be hit is if we hit a break. So we get it outputting all the numbers, and then it says done. In the case of a failed search, we could say nope if nothing is found. So we're searching for the language Alabama, and our languages list obviously is not in there because it's a bunch of programming languages, so we get nope. Next up, we got while loops. Here is a situation where we count from 0 to 9, and we get that output right here. So that's how you do that with a while loop. You can see the three pieces, the initialize, the condition, and the update. Those are the important components, and you can customize it however you want. So for example, you can start at 30 and count down. So that's going to look like this, and it's counting by 2, so you get 30, 28, 26, all the evens down to 0. Next up, we can convert between a while loop and a for loop just to show you that either one is fine. So we have the three components, the initialization, the stopping point, and the increment. If you do it within a for loop with a range, it's going to look something like this, where you have the start, the stop, and the increment, or the step. With a while loop, it might look a little bit different, and it's a little weird with the variables here, but we start with a variable, and while it's less than some stopping position, we're going to do something, and then we're going to increment that number to progress in the loop. To make them match perfectly, the update should come at the end of the while, because this stepping here, this happens at the end of the for loop. Another thing to know is that when you're passing a variable to the range, the variable is not affected. So we pass in this initialization, but then we use I to actually use the number within the loop. So initialization is left at 5. Next up, we have an else with a while. So we're looking through these numbers. Once it's done, it says else of while, which kind of is useless, but it shows the point. Here we get that output right here. And then we just have some random other examples. So the first thing is we're going to check if a number squared, anything up to the value 10, is greater than 50. So the first one that is big enough is 8. So the way this is set up, we're basically setting a cap of how many numbers we want to check. We want to check up to 10 from 0, not including 10. And the first one that is large enough, we want to finish with that and break. We're literally counting from 0 to 10. If you really only cared if any of the numbers are large enough, then you could start at the other end and save yourself some time. But we're specifically looking for the first number that is large enough, so that's why I started at 0 and counted up. Here is the example of a flag variable. You would want to do this if you're not comfortable with an else after a loop. So you set, in this case, this is a good example because the previous examples in the series, we were using Boolean flags. In this situation, we're using an integer flag, so -1, and it's going to stay -1 until told otherwise. So if any of the numbers squared are larger than 500, what we're going to do is we're going to update this index to whatever position that is at, which we can use later on. This coordinates to this output here. This was for the first one, but now we're on this one, and we get none are big enough because we're only checking up to 10 exclusive, and none of those squared are going to be larger than 500. So we basically check that flag later on. If the index is greater than -1, then we can print that value. Otherwise, we just say none are big enough. So that is how you would do a search and return the index. This is just a concept, just to be clear, guys. A flag variable is a concept. There's nothing new on syntax. You don't have to do a special flag variable or create it in a certain way. It's just a variable that we're using in a certain way. Next up, we have a setup for a do while loop, which again, there's no concept of this in Python, but we can implement the same thing using a normal while loop, where in this situation, it's going to print I at least one time. And in this case, we're incrementing it. Then we check to see if it's under 10, and then we do it again. So there's a little bit of code redundancy as we talked about. However, it does get the job done, and it's going to print 15 no matter what. So to generalize this, we do stuff, we check to see if we want to continue, and then we do stuff again. So we can use this structure or the other structure for a do while loop to create an indefinite loop. And in that situation, we're going to continue indefinitely as long as some condition is met. So if the response is y or lowercase y, then we can continue forever because it's in a while loop. So do you want to continue? Yes, and it's going to keep asking us. If you wanted to flip this so there's no code repetition, then what you would do is you would say while true, get the person's response, and if the response is not y, then you would break out of that loop. Oh, I'm hungry. I want chicken fingers. Sounds good. Careful again with the variable names. Don't use continue or in because those are keywords, so don't try it. And here's some vocabulary. A sentinel value is just a value to stop a loop. So if you're going and you want to stop when you hit Q, then that situation, Q would be known as a sentinel value. Next up, we got upper and lower, which can be used to make our code a little simpler. So we can just check for lowercase y by using response.lower. This is an example of a method, which is just a function attached to an object, in this case, a string called response. It's important to understand as y and y are not the same thing. Overlooking this can introduce logical bugs in our software. Logic or logical bugs meaning that the code runs, it seems to work, however, certain scenarios it doesn't work and you don't see them all the time because you might be practicing and testing it using a capital Y and you find out, oh, the lowercase y is broken or whatever it might be. So we want to avoid logical bugs as much as possible. There's also an upper, so this one it's asking am I screaming, and that's going to pop up. Let me show you right here, am I screaming? It's in all caps. And there's also a way to check, so you can say is upper, is lower, or else mixed. Caleb is not uppercase, it's not lowercase, so we get mixed. So I'm actually not too sure when you're going to need to check uppercase or lowercase, but it's still good to know that that exists. So that is all the review of everything we talked about in the last 10 videos or so. Make sure you understand pretty good everything in this, and that'll help build the foundation for the next section. All right, peace out, guys. Please be sure to subscribe and stay tuned because we're going to get into some more complex and exciting stuff. Hey everyone, welcome back to your next section of your Python tutorial series. Now, my throat's getting a little rough. I don't know what the deal is, so I apologize. I feel like I've been smoking like 15 packs a day, which is just ridiculous because I never go above 12. But this video, I'm going to be talking about nested if statements. So far we've talked about if statements within a loop, which is pretty simple to comprehend. But now I'm going to be talking about multiple if statements nested one within each other. The very first thing I want to show you guys in this video though is that indentation is vitally important in Python because it's used to determine how code is executed. And I imagine you figured this out by now, but this here is completely different than this here because of the break. In the first situation, if we find C#, we break. In the second situation, we just break after the first iteration, so we never get to the second iteration. So running this, the output is C# found for the first one, and then the second loop doesn't find C# on the first iteration, so it just breaks and stops doing anything. So that's the foundation that you need to understand. When we are doing nesting, you have to be very, very careful where you put your code. And if you have a bug in your code, there's like a 98% chance you just didn't indent right, or you put something in the wrong spot, or you haven't watched enough of my fabulous tutorials, which actually is probably more likely the case. So what we're going to do now is we're going to deal with nested if statements. So what I want to do is I want to create a few variables. And basically we can do a system where if logging is turned on, we want to log something to the terminal. If logging is turned off, then we don't want to log something to the terminal. So we'll say logging, and we're going to set this to true. And then let's say we're building a system for people to log in And we can set that in a flag, so logging in, we'll set it to true. And I'm also going to use my name, which, by the way, is Caleb. It's not Caleb, although, I mean, Caleb sounds pretty cool too, so whatever you guys like. So here's what we're going to do. We're going to say if logging in, and if it's true, which we don't have to actually put equals true because it's a Boolean, so it's implicit. So if logging in, we're going to print name plus is logging in. So let's run it, and it says Caleb is logging in. But this seems like something we might just want to log. Like, we don't want to announce that every time you log in. Like, how often do you log into a website and it says, oh, Caleb is logging in? Well, if your name is not Caleb, it's probably never said that, but assuming your name is Caleb, it's probably not going to do that very often. But it might log that information to the terminal on the server side, as an example. So we can actually put this inside of an if statement. So we'll say if logging, then we can print the name. And we need to indent again. So if we're logging into the app and logging is turned on, then it will go into the terminal. If we turn logging off, which you could get this value from a configuration file, run this, and now it does not output to the console. Another addition we can do is we could actually do something that executes within the first if, but not in the nested if. So we'll go in here and print welcome, and then we'll say plus name. So running it, it says welcome Caleb, and it says Caleb is logging in. We can turn logging off by setting this to false, and running it, now it just says welcome Caleb. The indentation is very important. Make sure everything's indented exactly the same way, or something will execute in the wrong context. So that is your introduction to nested if statements. And in the next video, I'm going to be talking a little bit about complex if statements because they can be used to achieve a similar thing. So we're going to talk about the difference and when you should use which. So stay tuned, y'all. Hey everyone, this is a follow-up to the previous video where we introduced the concept of nested if statements. And in this situation, we are doing something specific to logging if logging is true. This is a perfect scenario where you might want an if statement inside of another if statement. When we're logging in, we print welcome Caleb, and we only log Caleb is logging in the terminal in this situation if logging is true. So because that output is specific to that logging variable, this is a perfect scenario. However, in certain situations, you're only going to do one thing based on numerous variables having a certain value. And in this situation, a complex conditional is more appropriate. And what do I mean by complex conditional? I literally just mean using logical operators. So and or to make two conditionals within a larger conditional. So the code we have here is not ideal for a complex conditional because we want to test that logging variable separately. However, we're going to go through an example where logical operators might be more appropriate. So let's say we're making an app to determine whether you're invited to a party, right? We got so many friends, we don't have time to think through each one of them. So what we do is we gather data about all these people, which obviously would take way longer than just thinking about it. But let's just say we gather data about these people using their Facebook accounts. We can automate this system. So to save us time, we write some automation software in Python to skim everybody's Facebook profile or social media profiles, do some advanced machine learning, and we're going to come up with a way to invite or not invite people to the party. And we are going to base whether the person is invited on 3 descriptive features: their age, whether they like to dance, and whether the person is fun. So we're going to hard code one example, but you could do this in a loop with data you read from a file if you really wanted to. So let's go age is 20, fun, we'll go with false, and then likes to dance, we will go with true. So notice that we have 3 variables as the input, but the result is only one output, whether or not the person is invited to a party. In this situation, you don't really need to use nested if statements. You can just put it all within one because you're only going to have essentially one body to execute, which is to invite them or not. So I'm going to come up with a complex conditional, which you can type out. I'll just say if age is less than 30, so we don't want no old people at our party. Ugh. Or, if they're really fun, maybe we'll let them come. So we'll say or fun. It's a Boolean, so we don't have to compare it to anything. Now I'm actually going to use parentheses here. And this is not to do bad Python syntax, but I actually want to group these with an and likes to dance. So this is our complex conditional, and we'll break it down in a second, but we will say print you're invited. And just to be nice, we'll give an else just to be really clear that they're not invited. Print, get away you freak bag. Perfect. We don't want anyone confused whether or not they're invited, so we're just gonna put that there. Now I use parentheses here because anytime I mix ors and ands, I find it very confusing on what the actual output is going to be. So although this is possible, and we can run this, and it says you're invited, the reason it says you're invited is because this is true, which makes this or true, and the other side is true, likes to dance is true, so the and evaluates to true, and we ultimately get invited. So this is an example of a complex conditional, and you can break this out into a nested if statement, so it's going to look something like this. I'll actually copy this and just modify it. So we'll take this, get rid of this section right here, and inside of this if, we're going to have another one saying if likes to dance, then we get invited, like so. Now we have to consider where the else is going to go. We will put it right here. So if they don't like to dance, but they manage to get this far, then you say get away freak bag. So you can use nested ifs to be a little bit more clear on what things you want to check first, or what kind of outputs you want to do for each section. So for example, we can be more specific in here and say, oh no, you can't dance. And then we can have another else for this outer if, printing you are not invited. Sorry. So it allows us to be a little bit more specific, and we can replace this one here now. So let's run this and see what happens. It still says you're invited, but let's say we set this to false. So we no longer like to dance. Well, now it's a little bit more specific. It says you can't dance, and go away Creative Cloud. Do you want to die? Looks like you do. All right. You can't dance. So when we use nested ifs, we can be more specific in the response we give, and the ifs can be a little bit more clear when we're doing really complex conditionals. So the ultimate question is, when should you use a complex conditional as opposed to nested ifs? So my rule of thumb, and this is me, if I am mixing ors and ands in the same expression, the same conditional, I will split that out into nested if statements. That's just because it reduces errors on my part, because I get confused when I have a bunch of ors and a lot of ands. Then I have to really think about what is going to happen when we have a bunch of different variables. If we have just ors or we have just ands, then I can put it all in one and I'm totally fine. The other scenario when you would want to use nested ifs is if you need to be more specific with the responses, such as this one here, oh no, you can't dance. If we just had one really large complex conditional and it evaluates to false, it might not be as easier to see which one caused it to be false and to do a nice response like this here. So that is my 2 cents, but let me know in the comments what you guys think. Do you prefer complex conditionals with just one if statement, or do you prefer nested if statements? Another thing is I really try to avoid going really deep with the if statements. If I'm getting 3 layers or 4 layers deep, then I start to think, how could I redesign this code so I don't have to do this? So that's all I got for you guys in this video. Stay tuned for the next one, because we're going to be talking about nested loops. Scary, but kind of cool, trust me. Stay tuned. Hey everyone, welcome. In this video, we're going to be talking about nested loops inside of Python. We're going to specifically talk about for loops now, and later we'll get into while loops in upcoming videos. So this is where programming can get a little bit complex and a little bit hard to follow. So I'm just going to ask you to pay attention, stop looking at memes, and just write out the code that we're going to write. But fortunately, Python makes it pretty easy for us compared to some other languages, because you don't have to worry about setting up nearly as much. So here's what we're going to do. We're going to say for I in range, and we'll just keep the numbers pretty small. We'll say 4, and then inside we're going to say for j in range, and we'll go with 5. Then on the inside of the inside loop, we're going to print I, comma, j. So let's run this, and when you do this, you'll see you'll get a bunch of output here. So scrolling through this, we can go through and try to understand it. So we start at 0, 0. And basically, I starts at 0, and for each iteration of this loop here, we're going to run this entire loop. So the first time of the inner loop, we get 0, then we get 1, then we get 2, then we get 3. So it runs 5 times, which comes from the range 5 there. Then Next iteration of the outer loop, I is incremented to 1 right here. And we run that inner loop another time. So we got 0, 1, 2, 3, 4, and then the same thing happens again, iteration 3 of this outer loop. So it can be a little bit confusing to look at it that way, so let's try to make this a little bit prettier. And what we're going to do is we're going to just print J, and then we're going to say end, and just use a space. So that way everything stays on one line, and then we'll print on the outside, we'll say print, and keep it empty just to print a new line. So running this now, and we get 0, 1, 2, 3, 4, and we get that a total of 4 times. So maybe this is a little bit clearer for you guys. Just another way to look at the same thing. We are printing 0 through 4 in this loop right here. And how many times are we going to do that? We're going to do it 4 times with this outer loop here. So that is your first example of a nested loop. And just so you guys are clear, this print here is inside of the outer loop. So after we print 0 through 4, we print a new line to go down to the next line, which comes from this right here. Then we do this loop again, and we print a new line. Then we do it again, and then we print a new line. And then again, I think, if I counted right. I and J are arbitrary, but you'll often see that. You may see K as well. If you're using 3 loops, you'll often see I, J, and K. So that is your introduction. What we're going to do is we're going to do a little bit of review just before we jump into the next section. I know we haven't talked a whole lot since the last review, but this stuff is so essential. I want to make sure we are on the same page. So stay tuned. I'll see you in the next one. YOLO everybody, this video we're going to be reviewing a few of the concepts we just talked about, and I know we recently did a review, although it never hurts to do a little bit extra review. I mean, even me, an elite pro at programming, is reviewing these concepts. I mean, that being said, I am getting paid millions by YouTube, but we're still going to go through these, and I recommend you do as well, even if you think you got these concepts down pretty solid. So this is up on my GitHub. Caleb Curry is my name. I'm going to copy this and bring it into my editor. Do you need help advancing your coding skills? Check out my new program, Code Breakthrough. Code Breakthrough offers hands-on learning with Python and data structures, algorithms, and interview challenges. With a supportive community and regular new content, Code Breakthrough will help you get hired or advance your career. For a limited time launch special, use the link in the description to get 20% off your subscription. See you there. So the very first thing we talked about in this section is appropriate nesting. And Python is interesting because the indentation determines where a certain piece of code will be executed and what block it is part of. This is widely different than many other programming languages which use curly braces to determine where code is executed. Some people really like the indentation, other people do not. Personally, I like it. I think it looks nice, and it also forces you to indent properly, which in going into other programming languages, you need to have that skill as well. Even if in other programming languages such as Java, the indentation does not affect the code execution, it's still important to format your code in such a way so you can see it and know how it's going to be executed. So Python is a great training ground for that. So just make sure you're putting things in the right spot. So here I show a really simple example of how you might make a mistake. In this first situation, we break if the language is C# as we're searching for it, and we print language found. So that's where we get C# found. The second one is a little bit different because it breaks in the wrong spot. It's going to break after the very first iteration no matter what. So the first iteration C# is not found, so it breaks and it stops looking. So even though C# is in the list, we do not get an output for this loop because it breaks too early. Now I say here Python is white space sensitive, but I'm not entirely sure that's true because I can go in here and I can space this stuff out and it works fine. Running this and I get the same exact output. The main thing that Python is sensitive to is indentation. So it's sensitive specifically to the space at the beginning of a line. So if I added some space here and ran it, well now, we're gonna have some issues. It does not like that. So we're gonna bring that back, put it back to where it was, and also update my comment there. So now that we understand the foundation of indentation, I think it's safe to start talking about nested if statements, which is what we talked about next. And I go through a simple example where we have a few different variables. The main one we're worried about here is the logging and logging in. This could be confusing because we're using the word logging in two different ways. The first one being logging for debugging purposes or just for informational purposes, and the second one specifically to logging in or signing into a website. So it might have been more appropriate to use the variable signing in. However, tomatoes, right? And then we just have this name variable just to print it. It doesn't actually case on the variable name. So if we're logging in, what we're going to do is we're going to print welcome Caleb. In this case anyways, because name is Caleb. Before we print welcome Caleb, we're going to case and see if logging is turned on. If it is, we're going to write that this person is logging in. So if, for example, if you wanted to keep track of all of the logins, this is the appropriate spot where you would write this to a database, or you could write it to a file, or whatever it might be. We're just writing it to the terminal, and that's fine in this context. But this is only going to execute if logging is turned on. So that logging can come from a configuration file. So for example, you deploy some software to people, or you have some website and you're having some issues, you can turn logging on and start getting information. See, when Caleb logs in, we have some errors. Maybe there's something up with his account. What's different about his than everyone else's, and so forth. In certain situations, you can use nested ifs, but you could also use complex conditionals, and we show some situations here where we do just that. So here's an example of a complex conditional where we have three variables and some combination of these determine whether or not a person is invited to the party. So in the first situation, if they're under 30 or they're fun and they like to dance. So what this means is if you're 25 and you're super boring, that's fine as long as you like to dance. Everybody who comes has to like to dance. You can put them all in one like this and then give some general output here saying you're invited to the party. Or you can break this into nested if statements to be a little bit more specific. I like to do this when I have an or and an and in the same expression, just for clarity's sake. Now for this nested if for likes to party, we can determine if the person likes to dance or not and be more specific, saying something like, how could you not like to dance? Because dancing's fun. I used to take some hip hop dance classes. I was pretty boss, to be honest. Definitely gonna get back into that someday, but for now, I'm gonna stick to programming because I'm actually decent at this. So this allows us to be specific to liking to dance, and then we can have the else saying they're not invited. So those are just some more examples. Whether you use nested ifs or complex expressions to be evaluated, that's totally up to you. I'm gonna let you deal with that. So next up, we got nested for loops. This is just a simple example, just as a taste of what we're going to get into next when we're gonna deep dive some of these loops here. And running this, it's just going to print 0 to 4 4 times. 1, 2, 3, 4. 1 time for each iteration of this outer loop. We space them out with just a space, and then after each iteration, we print a new line just to go down to the next line right there. So that is your review. Hopefully you understand everything in this. And now let's go into the next section with confidence. So I will see you guys soon. I'm gonna go practice my hip hop dance moves, and I will see you in the next video. Hey everyone, welcome back to your next section of this Python tutorial series. We're going to dive deep into nested loops and the different things we can do with them. So I'll probably do that, finish up this series, maybe make some assembly videos, and then I'm probably gonna quit YouTube. Guys, I'm just kidding. All right, I'm not going to teach assembly. So let's first start with a nested for loop, which we talked about earlier, and then we'll talk about some variations in this video, and then get into while loops and all kinds of other junk like that. So we'll just say for I in range, and we'll just put, let's go with for, and then we'll do a nested for. So for j in range 5, print I comma j. So this is the most basic one, and pretty much this is just going to iterate through that inner loop 4 times, printing 0 through 4. You can use I within this inner loop, and it's going to display it numerous times. If instead you just wanted to say iteration 1 and then showed the output, and then iteration 2 and then showed the output, what you would do is instead of printing it here, you would actually print it outside of the inner loop, something like this. Print, and we'll say it, if I can spell goodly, or speak English. And what we're actually going to do is we're going to say stir, pass in I, and then a colon. So here's what it's going to look like now. We run it, it says iteration 3, and it does the output, and we can actually get rid of I here if we want. Change the end, so we'll say end is just a space, and then back up to the previous indent, and we will print a new line here. So we'll just keep it empty like so. And let's run this, and here's what we get. Iteration 0, we get 0 through 4. Iteration 1, 0 through 4. Iteration 2, 0 through 4. Iteration 3, 0 through 4. Now, if you wanted to start with iteration 1, which would make sense, you could go in here and say I plus 1. So the very first iteration, we get this, and it goes up to iteration 4. We can do all kinds of variations. So for example, we could use I inside of some expression inside of the nested loop. So what if we wanted to count by a certain number? I'll show you how to do that. So instead of saying iteration here, we're going to say counting by, like so. And then I will just do comma I. And instead of printing j here, what I want to do is I actually want to print j multiplied by I. So running this, here's what we get. Count by 0, we get 0 every single time. Counting by 1, we get 0, 1, 2, 3, 4. Counting by 2, we get 0, 2, 4, 6, 8. Counting by 3, we get 0, 3, 6, 9, 12. So we're basically using the outer loop in an expression on the inside loop. So that is another variation of this for loop, and you can do all kinds of crazy things. Next up, I want to talk about using that outer iteration variable I inside of the range for the inner loop. So stay tuned for the next video. I'll see you then. Hey everyone, I just have a real simple video for you to show you how to create nested for loops using the outer iteration variable inside of the range for the inner for loop. So if that doesn't mean anything to you, then let's just code it out and try to go through a simple example. So first, I want to print a square. I want to print 0 through 9, and I want to do that 10 times. So here's how we would do this. We would say for I in range and pass in 10, so that's going to go 0 through 9. And for each iteration, I want to do that again. So for j in range 10, that'll go 0 through 9. We're going to print j, and we're going to say end is just a space, and after that we're going to print just a new line to get it on the next line. So running this is what we get. We get 0 through 9, and we get it 10 times. What we can do is we can shorten the amount printed each iteration by depending on this outer variable I inside of range. So we can use I for the starting position or the ending position. So as an example, let's use it for the starting position. In that situation, we would say I, comma, 10. So we're going to go from I up to and excluding 10. Running it, here's what we get. We get this triangle-like structure. The first iteration, since I is 0, we go 0 to 9. The next iteration, I is 1, so we go 1 to 9. And it keeps going up and up until we get 8, 9, and then just 9. And we can do a similar thing using I as the ending position, and that's going to be exclusive. So now when we do it, we get a similar thing, but it's in the opposite direction, and it ends at 8 actually. And maybe that throws you off just a little bit, but let me explain. When we put 10 here, that's exclusive, so the highest is 9. So when I is 9, the last iteration, we pass that into here, and the 9 is excluded, so we get all the way up to 8. If you needed that 9 in there, you just say I plus 1. And there you go. So that's how you make triangle structures, and you may see this in your development career. Maybe not, but it's okay. So next up, I want to talk about nested while loops. Should be pretty fun, so stay tuned and I'll see you then. Hey everyone, in this video, we're going to be talking about nested while loops. This can be confusing because we have a lot more going on than nested for loops. So let's just try our best. First, we'll create one while loop, and then we'll worry about the second one. So we have an initialization. We'll say I is 0. Then we say while I is less than 10, which is a condition. And then we have some code, and then after the code, we increment I by 1 in this scenario. This is the most basic loop. Starting off, we could just print I, and this will give us 0 through 9. So that's how we do one loop. Now, if we want to make a nested loop, we put another loop here instead of the print, and it's going to run once for every outer iteration. So let's try that. Let's just give ourselves a little bit of space and create a new loop here. Same exact structure, we're just going to use a different variable. So we'll say j is 0, while j is less than 10. We'll do something, and then we'll say j plus equals 1. Careful not to use I accidentally on any of these. You need to use j or some other variable name. All right, so now we can use code inside of this while here. So we'll print I comma j, running this, and it works. So we get 0 through 9 10 times. Let's make the output just a little prettier. So here's what I'm going to do is I'm going to print j comma and then say end is just a space, and after that loop I'm going to print a new line just by using an empty print and running this. Now we get 0 through 9 10 times. So notice that this is a whole lot easier to create using the for loops, but sometimes you're going to want to use while loops, and that's totally fine. Now you have to be really careful to put everything in the right spot. Anything off can mess it up. So one common mistake might be to assign j up here and not here. You might just think, oh, I need 2 variables because I have 2 loops, but running this, we're not going to get the same thing. You can see, we just get a bunch of white space, and pretty much it's just printing this new line a bunch of times. We get one output that we expected, but not one for each iteration. And that's because j is not reset to 0 each iteration of the outer loop. So let's put that back, and I'll show you another common mistake, and that is to accidentally use I inside of the inner loop when you're not expecting to. So for example, you could put I here instead of j, and running this, we get a totally different output. I mean, it's cooler, it's pretty, but it's not what we were looking for. And I imagine if you delivered this to a client, they'd probably not be too happy. You are getting sleepy. You will hit the subscribe button. All right, that's enough of that. Let's go on to the next video and talk about some different while loop variations, some different algorithms we may want to do. Hey, what's going on? This video, we're gonna get some more hands-on experience with nested while loops. And I want to get a sum of numbers, which you can do with a while loop, but I don't just want to get a sum of numbers, right? I want to get a sum of numbers for numerous numbers. Mind blown yet? Yeah, mine too. I don't even know what I'm talking about. So here's what we're going to do. We're going to say j is 0, and while j is less than, we'll just start with 10 here, all right? So this is going to go 0 through 9. And I want to sum up these numbers. And here's how you would do something like that. You would create a sum, set it to 0, and each iteration we're going to add whatever I is to it. So it started 0, then we add 1, then we add 2, then we add 3, so forth. And each iteration we're going to need to increment I, so I plus equals 1. And then at the end, what we're going to do is we're going to print sum. And heck, I'm even going to go the extra yard and make it pretty for you guys. So we'll say sum, comma, sum. All right, so we broke it. Oh, that's because I used j up here and I down here. See, I'm a noob. So we're going to go in here, type j. Literally told you guys not to make that stupid mistake in the previous video, and I just did it. So sum is 45. I think that's right. Yep, 0 through 9, 45. Now what I want to do is I want to put this loop inside of another loop. So right now we're going 0 to 9, but what I want to do is I want to get the sum from 0 to 9, 0 to 8, 0 to 7, 0 to 6, all the way down to 0. So we're actually going to make a loop that counts down. We're going to start at 9, so we'll say I is 9. And while I is greater than, and let's just go with -1, or you could do greater than or equal to 0. That's fine too. And then we're going to do something and then say I minus equal 1. So it'll decrement. Oh, son of a beanbag. Okay, where was I? This video is like the worst, I tell you what. All right, so in here, we're actually going to take this loop, cut it, paste it in here, make sure everything is indented nice and pretty. So now instead of going up to 10 here, I actually want to go up to I. And you can see I is 1 less, so if we want to match this loop that we created, we can say less than or equal to I. And let's just output this, see what we get. Run this, and we get a whole bunch of sums. The very first one up here is 45, and then it just goes down from there. So to me, the syntax for nested while loops just looks like total garbage. Like, it's hard to even see what's going on here, so we need to break this down step by step. We start with I is 9. And we're going to go down to 0, including 0. For each iteration of that, what we're going to do is we're going to get the sum from 0, starts at 0 every time, up to I. So that first iteration, we're going to go up to 9 and include 9. The next iteration, we're going to go up to 8 and include 8. And then 7 and 6, 5, all the way down to 0. So that is how we get these sums here. So yeah, nested while loops, syntactically kind of gross. And another thing that we could do to improve this, well, if you take a look at the sum, it is purple, which means it's being used somewhere. So we don't want to override that. So what we should do is probably use a different variable. So let's say added. And there we go. Now it's white. Added. And then replace it here as well. All right, just run and make sure everything's good. All right, there you go. All right, so to be honest, even I stumbled through this, but the point is that sometimes nested while loops are just gross and you should use nested for loops, or what we're going to get into later on is create functions to isolate a particular behavior. In the case of what we're doing here, we could have isolated the summing there or use an available sum function already, and we could then call that and make our code a whole lot cleaner. But we will get into that later on. Next up, we're going to review all the loop stuff we've talked about thus far before we move into the next section. And trust me, you'll want to stick with it because after loops, we're getting into custom functions, which is going to make coding a whole lot funner and a whole lot easier. Oh man, I want beef jerky. All right, you guys know the drill. I'm copying some notes from GitHub. You can find them on my GitHub profile, Caleb Curry, and then Python Beginner Python 09 nested loops. So I'm going to take this, paste it in our editor, and we're just going to go through it. So the very first thing is we just did some review of the for loops, how we can create a nested for loop that iterates 4 times on the outer loop and 5 times on the inner loop. So we get the values 0 through 4, and we get that 4 times. So make sure you understand what's going on with this before you move on to the while loop section. We can also add some custom strings here to say what iteration we're on. So iteration 0 all the way through iteration 3. I don't really think of iterations as 0 based, so it might be more appropriate to say I plus 1 there, so it's iteration 1 through 4. But you guys get the point, you can customize it to whatever you need. Next up, we can make even a more complicated loop. So this one's doing some multiplication, counting by a certain number. So here's how to count by 0 through 3. So we're using the outer iteration variable inside of this multiplication, and that's a little trick we can do there. Next up, outer loop variables and inner loop ranges. So we use I in the beginning here, and that's going to give us this cool triangle pattern. Next up, we got nested while loops. Obviously, syntactically, while loops are not nearly as pretty, but it does show us more step-by-step exactly what's happening. So maybe it's a little cleaner for you if you think more algorithmically, whereas I just like to think of larger constructs like a for loop. So I guess it's personal taste, but you can go through this and see that it prints 0 through 4 4 times. So same exact loop as the very one at the beginning, this here. Make sure you put everything in the right spot, because here's an issue where we put J at the beginning. I showed you guys this earlier, and when you do this, you get the first output correct, and then you get a bunch of spaces. That's because J is never reset back to 0, so this is never evaluated to true after the first iteration. Now here is a loop to sum all numbers. So we have a sum, and this one's actually counting down. So we start at 10 and we go while it's larger than 0. So it doesn't add in 0, which is fine. Either way, it's not going to hurt anything, but just saving that extra step. It adds that number to the sum and decrements J. So it'll go down from 10 to 9 to 8 to 7 to 6 all the way down to 0. And it'll print the sum, in this case 55, because we are including 10 in that calculation. And now we can do something in a loop, getting 9 to 0, 8 to 0, 7 to 0, 6 to 0, and so forth. So here's how you would do that. You first create the outer loop, and then you can paste that inner loop on the inside, so the final structure looks something like this here. So we're going while I is greater than -0, or you can think of it as greater than or equal to 0. Calculates the sum, prints it out, and we get this result here, 55 all the way down to 0. So the very top one, 55, that includes 10. We start at 10 and it is included. and it goes all the way down to 0. And then I just created a version that's just a little bit prettier on the output, which you can see here, and that gets us this result here. Oh, hello. Yo, what's going down?
Yo. I got ham.
Ham's cool.
Do you want ham?
I mean, if you want to give me some ham, I'll take some ham. Conclude my video.
What do you mean conclude your video?
Like, I'm recording a video, and
Oh, no.
I was like 2 seconds from finishing, so I gotta say bye.
Okay.
So you want to conclude it for me?
No.
Come on, you can do it.
Okay. Do I just say bye?
Yeah.
Bye, guys. Thanks for watching.
Thank you. Hey, what is up, everyone? In this video, I'm excited. That's what I am, because we are starting a new section and we actually get to do some useful things in this upcoming section. So we've talked about a whole bunch of different basic stuff, and now we can start to piece sections of code together to create things called functions. So we've used functions before, and they're useful to us, but now we can create our own functions. This is essential if we want to build any complex application, because just writing everything line by line is going to give us nightmares probably, and it's not going to really allow us to build anything too complex. So let's go through from the very beginning what a function is, how to create them, and over the next few videos, we'll be adding a little bit more complexity each video. So make sure you stay tuned for the next few videos, and we're just gonna start with the basics. So let's say I wanted to print to the console. We might say something like, hey there. So let's say we're trying to greet someone, right? So we say, hey there, and then we do another print. We'll say something like, welcome, Caleb. So we run this, and we get exactly what we expected in the console, nothing crazy. But if we wanted to do it 2 times in one run, well, what we could do is we could copy and we could paste it in here like so. And we run it, and it works 3 times, it's great. But then what if I wanted to change my name, right? I no longer wanted to be Caleb, and I wanted to upgrade to Caleb. Well, in this situation, I would have to go through and change every single occurrence, which that's lame because more than likely I'm going to forget because my brain is like a potato, and we're going to introduce bugs into our software. So we don't want to have repeating code, and that principle is called dry, don't repeat yourself, and we're just going to fix this by creating a function. So to do that, we say def, then we give it a name such as greet. We can make up whatever we want. We could call it, I literally can't think of a single other name. We could call it roller coaster if we wanted. All right, and then you put parentheses and a colon. And then just like with an if statement or a while loop, we indent and we put all of the code for this function here. So now what we can do is we can do that print inside of here and say, hey there, and then print, welcome, Caleb. So essentially what we're doing is we're taking a few lines of code and we're putting them in a group. And this concept of a group is known as a function. And we can invoke or call this function to execute those lines of code. You may have heard of the terms subroutine or method or any other variations, but they're all pretty much the same concept. We give a name to a section of code and we can invoke it numerous times. So now all we have to do is say greet. Gotta kill this terminal because I accidentally did the one thing. Run this and we get, hey there, welcome Caleb. But the cool part is I can invoke this numerous times. So I can just paste this and every single time it's going to run the same exact code. And if I decide to change my name for some reason, well now, running this, it changes every single occurrence. So if I wanted to summarize the benefits, here they are. The first is that we can save lines of code if the function is large. Rather than repeating the code over and over again, we can just create a function and invoke that function numerous times. It creates one source of truth, so you don't repeat yourself. You need changes, then you just have to update one spot. And ultimately, it can improve code readability because seeing this function call greet is very easy to understand what's going on, and you don't have just a bunch of code polluting all your files. And you'll see that more clearly as we go on. So that is your absolute basic beginner introduction to functions, and now we're going to make them more useful and a little bit more general to be used for more purposes. So stay tuned for the next one. Hey, welcome back. This video we're going to be talking about arguments and parameters. You'll often hear these words used interchangeably, but they are technically different, but I'll explain all that in this video. So right now we created this function to greet Caleb. Oh gosh, come on Caleb, get your name right. Caleb. And that's cool and all, but like we want this to be able to work with anybody. So anybody signs into our application or does something, we want to be able to say Caleb or Sabrina or you or whatever it is. So here's what I want to do. I want to invoke this function and pass in a name like so. This is the concept known as an argument when you pass data to it. So just consider greet to be this box that takes in some input and does something magical. We don't have to worry about what's in the box. From this point of view, it's completely separate. Now we can take a look at the inside of the box and we can take that input as name. Now we can take a look at the inside of the box and we can use that argument by creating a variable here. And this is called a parameter. So when you store the arguments inside of the function, inside the little box we're creating, that is known as a parameter. And we can use that in our code. So rather than saying welcome Caleb, we could actually say welcome plus name. All right, let's run this. And it says welcome Caleb. So it does exactly the same thing, but now it's more versatile. So I can go in here, I can create a few more of these calls and change the names. So we have one for Sabrina and one for Carl. Running this, and now we get welcome Caleb, welcome Sabrina, and welcome Carl. So that is your introduction to arguments and parameters. Again, arguments are the things you pass to the function. Parameters are the variables on the inside of the function used to store that data. Another thing is you can pass in variables. So for example, I could say name is Caleb, and then I could pass in this variable here. Running this, it works exactly the same way. This value Caleb gets copied into this variable here, name. So that's your introduction to arguments and parameters. We'll be using those throughout all of this, so if you don't have it perfectly figured out, don't worry about it. We're gonna move on to the next concept, which is a return. Hey everyone, welcome back. In this video, we're going to go over the concept of a return. And this can be used to exit a function early. So for example, we're accepting name here as an argument and it gets stored in this variable here. We can case on this. So I could say if name is equal to Claire as an example. I mean, just a total random name, nothing against Claire's or anything here. But if your name is Claire, I'm gonna do something else. I'm gonna say, you smell like pickles. Because who wants to smell like pickles? I don't want to smell like pickles. And then what I'm gonna do is I'm gonna say return. So basically, we don't want to greet Claire. Claire doesn't deserve our greeting. So we run this and it's fine now, but let's do one where we say greet and pass in Claire. Running it now and it says you smell like pickles. Sorry Claire, but you're just not welcome in this greet function. So that is how a return works. It works in a similar nature to continue and break with loops, except we use it for functions. So make sure you got all those words figured out. I used to get confused between break and continue and return when I very first started with programming. Return is for functions. Continue and break is for loops. We can use continue and break inside of our function if we are within a loop. And we can use return inside of loops if that loop is within a function. But I'm not going to get into all the details of that right now. Stay tuned for the next video because I'm going to show you a little bit of a variation on this code here. Hey everyone, welcome back. This is a very simple video. I just wanted to show you another way you might see this code right here. So right now we have this return, which is going to prevent these lines of code from executing. But anytime you are breaking out of something early, you can often see it replaced with an else clause. So here's what that might look like. You might say else, and then indent both of these lines here. And now we could get rid of this return, because it's impossible for both this and this to execute. So running this, we get the same exact output. So which one should you do? My personal preference is to use the return because I don't really like indenting and making more complicated code when I don't have to. I consider indents to kind of be like an extra layer, and the less layers, the better. I like to keep everything in line and avoid else's whenever possible. So that's just one option, but I think ideally we're going to return to what we had. Pun master. All right, there you go, guys. So right now, this return is just exiting the function, but we can actually use a return for something else that's quite magical, and that is to give output. So right now we are taking input, we have this name, but how do we give something back to the caller? That's what we're gonna talk about next. Hey everyone, welcome back. This video, we're gonna talk about return values. So right now, as is, this function prints to the console. And although that's fine in certain situations, we don't always want to just print junk to the console. We want to give that data back to the caller, which the caller, by the way, is when you call or invoke the function. We want to give that data back to the caller to decide what to do with it. Because maybe they don't want to actually put it in the terminal, they want to give it to some other function or assign it to a variable. And we currently cannot do that if we're just printing data to the console. So what I want to do is I want to change this up a little bit to return data instead. And I'm going to be a little bit nicer to Claire. I'm not going to tell her that she smells like pickles, even if it's true. I'm just going to say return, and we can actually add a value after the return and just give her some questioning. Who do you think you are? And then what I want to do is, if we're not Claire, I want to return down here. So let's move these prints down for a second and say return. And then we're going to say, hey there, welcome, comma. And then what we could do is say plus name. So now we can get rid of these print statements. And now our function is going to return data instead of printing it to the console. But this is going to change the way we have to invoke the function. Because run this right now and we get absolutely nothing in the terminal. That's because there's no print statements in any of our code. So let's go through just one example here. We're going to say greet. We're going to pass in Sabrina. And how do we actually get that return data? Well, we can assign it to a variable by saying something like returned greet Sabrina. I don't want to run it quite yet because we're still not printing anything. If you wanted to print the data, you would say print and pass in returned, like so. And running it now, it says, hey there, welcome Sabrina. And we can still use this just like any other function call. So we could pass in Claire as an example. And now the output is, who do you think you are? Because we're assigning to this returned and then immediately using returned in this print, we can actually just bypass that step. So we could take this and put it inside of the print, like so. So with this nested function call, the greet gets invoked and whatever that returns gets passed to print. So running this, we get the same exact thing. That's all I got for returns for right now, but it makes our function a lot more useful. That black box illustration makes more sense. We give it an input, it processes some data, and then it gives us an output. It's kind of like the basis of algorithms even. If you think of, we haven't really talked a ton about algorithms, but when you get into some more complex algorithms, you can think of them as this black box where we don't have to know the inner details. We just pass in some data and it gives us some results using that algorithm that we don't have to know the inner details of. We're doing the same thing here at a micro scale. We're greeting people and we don't have to necessarily worry about how it decides if Claire is welcome or what the message is. We just have to know that we can pass it some data and get some data in return. So what that means is we could move that function declaration completely out of sight and you should still confidently understand how this code works. The way we push that data away is known as an abstraction. We've abstracted away the inner details by creating a function. All right, so I'm going to put this back. We don't need a million spaces in our code. So we'll bring this back up to the top and we'll move on to the next video where we are going to be talking about default values, which are super important when it deals with parameters and passing data. So stay tuned. Hey everyone, welcome. This video, we're going to be talking about default parameters. So right now we have this function and we pass in some data and it processes this data. And if we pass in some name like Caleb, can't even spell my own name, run this, we get, hey there, welcome Caleb. But what happens if I try to invoke greet like so, and I pass nothing in? Running this, and we get an error. It says missing one required positional argument name. So it's not going to let us execute this code. But what if we just wanted to do like a generic greet? We don't use the person's exact name because the name might not be there. And an example of this that comes to my mind is when you sign up for a newsletter, you sometimes have the option to put in your first name, and it might be optional. And when you don't put it in, you might get an email that says, hello, subscriber. Or if you put your name in, it might say, hello, Caleb. They're often usually messed up, and they usually say something like, hello, Curry, and then proceed with the message. But they tried. They used part of my name to create the message. Another way that you could say that is that they parameterized the email. We're parameterizing our function. That's a really hard word to say. But enough on emails and parameterizing. We're just going to create a default here by saying name is equal to user. So if you don't put in your name, then it just defaults to user. Running this now, it says, hey there, welcome user. But we can still override that. We can give it a value. And when we do that, it uses that value instead. Hey there, Caleb. So that's an example of default parameters. So that's all I got for you guys now. Next up, we're going to talk about how to deal with numerous arguments passed into a function. Hey everyone, this video we're going to be talking about passing numerous arguments to a function. When we do this, we need numerous parameters. One parameter for every piece of data passed in. So what if I wanted to create a greet function? And this greet function is a little bit special because there's a flag variable in here that we can toggle whether or not to be nice. If we're feeling in a good mood, we can greet nicely. If we're feeling a bit ticked off, then we can be a butt munch. All right, so what we're going to do is we're going to say be_nice, and this is going to default to true. You know, generally I think I'm a pretty nice guy. And also, I like to keep the spaces out of the equals here for the parameters, although it doesn't really matter. And now what we can do is we can do some different casing. So we can say if be nice, and then we could say not, just because it's set up that way. So who do you think you are? Otherwise, we'll say, hey there, welcome, and then put the person's name. So running this, by default, it says, hey there, welcome, Caleb. But we have the option to go in here and put a comma and pass in false. And when we do this, we run it, it says, who do you think you are? So it's just another way we can make our function a little bit more versatile. Now I have a question for you. It's a challenge. I don't really expect you to know the answer because we're going to talk about it in the next video. What if I wanted to set this to false, but I wanted to keep this as is? Well, you can see there's a problem. If we get rid of Caleb and we just want to use the default there and we try to run this, it's not going to work. That's because it's taking this false value and assigning it to name, and it just throws everything off. It's trying to concatenate with a Boolean. Icky. I do not like. So what we're going to be talking about next is how we can do that, fix that problem so we can assign to a specific parameter. Hey everyone, in the previous video I showcased my life-threatening problem of being unable to assign a value to this parameter of my function and skip this. You know, we should be able to skip it because it has a default value. It defaults to user. So if you want to skip something, all you have to do is call out the parameter by name by saying be_nice and assigning it the value false. So that's going to assign that one to here, and this one here will remain user. So running this, it says, who do you think you are? And it does that because this gets evaluated. But just to confirm that name is working fine, we could say plus name, and we can just put a space right there. Running this, and it says, who do you think you are? User. So it is getting that default value still, and everything seems to be working fine. So this explains some things we may have seen when we do a print, for example, and we say, hey, and then we put a comma and a 5, and then we say end equals. Well, the reason this works is because this is a named parameter. We have to invoke this one by name because the print function actually allows us to pass in an indefinite number of arguments. I really do wonder if there's a limit to the number of arguments. I don't really know the answer to that. However, I do know that I can go in here and I can put a lot of information separated by commas. And eventually I'm going to want to change the way this is spaced. So that's where the named parameter comes in and assign it a space. So it works. Well, let's get rid of that mind spam, and we're going to now talk about different types of arguments. It's very, very important to understand this stuff, so stay tuned for the next video. So right now we're invoking this by keyword. We're saying be nice has the value false. When I say keyword, it means we're putting the parameter name in the argument. And we can swap the position of these parameters. So for example, I could say name and assign that to literally whatever we want. And running this, we don't get any errors, it's fine. So when we're going by name, it doesn't really matter the order it's in, but one thing is if we're going by position, the order does matter. So let's get rid of this for a second, and we say Caleb and false. Well, this is positional because we're basing it on what position the arguments are passed in on. The function call works fine. But if we were to switch these around, so we said false and then Caleb, this is not going to work. See, we get an error. And another situation that's not going to work is if you have a named argument. So let's say we go back to when we had be nice as false, and then we try to pass in a name, but we don't put the parameter name there, we're going to get an error. And it says positional argument follows keyword argument. So we're going through a bunch of different examples. What exactly am I trying to show you here? My point of this is to show you that positional arguments must come first and then the named arguments. So just like with print, we never go and say end and assign it a value like so, and then put some data to print. This doesn't work. And just to prove that to you, I'll show you. Running this, we get an error, positional argument follows keyword argument. And this is going to work just the same if we don't have default values. That is a different concept. So let me just show you that real quick. We can just have name and be nice. Don't have any defaults for that. And let's go back to invoking this function. And we say be nice is false. And name is kite, which is a pretty fly name. Running that, and it seems to be working just fine. Now, if you want to be strict about the way your function is called, you can. You can say, yo, these are positional only parameters, and these over here are keyword only parameters. That's what we're going to be talking about in the next video. Hey everyone, in this video I'm going to be teaching you how to create position only parameters. So right now we are passing these arguments by name, and this works. It's doing great for our purpose. However, for some reason out there, you might want to prevent passing data by name. And in this situation, you have to pass it by position. So you couldn't swap the position. You notice how be nice comes first and then name comes second in the arguments list. You have to do it in the correct order, and you have to do it just by passing in a value such as this here. So if you want to force it to be this way, I'm going to teach you how to do that in this video. And it's really simple. It's a little funky though. Just put a comma here and then put a /. So running this now, it works exactly the same. However, if we try to use a named argument like so, we're going to get an error. We get an error and it says positional only arguments passed as keyword arguments. And it calls it out by saying be nice here. Now you can actually just make some of your parameters position only. So if you wanted to make a name by position only, you would put a comma after name and then a / and then a comma for the next parameter there. So this is the syntax to do that. And running this now, it no longer gives us an error and it runs just fine. We can't pass this here by name, but we can pass this here by name. So anything before the / is position only, anything after is by name or position. So we can still do it by position just by passing in true here. Running that, and that works just fine. So that is how you create position only parameters. Check out the next video because we're going to be talking about keyword only parameters, which is passing them by name to a specific parameter here, such as be nice. So I'm going to be showing you how to restrict it to just that. Hey everyone, so at this point you should know how to make your parameters only passable by position, such as what we have here, but now I'm going to be teaching you how to create them by keyword only. To To do this, you put an asterisk in your parameter list, and anything after the asterisk is by keyword only. So we can put an asterisk here, and then a comma, and anything after this is by keyword. So running this now, we're going to get an error because we're passing in 2 arguments by position, and we're only allowed to give 1. So what we need to do is we need to say, be nice, and assign it true. Running it now, and it works. So what you can do now is you can put data between these 2 after the slash and before the asterisk to say both. On the left, we have position only. On the right, we have name only. And then in between, we have either. So I'm going to be talking about that in the next video where we're going to summarize all these different parameter things. So stay tuned for that. Hey everyone, in this video, we're going to summarize what we've talked about with parameters, whether you pass data by position, keyword, or both. And I created this function here. You don't have to type it out, just follow along for this video. You can type it out if you want. But basically what I wanted to show you here is that anything on the left of the / is by position only. Anything here is either. And then anything after the asterisk is keyword only. So when we run this, let's see what data we get. And this comes from what we passed in. So let's take a look at that. And if you're confused on how this is set up, once you understand why it's set up this way, it makes sense. We have to have the positional ones first on the left, otherwise it's not going to know what position we're trying to put it at because we just janked everything up, everything's moved around, and it ain't going to like that, right? So we put the positional ones on the left here. We have to put the ones that are either in the middle because the left side of that has to also be positional. So that's why all the keyword ones end up being at the end. So the very first thing we do in here is we pass in 4 pieces of data by position. That goes to position 1, position 2, 3, and then either 1. So you can see either 1 has the value 4, which comes from right here. So we could do the same thing with either 2. We could just pass in 5 like so. And running this, we still get the same thing where either 2 has the value 5. However, we can also use a keyword here to be more specific and say either 2 has the value 5. Next up, we have the keyword only, which we assign 6, 7, 8. But notice the order in which we're assigning these. We did keyword 3 first, which is actually the last parameter. We're putting it in as the first keyword argument. Then we have keyword 1 and then keyword 2. So down here it still says keyword 1, 2, and 3, but the value is 7, 8, 6. So when you're calling via keyword arguments, you can put them in whatever position you want. The only thing is you cannot take one of these and move it right here, for example. This is not going to work. We'll get an error. So that is your summary. Again, just to review real quick, everything on the left of the slash is position only. Anything in between the slash and the asterisk is either. And then anything after the asterisk is keyword only. Once you use your first keyword argument, you can't switch back to positional arguments. So that's pretty much it. You'll probably get a lot of practice with this as you're using different functions or creating your own. But if you have any issues, you can always watch this video or research it online. You don't necessarily have to have every little detail memorized to this. Next up, we're going to be creating another function that's going to take a list as an argument, and we're going to talk about how to work with lists inside of functions. So stay tuned for that video. I'll see you there. Hey everyone, welcome. In this video, I'm going to be teaching you how to create a function to work with lists. And why would you want to do this? Well, because we often use code to iterate through a list and do something. What if we could extract this functionality into a function and then just invoke that function whenever we need it? That's what I want to do in this video. So we'll create a function, we'll say def, and we'll call it greet all. So it's going to take a bunch of people. So we did create a greet function earlier, which greeted people, but now I want to greet every person inside of a list. So inside of the parentheses, we'll just create a parameter people, and then a colon, and then inside of here, we're going to create our function. And we can just treat this list like any other list. We can say for person in people, print, and we'll just say hello, and then we'll put in person. All right, so that's our function. Now what I want to do is create a list outside of the function. We'll just call it friends. We'll just put some values in here. And first one, I'm going to put Bob, which is the name of my invisible ghost friend from when I was younger. It's a little creepy, but don't worry about it. We don't talk anymore. And then we have just a few other values in here. There we go. And now we can invoke this. We can say greet all, and pass in friends. So we don't have to pass in each person to a function. We can just pass everyone to a function. And running this, it says, hello Bob, hello Josh, hello Austin. If you still had your greet function from a video earlier, you could invoke that within this greet all. However, I'm not going to worry about that right now. So that is how you work with lists. Now, a thing with Python is you got to be careful, and that is you can pass anything in here. So for example, I can pass in 5 and we're going to get an exception. So a different language such as Java would be like, oh no, you can't do this. There's a type conflict. However, Python don't give a crap. If you use the function wrong, that's your own responsibility, man. It's your fault. So some people like the compiling, some people like the more interpreted style. So whatever you prefer, that's up to you. But just keep in mind that when you create a function, people might use it other than you expect them to. And that is developers. Developers might try to invoke your function passing in the wrong data. So that is how to use a list inside of a function. Stay tuned for the next video because I actually want to try something new. I want to create a function where I can pass in numerous friends, but they don't have to be in a list. I just want to pass them in as strings to this function separated by commas. Similar to how the print function, you can just pass in whatever you want. I want to do that. So stay tuned for the next video. I'm going to show you how it's done. Hey everyone, welcome. In this video, we're going to be talking about a concept known as packing. So what we're going to do is we're going to pass in, instead of this list of friends to this function, I want to pass them all as strings separated by commas. So we have Bob, Josh, Austin. And we can just get rid of this altogether. We don't need this list anymore. But when we run this, it's not going to work the way we expect. It says takes 1 positional argument, but 3 were given. So how can we change this function here such that it can take unlimited arguments? It's actually quite simple. All you have to do is put a capital 8, aka an asterisk for you fancy people. Run this and look at that. Hello Bob, hello Josh, hello Austin. So that is how you create a function to take unlimited arguments. Throughout these videos, you learn different variations of invoking and different ways of creating the functions. You do not always have the ability to modify the function itself. You might just have access to invoking it. So it's good to know different ways of invoking the function as well and just be very versatile. So what we're going to do in the next video is do another variation. And with that variation, I want to flip this around. What if we have a function that we're trying to use and this function is expecting numerous arguments, but we don't have numerous arguments. We actually just have a list and we want to basically explode this list into a bunch of different values without having to do a bunch of indexing. That's what I'm going to be showing you in the next video, and if that explanation made no sense, just stay tuned because I'm about to blow your mind. It's going to be crazy. But in order to watch, you got to hit that subscribe button. Hey everyone, what is up? This video, I'm going to be teaching you how to unpack data. So how do you take a list and explode it into a bunch of different arguments? So right now I got this function and you can type this out to get on the same page with me. We're doing some string concatenation inside of a print. You can also use commas if you prefer, it doesn't really matter. The main thing here is that we have 3 parameters, name, age, and email. So let's show how we would invoke this. We would say print _ info. And then we pass some data in here. So we would say Caleb, I'm 12. Not really. And this is my email. And running this, and we get the output we expected. Caleb is 12. You can reach him at caleb@email.com. But what if we had a list of data instead? So we'll just create a list. We'll call it info. And I'm going to take this information, cut it, paste it here, highlight it, and then put a left square bracket, which will put it all inside of a list. And then I want to pass info in here. Well, this isn't going to work. Nope, it doesn't like that. So what you could do is you could say info index 0, info index 1, and info index 2. This should work because that's going to grab each of the individual elements. And that's fine. That's one way to do it if you don't want to learn any fancy new syntax. However, obviously there's a direct correlation between these positions and where we're trying to pass these in. So instead of being more complicated, what we can do is we can actually do something called unpacking, where we take a list and again, explode it into individual items. And you can kind of think of this little asterisk as a visual explosion. It's going pow in all different directions. All right, that's a terrible illustration, but It's kind of cool. All right, so you do asterisk info and run it now, and look, it works exactly the same way. So when you do this, it's basically saying, hey, the first item in the list, we want it to be the first argument. This the second argument, and this the third argument. Beautiful. All right, so I actually just took a second just to do a little bit extra research on packing and unpacking, and the first article I found used the same illustration of the explosion, and I was like, man, I thought of this myself, but it looks like I'm not the first one out there. So I ain't trying to steal nobody's cred. I did think of it, however, seems to be a thing already, but whoever thought it, brilliant. I swear that always happens. I'll be like, man, I just thought of the world's greatest invention. It's like this box, and you put raw food in it, and it comes out cooked. And then 5 seconds later, I see an ad on Instagram of a microwave, and I'm like, dang it, they took my idea. So that totally just happened. But anyways, that's all I got for you guys in this video. Sorry to bore you with my little story there. But anyways, we'll jump into the next video with a new topic. Hey, welcome everybody. This video, I'm going to be talking about creating functions that invoke other functions. Maybe this is really simple for you, but for me, it took some time just to kind of comprehend how things were executing. So that's what we're going to be talking about in this video. And I went back to the code we had from a previous video. You can type it out if you want to get up to speed. But pretty much we have this function greet all, and it takes a list of people. It iterates through the list and prints hello person for each one. And I mentioned earlier that you could replace this print with another function call. So that's actually what I'm going to do. I'm going to say greet, and then I'm going to pass in the person. And this greet function doesn't exist yet, so I'm going to create that above. I could paste the code I had from earlier, but I'm just going to recreate it. So I'll say def greet, and this is going to take a person. And in here, what we'll do is we'll create the custom message for this person. And we're actually going to return the message. So we'll say return, and then we'll say hello plus person. And you can imagine this function being a little bit more complex. Maybe we have another flag variable, maybe like first time, if it's the first time in the app. And we will default that to false. And we could case and say, hey, if this is the first time, give them a different message. So if first time, and then just return something different, such as first time for everything, right? Welcome plus person, like so. All right, because this is returning data, we actually have to do something with it here. So since this greet all, I kind of assume it's gonna print to the console. I'm just gonna do that here. So I'll say print greet person. Running this, and there you go. It prints everybody's names. And if for some reason we wanted to say that these people are all new people, we would just pass in another argument, comma, and we would say true. Running it now, and it would say first time. Now notice that this greet returns the data instead of printing it directly, which makes it a little bit more useful because we can actually get that value returned and then use it for something else. In this situation, we're just printing it, but we might be able to use that for whatever we want. We might assign it to some data that's showing up on our website or on our application, whatever it can be. So generally, you should return data whenever you can, as opposed to just printing a bunch of stuff to the console. So to understand the way this is invoked, it starts here. The whole process actually starts at the bottom. So we define the functions, but they don't actually get executed until line 12. I mean, technically, all of this stuff here does get hit first, but the functions are not actually ran until line 12. This data is defined on line 10, and that's obvious because we have to use it in line 12. When we do greet all, it goes to line 7, and it starts a loop. And for each iteration of that loop, let's say the first iteration, we're working with the first person, Bob, it does greet, passes in that person, jumps up to line 2. First time is true, so it returns this data, and then we jump back. That data is returned and is passed to print, which shows up in the terminal. And then the next iteration of the loop, we're on Josh, that same process is repeated. And then eventually it gets through all of the data, this loop finishes, that concludes this function here, and we go back to line 12. And if we had more statements after line 12, it would continue going. So hopefully that's not too confusing. Just get some practice working with functions that invoke other functions. Again, just try to think of it as a black box. We don't have to worry about this greet a whole lot. Just pay attention to this function here. All we care about is that this greet function works and it returns some data to be printed. And then if you're looking at it from this point of view, we don't care at all about the functions. As long as the greet all works, we're happy. lots of information on functions, and it's going to be the basis for pretty much everything else we get into in Python. So stay tuned for the next video. We're going to do a quick review of everything we've talked about with functions. Make sure you got it all down good, and then we'll move on to something new. Hey everyone, welcome back. This video, we're going to summarize everything we learned about functions, and I have to say, first off, congrats for finishing this series. I'm honestly surprised. I didn't think you could do it, but you should continue on because this actually isn't the end. We're going to be producing a whole lot more content on this channel, and as we speak, I'm working on a next level Python series right here. So if you enjoyed this beginner Python, then you can check out that next Python. But anyways, we're going to review functions, conclude with a nice happy ending, and we'll all cry, go home, and it'll be a great memory. Yeah. So I'm going to copy this, bring it over to my text editor, run it, and just make sure everything is Gucci. All right, so we run this, we get a ton of output, and we're just going to work our way through this. So very first thing is I talk about how to create a function, and the main point of this is to encapsulate multiple statements in one word called greet. So then we can invoke greet numerous times, which are all these outputs right here. Next thing is we learn how to parameterize our function. And when we do this, we create a variable inside of the parentheses of the function declaration, and we can use that in here. We don't know what the name is ahead of time, so we refer to it by its variable name, and we can pass in that data as an argument. This is an argument, this is a parameter. Think of an argument as a value, a parameter as a storage location for that value to be used within the function. You could also pass in a variable. In that situation, the data is copied to the parameter. Next up, we talked about a return, which can be used to exit a function. So we're creating this greet function. If your name is Claire and under no circumstance are we going to greet you, we return. Otherwise, we do some other stuff. This else can actually be removed eventually, and we show that here. We can just put it here because there's no way to actually proceed to line 52 in this situation if the return is hit. We can't get to 52 if the return is hit, so we can actually just get rid of the else because we don't have to worry about these executing in any circumstance when this is true. If for some reason we were not returning here, then you would need the else, and I call that out right here. Next up, you can actually return values. So if we are returning data instead of just printing it directly, well then we can say return, and then that string can be used by the caller. So we're greeting Sal right here and printing that right here. So we'll find that in our output. Hello Sal, welcome to my app. If we happen to pass in Claire, which it also shows that we can use the greet inside of the print, it's going to say go away. Next up, we talked about default arguments, which if you don't pass something, it's going to default to something. So in the case we use user, if we just say greet with no argument, it's going to default to user and say hello user. Next up, we talked about making multiple parameters. So we have a name parameter and a be nice parameter, both with default values in this situation. And here's just two examples of invoking this. The first one we pass in Caleb and true, and then the next one we just pass in Caleb. They both work, but when we do not pass in true here, it says go away Caleb instead of welcome to my app, like this case here. Next up, we talked about keyword arguments, which allows us to be specific about what parameter we are trying to assign to. So in this situation, we are assigning true to be nice, which allows us to skip the name parameter altogether. We don't have a name value there. And in that situation, it just defaults to user, and it works because we are using the name be nice. Next up, we talked about positional or keyword arguments. So in this situation, you can do it positional like so, and that's where this output here comes from. Or you can do it by keyword, and in this situation, just to show you guys, I put them in the opposite order. So be nice comes first, and then the name comes second, and the output is exactly the same. It says hello keyword, welcome to my app. It's a cute name, by the way. I think I might name all my children keyword. If for some reason you tried to use a keyword first and then a positional one, that's going to give you an error, so do not do that. So what you can do is you can actually restrict to either positional only or keyword only. If you want to do positional only, anything before a / is going to be positional only. So in this situation, you have to pass both name and be nice by position, such as right here, which we did correctly. If for some reason we tried to use this, we would get an error. You can put the / between arguments. It doesn't have to be at the very end. So in this situation, you can use name positional, which you actually will just put first there. And then you can assign to be nice either by assigning to it here or just doing a positional like so. It doesn't add a lot of value right here because we're not working with a lot of arguments. It would make more sense just to do it by position. However, sometimes it's useful. And the other option is keyword only arguments. And in that situation, anything after the asterisk is by the parameter name only. So we have to say be nice is equal to true. If you try to do positional like so, you're going to get an error. Now to review all this, just because it's a lot of information, think of a really complex example where all of the positional ones are on the left, then we have either, and then the keywords. And we went through the same exact example because I copied and pasted. You put all the positional ones when you invoke it on the left. The either ones coming in the middle, that's where these come in. So the 4 goes to either 1 and the 5 goes to either 2, which we can see in the output right here. Next up, we got the keywords, and just to show you guys, I put them in a different order. So we assigned a keyword 3 first, then 1, and then 2. And you can see them and what values they are by looking right here. Whatever we assigned. So keyword 3 is 6 right there. Keyword 1 is 7, which is right there. And then keyword 2 is 8 right there. Then I got some notes here. If you want to bore yourself, go ahead and read them. Next up, we talk about lists. Very simple. You can iterate through the list like a normal list. Assume you're getting past a list when you create the function, because it's ultimately the caller's responsibility to pass the correct data to get the function to work properly. So that's my opinion. I mean, if you wanted to do some type checking in here, you could. However, just make sure you use the function correctly. So we pass in a list of people and it works fine. It says, hello Caleb, hello Josh, hello Austin. Here's an example of unlimited arguments where you can actually pass in all the data separated by commas. The only difference here is you just have to put the asterisk here. Next up, you can do the opposite where you take a list and pass it to numerous parameters by putting the asterisk on the calling side. And then lastly, we have an example of functions calling functions where we have this greet all function and it invokes this greet function for each iteration of this loop right here. So that's another way you can simplify your code, kind of separate things out so you can better unit test or whatever you need to do. You invoke it pretty much the same way though. You just say greet all and you pass in all the people as a list and it works. And that's where we get all this output right here. So that's a pretty big summary. Hopefully you understood everything in that. And that concludes our beginner Python series. Oh wait, I think I just had a brain fart. We're only on video 99, aren't we? Caleb, what did you do wrong? Well, I think I'll take the next video just to kind of go over what we talked about, just a brief summary, and then go into what we're going to be talking about next. Hey, welcome everyone to your final video in your beginner Python series. Congratulations. That was me clapping. And now, what in the world are you supposed to do with your life? Now that you're like senior software engineer level, nah, I'm just playing. We got a lot to go, but we did cover an awful lot. Yes, this series may have been a bit slower than some, but I also tried to go through numerous different scenarios and go in a lot of depth. All of the things we talked about are the fundamental building blocks for Python as well as pretty much every programming language. So not only have you developed skills in Python, but picking up any other programming language should be a lot easier. We're pretty much just going to continue right where we left off in the next series, which is just probably going to be called Python Programming. And in that series, we're going to try to start piecing these principles together to make some more complex applications. Now you know how to manipulate data, you can start working with different data to do different things and start building apps rather than just silly little functions that greet people or whatever it is. It's kind of like the Legos. You understand what each Lego piece does. Now you can piece them together to build a functional Bugatti, drive it down the street, impress your friends. That's what the upcoming series and maybe even more series is going to be about. How do we take all of these skills and bring it to the next level? So I'd encourage you to check out that, and just thank you so much for staying with this. It really means a lot. And if you haven't subscribed, it means the world to me, and peace out.